you guys covering how much trees.
Any questions?
I'm going to collect on side. Yeah.
Well, you can collect it on slide, or you can also do it on the webinar.
We go right. Oh well, don't use the laser pointer. Use the mouse if you are, because people online won't be able to see the laser. And we have a clicker, or you can use backwards and forwards on here. Yeah. Oh, if you present from here, because the microphone's here, so that means people online will be able to hear you. That's perfect. You can shut down. I've got it. Yeah. In which case.
Yeah.
My client thing seems to be working. It's broadcasting on YouTube. We've got 150 people online so far. So.
Well, I'm not going to say that. I'm going to say we've got nearly 700
about
registered.
1,000 people online.
Mike, should this be moving on?
Should be.
Always helps.
Try that. There you go.
Thank you.
We've got a few more still coming in, and this is I think we did
There's an easy.
Okay. Okay. Good morning, everybody. Welcome to the Cable Awareness Workshop. Just to introduce myself, I'm Clive Spencer. I'm the Director and Company Secretary of ESCA. This event's been co-hosted by ESCA, Crown Estate Scotland, the Crown Estate, and kindly hosted here by the NOC. In terms of the purpose of the workshop, which is on the agenda, I won't read those items, but the purpose of the workshop and the objective and the outcomes are there for you to note. In terms of attendance, unbelievably, we have 130 in person, but near to 700 have been registered for online. We certainly didn't expect that. So it may be a little bit tricky to manage, but it's an amazing response that we've had. I'll be introducing each agenda item as we go through the agenda and requesting the presenters to come up and speak. A very big thank you to all the speakers. It's very much appreciated for you attending and giving your time. In terms of questions, it is an interactive workshop, but we're running to a very tight schedule, and if we go into a Q&A after each presentation, it may well be difficult to keep to the timings that we've got on the agenda. So what we're asking is if you can submit your questions via Slido, and you also, for the people online, you can also submit via Slido or on the actual webinar itself. So if we can do that, if we have time, we've got a Q&A session at the end of today, which we can take some questions. There's about an hour and a half maybe and we also have our wonderful sustainable notebooks and pens where you can take notes and write down your questions. But and we also have the breaks where we can have some networking sessions, and if you have any questions for the presenters, you can ask them during the break. We also have these wonderful coloured lanyards, which as you probably saw as you came in, the green ones are 0 to 2 years experience, the yellow is 2 to 5, and the over 5 years is red, but some of us are over 30 or 40, I think. So, so yeah, if we do that, and questions that are asked via the Slido or webinar, we will take note of all those questions after the event and respond accordingly and compile a list of answers to those questions. We do encourage networking during the day, so just talk to anyone you don't know, especially the people in red, because they have all the experience. So please, we do encourage that. So with that, I'll now pass over to Mike, who will give the introduction from now on.
Real, thanks very much, Clive. Really great to see so many people here and great to see so many people online. It seems like technology is working for us at the moment. So we're streaming live to YouTube, we're streaming to several hundred people on Zoom. I'm really pleased to have so many people here in person. So myself, Isabel Yo, and others from NOC are really pleased to welcome you to the National Oceanography Centre. We are an independent research organisation, and our research focuses on understanding the ocean, understanding the health of the ocean, understanding what goes on in the ocean. But a key important part of what we do is trying to make sure that any activities that occur in the ocean are happening in the most sustainable way possible. And so it's really kind of motivated having this meeting here for those of you who are at the plenary. So we're really pleased to welcome you to the NOC. I've also got some boring housekeeping things, but important. For those of you that are here in person, if there is a fire, then you will see fire exits marked behind you. Follow people on your way out through. There's a muster point in the car park outside. Things should be obvious there. In terms of toilets, if you come out of the room, turn left and go down the stairs. There's both male and female and disabled toilets there. If you need others, then just speak to myself, Izzy, or Alice on the desk, who will be able to sort you out with that. For those who are attending online, if there are any issues, if you could write any questions in the chat box, then we'll be able to check that, particularly if you lose the audio or you lose the video feed, for example. But keep an eye on emails just in case you drop out, and Claire and John from ESCA will speak to you about that. And just for presenters, anybody who is presenting, we could make sure that if you're in person, you stay at the podium, because this is where the microphone is. This will give the best quality audio for the many thousands of people who are coming in online. So I think from my side, that's everything. And just a big thanks again to everyone for coming, and look forward to some really good discussions today. Thank you.
Okay, thank you, Mike. Okay, I'd like to invite Peter and Alice to come up and give a welcome introduction for ESCA and a Van Estate perspective.
Morning, everyone. My name's Alice Ramsey and I work at the Crown Estate. And I'd just like to join Mike and Clive in extending our welcome to their workshop. Thank you for joining us. It's been phenomenal to see how much interest there's been in the event. Before I hand over to Peter, just a couple of things from me. We started this event back in 2018. We've run it a number of times. The first one, it was just a handful of people in person, and it's really evolved since then. During COVID, it went online, stayed online, and this is our first hybrid in-person and online event. We see there's huge value in bringing together experts from industry, SNCBs, regulators in this knowledge sharing workshop. So thank you for joining us. Just one other thing is just to say, please do leave us feedback. You'll see on slide there are two tabs, one for the questions and answers, or submitting your questions. The second tab has a poll, and there'll be some quiz questions in a minute, but also a feedback survey. And be really grateful, even if you're only with us for a short time, if you could, before you leave, just log on to that and leave your feedback. It would really help us to evolve the event for future workshops. So I'll hand over to Peter now.
Good morning, everybody. My name is Peter Jameson. I'm the Vice Chair of ESCA. And as someone who's been involved with ESCA and its forerunning organisations for a number of years now, it just gives me a great sense of pride to see how these events have increased over the years. And it's great to see all you guys here interested in the industry, interested in the sector, wanting to know more. So thank you for coming. And with that, I think we'll get on with it. So I think it's quiz time, is it? So that's your Slido QR code. If you haven't already got it, it's just, and we're going to do this in real time, so we should be able to see the answers come up in real time. Right, we're away already, are we? I didn't get to do my Jimmy Clarkson, who wants to be a subsea cable expert, sort of thing. So, what is the approximate diameter of a deep water international submarine telecoms cable? And I think we can see there's a definite winner there. And the correct, it is approximately the diameter of a hose pipe as it goes transoceanic. Get a little bit thicker as they come on the continental shelf, but yeah, about 20 centimeters or so. So well done, everyone. How long is the longest subsea power cable in the world currently? So yeah, people obviously know the power cables in this room. So that's correct. 765 kilometers, and that is the Viking link that connects us to Denmark. How much of the world's intercontinental traffic is carried by submarine cables? Look at that. Oh, who's let me down there? Correct. 93%. So, is this wonderful picture a cross-section of a communications cable, a DC power cable, or an AC power cable? And that's right. It is, in fact, a AC power cable, three-phase, and that is a section of the Wolf Island export cable, which is off the coast of Ontario, Canada. What is the biggest cause of damage to submarine telecommunications cables?
Yes. Good answer.
Oh, cool.
Sharp eyes.
It is indeed human activity, fishing, anchors, definitely not sharks. The odd earthquake. Cool. So which type of subsea power cable is likely to be longest in length? Would that be an inter-array cable, an export cable, or an interconnector cable? Well done. Yep, it is an interconnected cable. And that's it. So, well done on the quiz. I think most people got the right answers there. Well done. Back to the slide there. Right. Okay, so now I'm just going to give a very broad overview of subsea cables. We're going to go into a lot more detail on certain aspects of the sector throughout the next couple of days. So this is just to give you a taste of what the sector's about. So as we said in the questions, we carry more than 99% of global communications. A very famous figure is that subsea telecoms cables carry in excess of 10 trillion per day, and that figure is probably more than that. That figure must be about 15, 20 years old. The latest technology, most modern cables can carry 400 terabits per second for a single cable. Now that seems like a lovely number, but what does that actually mean? Well, that is, imagine you can download 8,000 Blu-ray discs per second, 100 million MP3 files, or 300 million photos per second is what 400 terabits works out to. What value can you put on social global connectivity? I mean, it's not hyperbolic to say that without subsea cables, without the internet, without global connectivity, the modern society wouldn't be able to function the way it does now. And that's only in the last 35 years. And people always say, well, what about satellites? Well, satellites have their place, but the entire capacity of Starlink was about 79 gigabits per second. So that works out to about 20% of one cable. So satellites are okay for reaching remote communities or restoring some services in an emergency, but they cannot replicate the amount of capacity that subsea cable infrastructure carries. And as I say, it's vital to almost every aspect of modern life. So telecoms cables, economy and trade. So you enable about 545 billion in exports. The government did an exercise, and they reckon that if we had a loss of connectivity for a severe loss of connectivity for 30 days, we could lose 22 billion to the economy. Social media, love it or hate it, but it wouldn't be possible without subsea cables. Home working, we realised how important that was in the COVID years. Subsea cables kept businesses going. And then home shopping, the ability just to go onto the internet, find something that you want anywhere in the world and order it online. And then the next big thing that's going up is AI. We don't know where that's going to take us. That's the new frontier, and that's all going to be enabled by new cable infrastructure. So cable charging awareness. So that's a quick look at the amount of cables, telecoms cables around the UK and Northern Europe. Now it looks very congested there, but you've got to remember that those lines are about 3 miles wide. So it's not as bad as that. And we have ESCA is the regional trade association for subsea cables, and there's other associations around. There's obviously the ICPC, which is the global one, and then you got NASCA, which is the North American version, and DKCPC. The Danes have their own one as well. And that screenshot is from Kisorka, which is the charting tool that ESCA manage, and we'll be talking a bit more about that tomorrow. So cables are always under threat from some issues. I mean, obviously, if you've been keeping up with current events, you realise that the Baltic is a bit of a hotspot at the moment. But cables are damaged with depressing regularity. Usually, the damage on average about once every 3 days. Usually about 100 cable faults per year, and the vast majority of them are through commercial fishing and errant ships' anchors. We do have issues with geological issues, earthquakes and turbidity currents, mainly around Asia, although off the west coast of Africa has always been an issue. Not so much in the north, but cables from the UK go globally, so can still impact traffic to the UK, incidents around the world. Definitely not sharks, though. Sharks do not damage cables. So when you're thinking about installing, routing and protecting cables, you want to bury them deep, and you can use various tools around. So the screenshot in the middle is an example of fishing effort around the UK. So if you're planning a cable, you try to avoid the areas where there's a lot of fishing, or at least if you're going to go through those areas, make sure you protect it properly, get it very deep. Likewise with the one on this side, that's a screenshot of the AIS traffic. So that's all the main shipping traffic. So you can see as the shippings come through the channel, those two very bright lines, the shipping channels. So obviously, if you're going to cross the channel, you want to make sure that as the cable goes across those bright lines, again, you want to make sure it's deep in case a ship loses its anchor and drags it for a while. The picture in the top corner there is a picture of a plough. So that's how we bury cables. And then the one below that is how we bury cables in areas of mobile sediment. One solution, not the only solution, but one solution is to take off the top of the mobile sediment and bury it below that. Repair capability. So when a cable does get damaged, we've got to be able to fix it. And we do that with various ships around. There's various consortiums. There's the ACMA, which is the Atlantic Cable Maintenance Agreement, that has 3 ships that cover the North Atlantic and something a bit towards the south. The APMA, which is the Atlantic Private Maintenance Agreement. They have ships or several ships all over you can call on. So you've got to make sure that there's no regulatory impediments that would delay a cable repair, and that's one of the reasons that ESCA exists, to make sure that there's no overreach by various governments to that would prevent us from repairing cables when they become damaged. And also, if you have multiple incidents and multiple damages, the sector may have to cooperate and how best to use the repair ships. They're a finite resource, and so you need to make sure that it's managed well. So I'll now move on to subsea power cables, and I didn't put these one slides together, but the slide over there says powering the world. I don't know about powering the world, but they certainly power the UK, because there's a lot there. So these are all the interconnectors. There's this is not including all of the wind farms and wind farm export cables. I couldn't put them on there, and you couldn't get the granularity of the screenshot to show them all. But these are just the interconnectors, and there's wind farm and export cables all around the UK and Europe as well. So they're becoming more and more important to the energy security of the country. Vital to distribute energy to island communities, especially up in Scotland, and an 900 megawatt capacity to supply 1 million households. Interconnectors are really important to balance the power between countries. So when a country is producing too much electricity, well, not too much, but a lot of electricity, they can then sell it to other countries who need it, and electric traffic flows both ways. And as mentioned in the questions before, the longest subsea power cable in Europe is the 765 Viking link between UK and Denmark. So there's two types of technology mainly in power cables. There's the high voltage alternating current and the high voltage direct current. The way I'm not a power cable expert, so but the way I actually think it is DC long distance, AC shorter distance. So a lot of the wind farms around the UK that are fairly close to the coast, they will have AC export cables, whereas your interconnectors that are going from the UK across the North Sea to Norway and to Denmark, the direct current cables. The UK power grid is AC, so they're easy to connect straight into the power grid. Whereas if you're using interconnectors with DC, they need converter stations at either set end to convert the current from DC to AC, and the fairly big installations as well. So, as in that question earlier, the AC, I'd say, is usually a three-phase conductor, and the DC is usually a single conductor, but usually in a bundle. So you'd have two of those cables next to each other, generally speaking. Or you could even have them in a coaxial arrangement where you have two conductors in the one cable. So power cables and telecoms cables share many things. You know, the route design and planning is just as important with power cables as telecoms cables. Power cables may be a bit more constrained as to where they can land, because a power cable usually has to land to a grid connection point somewhere close to a grid connection point. So you don't want to be landing somewhere miles away from the grid connection, then have to bury the cable on land a long way, because that's really expensive. It's probably more expensive than laying it out at sea. And obviously maintenance and repair considerations are definitely different from power cables to telecoms cables. If you have a damaged telecoms cable, you can expect that to be repaired in a matter of days. If there's available vessels, power cables are a lot more. And there's experts in the power sector will be on later today and tomorrow to explain that a lot better than I can. So in summary for the power, it's rapid deployment of renewable energy. You know, the wind farm boom is not looking to end anytime soon. There's lots more wind farms being built, and we need the power cables to deliver the power from the wind farm back into the UK. And the maintenance and repair considerations are different for power cables, and that is a growing industry topic, leading to what to do when the power cable is broken, how to get it fixed a bit quicker. So that is a very broad overview of the power sector and the telecom sector, which I hope just hopefully get you in a bit gently into what we're going to be talking about over the next couple of days. And with that, I will hand back to Clive.
Okay. Thank you. Thanks, Peter. Okay. Next item on the agenda is some of the project design. We've had some presentations from Nick Smith, Dave Sutherland, and Andrew Palmer-Felgate. So the first presentation is from Nick Smith. So I'll give that, Nick.
Some mood lighting.
Thank you.
Right, good morning everyone. For those of you who don't know me, my name's Nick Smith. I work for Google. I'm going to be talking this morning about, the title is Desktop Study. This is actually focused very much on the telecom sector. I'm hoping that Dave, who follows me, will cover the equivalent topics for the power cable sector. So the first point I'm going to make is that a submarine cable, it's perhaps obvious, doesn't exist in isolation. You know, a connection beach to beach doesn't actually solve any business problems. So when we start to think about a new cable system, the first question you have to think about is what business opportunity is the cable going to address? And I've listed some examples here, and then I'm going to, in a few moments, try to make these a bit more real with some concrete examples. I'm going to show you how the business opportunity you're trying to solve drives some aspects of the cable design. But how, and not only is the business case important, but also how are we going to connect with terrestrial networks? Because that's the starting point for determining landing point locations. Just to carry on with some general principles before we dive into the examples, just as we go through the examples, bear each of these ones in mind, and you'll probably start to see them popping up. There's a reach. We need to get to where we want the cable to go to. Some cables systems will think about, can we add a branch? If we add a branch to another location, does that improve the business case? There's connectivity. If we land in a similar location to other existing cables, that might allow us to transfer traffic onto those cables. It might give us opportunities to either sell fibers or have redundant networks. Key issue, of course, is security and reliability. And here we're thinking about natural environmental threats. We're thinking about human threats, fishing, anchoring, bad actors, a very prominent topic in the news these days. And also, particularly in an international environment, we're thinking about political and regulatory issues. Can we get a telecoms license in a certain jurisdiction? Or are we going to have to work with a local partner? Is there a risk that an asset could be nationalized or otherwise its use impeded by a government? Now, almost the converse of connectivity is diversity. If we build too many cables all landing in the same place, then there's a risk that they could all be damaged at the same time, either by a large ship dragging an anchor or some other issue. So if you build in a completely new route, completely new location, that adds diversity to your network. It might be an attractive proposition if you develop a new route to sell capacity to customers or other operators. A slightly corner case, but we're going to look at it, is latency. How long does it take the signal to transmit from its origin to its destination? And finally, of course, we can write a long wish list of lovely attributes we'd like our system to have, but we're going to have to fit it all within a budget. So here are some examples. All the information on these sites is public domain. I've tried to give you the references, so if you want to look in more detail, you can see. So TampNet is an operator who primarily provides services for the offshore oil and gas renewables markets in the North Sea. I don't know if you can read the slide writing on the legend here. So basically, they have built a backbone network through the North Sea that passes as many oil and gas offshore platforms as possible. Red lines are actually microwave links from those platforms that allow them to extend their reach. Where are they going to land? Well, it's fairly obvious, where are the onshore control centers for all those offshore oil and gas platforms? Answer, they're mostly in Norway, or in Aberdeen, or probably around the London area, and again in Rotterdam. And so that drives them, of course, to connect to where they're close to where their customers are. And then they've augmented their undersea network with terrestrial connections, which provides resilience. So if they are cut on a backbone offshore, they can actually route the traffic around the other way and back on their terrestrial network. Now, let's get to a slightly more ambiguous problem to solve. Since I work for Google, this one's close to home. Google's European data centers, this is all public domain, are mostly in the Low Countries, Denmark, Scandinavia, because that's where we can get affordable renewable power. We also, of course, have lots of data centers in the US. We need to interconnect them. And so how are we going to do that? Well, we built 3 transatlantic cables in recent years, and I'm just going to talk you through the pros and cons of each of them. Before I talk you through the solution we have found, let me point out one solution we haven't employed, which is actually to route directly up the English Channel and land somewhere in the Low Countries. And if you think back about slides Peter presented, and if you think about the map of fishing activity, you may remember it had huge hotspots in the English Channel. If you combine that fishing intensity with some of the seabed conditions in the English Channel, that gives you a very adverse environment. And about 20 years ago, people did build some cables up the English Channel. They've not had good fault histories. So let's have a look at the solutions we found. I didn't mean to go back. Okay. This green line up here is Havfru. Okay, so it comes round the north of Scotland, lands in Denmark and Scandinavia. So lands pretty close to our data centers. That's great. The problem is, let's look at where the edge of the continental shelf is. It's out here. There's a very long route on the continental shelf. And remember, building a cable on the continental shelf per kilometre is about 10 times more expensive than building one in mid-ocean. It's also, the weather up there is pretty horrendous in the winter. That impedes maintenance and installation activities. There's all the oil and gas infrastructure you've got to cross. And finally, you're crossing multiple jurisdictions. You know, Scandinavia, UK EZ and Irish EZ, and you've got to get all those permits. So that's one option. Now, the brown line here is Dunat, which lands in France at Saint-Hilaire. If you look, one of the great things about that is it's very close to the edge of the continental shelf. You only got to get out about 100 kilometres and you're off to deep water. The disadvantage is it's a long way from our European data centres, and we've had to build a long backhaul route. Backhaul, for those who don't know, is a term for a terrestrial connection from the cable landing station to the endpoint to get there. Finally, there's Grace Hopper. Now, Grace Hopper, it has a branch to Spain, which has similar considerations to landing in France from our perspective, but they're amplified in terms of the route back to the data centres. It's got the UK landing, which is a bit of a happy medium. The route to the edge of the continental shelf is a lot shorter than the route, the Havfru route. Yes, we've got a way to go to the data centres, but we can leverage existing network assets, which in the UK are quite dense due to the number of other submarine cables that land in the UK. So that shows you how there are three very different solutions. We've actually built all of them, and that again takes us back to diversity. Now, here's another transatlantic operator who has a different business case. This is Exeter Infrastructure. If you look at their website, they're quite very upfront about what their unique selling point is. They say they are the lowest latency link between New York and London. And they are very much targeting financial traders whom a few milliseconds latency advantage is absolutely critical. And that means they literally need physically the shortest route, because latency, which is time it takes signal to reach one end cable to the other, that's determined by laws of physics and the speed of the light in an optical fibre. So on this top slide here, that red line is the theoretical Great Circle. That's the absolute shortest route you could ever build. UK end, you'll see they've got three cables. Again, diversity, they've chosen one to route around the North Island, two route around the South Island. But then when you get to the US end, they do something very unique. This pale blue area on the Google Maps image is the Newfoundland Grand Banks. That's the continental shelf, heavily fished, cable has to be buried. Almost all transatlantic cables go around the southern end of that prominent tip, and they stay in the deep water, and they come in and land in either New Jersey or New York. Exeter, because they want to stick close to that Great Circle route, they come in across Newfoundland Grand Banks. They've got a landing at Halifax, Nova Scotia, then they have an interlink down to New York, all on the continental shelf, all buried, expensive to build, vulnerable to fishing and anchoring, but it gives them that lowest latency link that is absolutely key to their business case. So there you are. Different business cases can lead you to different designs. Now, just starting to circle in a bit, I'm onto slightly more micro level decision making. Once you have a rough idea where you want to land, which country, which part of the country, you need to find a landing point. That's actually really complex because we need a cable station, a building to hold the equipment in. That could be an existing or could be a new build. Wherever it is, we need an industrial build, an area that's suitable for light industry to build a sort of warehouse type building. Of course, close to the coast, you've got lots of protected landscape or high value residential areas. Not actually that easy to find that. And then it's got to have a good grid power supply capacity. We need to connect our backhaul network. So is there an existing backhaul network? Then we need to look at what's called the front haul between the cable station and the beach. How long is it? You know, we try to keep them down under about 10 kilometres, possibly can. Is there a public route, a public road on which we can easily get permission to dig a trench, put ducts in? Is it urban or is it rural? An urban area, you may suffer from interference, or there's much higher risk that you'll get accidentally damaged by somebody else's construction work. Come down, we're looking at the beach. Who owns the beach? Can we get permission to put a cable on it? How deep is the sand? Can we bury the cable? Is it subject to erosion? A beach that's subject to erosion, your cable's likely to become exposed. How heavily is it used by tourists? If it's heavily used by tourists, you probably are not going to be able to conduct operations in the summer season. And there's environmental concerns. Are there sensitive habitats? Are there sea defences? Is there good access? Can we get machinery onto the beach easily? And then finally, you come to the offshore approach. What's the seabed geology like? Can we bury the cable? How deep is the water? Can we get a cable ship close to the edge of the beach? What's the fishing and the anchoring like? What's the currents? What's the protected areas? What's the permitting? So very complex environment. Unlikely to be one perfect answer. And somewhere along the lines, we're going to have to strike some compromises. Now, to try and answer all those questions, we commission what's called cable route studies. A cable route study is a very fat volume of paperwork supported by a lot of geographical information, often supplied in as GIS files. So we look at all the publicly available information on the environment. We'll probably go and visit potential landing sites. And then we define a route between the landing points that we'll investigate during the marine survey. The information that comes out of cable route study, it's not just used for route planning, it's also used for installation planning. What's the weather like? What's the current like? As I say, lots these days of geographic information system use, largely public domain information, but also some specialist data sources. And so what are we looking at? We're looking at geology, we're looking at the oceanography, we're looking at biological factors, we're looking at hazards, restrictions, you know, the anchorages, the UXO risk. And then we're at a top level, we're probably taking a first pass over the permitting for the system. Who has jurisdiction? What are their outline processes? And then before we actually go out and survey, we've got to define a survey line. Survey. Now in mid-ocean, here I'm talking off the edge of the continental shelf, cable's going to be surface laid. Going to be trying to minimize our route length, come back to the great circle route idea. Ideally, we'd like nice, flat, benign seabed, probably deeper than about 2,500 meters of water. We want to cross the ridges and the slopes perpendicularly to minimize the risk of geological faults due to slumping and turbidity currents. We need to maintain separation from other cables, because if we're too close to someone else's cable, then neither cable could be maintained. And there's still some hazards out there in mid-ocean. The UXO dump areas, it could be geothermal active regions, and there could be seabed mining sessions. And you also need to think about whose waters you're passing through. Sometimes it may be worth taking a slightly longer route just to stay out of the country's EEZ if you're not going to land there. And then finally, we also actually have to think about some installation limitations. You know, our cables can't turn 90 degrees because it's not possible for a ship to lay a right angle at sea. The continental shelf, most of those considerations for mid-ocean routing are still valid. As I said before, minimizing the route length to the edge of the shelf is often a key topic. We try and exit the shelf perpendicularly down the slope, try and follow a ridge down the slope, not a valley, because if you're in the bottom of a valley going down the slope, any sediment movement is going to accumulate, funnel into that valley. The default on the continental shelf is that burying the cable, so looking at seabed sediments becomes a consideration. The environment typically is more crowded than mid-ocean, and there's a lot more hazards: fishing, anchoring, offshore renewables, stand waves. And I hope the route engineering exercise we're going to do later on today actually makes some of these things a bit more real and tease out more of the details for you. So that's all I've got. Hope I've got the time.
Yeah, thank you. Thank you, Nick. Yeah,
And I'll hand over to Dave.
Yeah. Hey, yeah, next topic is power cable survey and planning by Dave Sutherland.
Hi, good morning everyone. My name's Dave Sutherland. I'm the Senior Marine Consents Officer at National Grid Ventures, which means that I have the dubious honour of looking after our permitting and environmental conditions on our existing cables and the ones under development. So I'm going to talk a little bit about some of the surveys and planning that goes into how we come up with a route, how and what look at what informs the route, and sort of talk through the whole process. So National Grid Ventures is in the interconnector business, so we tend to build between the UK and France, Norway, Netherlands, Belgium, and we have other cables that are on development. Repeating those, I think you saw earlier that there was the Viking Link cable, which was finished in December 23. It's the longest one in the world, and that's the bottom image there is the landfall in the UK as it came on shore. So how do we start with planning our routes? Right. So I think Nick touched on we have to have landfalls, and then at the moment we're looking at not necessarily an interconnector, but also can we connect to an offshore wind farm, like a multi-purpose interconnector. So we go either straight to another country, maybe we go to a wind farm halfway, and then the wind farm then has two options to send its power to the host country or back to the UK. Then once we've got, I'll go into these in detail a bit later on. So you've got your starting point, your end point, and then we put up a indicative corridor. Usually engineers love a straight line, so it's going to be a straight line until everyone says you can't actually, like there's things in the way, you can't do it. Desk studies, again, touch on those. There's also some guidance, there's some ESCA guidance. There's also there's some other guidance as well. We've used the ESCA guidance on a number of our cables, and it's worked with us pretty well. Survey corridor is usually the next step. So you've got your start point, your end point, you've done your desktop studies, you've got a rough idea of where your cable's going. You go off and you do your offshore survey. Usually you start with quite a wide corridor, certainly compared to onshore cables where the corridor is typically a bit narrower. And then you do the offshore surveys, you go and talk to fishermen, you go and talk to other people, regulators, statutory nature bodies, to see if they have any data or any concerns about where you're going. You do some more assessments, this time using actual data rather than publicly available data, and then you tweak your route alignment. So these are some data examples from one of our cables. This data was collected earlier this year. You probably see some nice sand waves in the bottom, but why do we go and collect survey data? Number of reasons. It helps us find, the most important is basically, we don't want to route through stuff that either is going to be very difficult for us to install a cable safely, or it's going to flag up bits of the seabed that contain sensitive environmental features. So subalarea reefs, biogenic reefs. We might go through some fishing grounds. We might find an undiscovered wreck. We don't want to lay our cable through it. So we go out, we get the data. I'll touch a little bit on the surveys, the types of surveys that we do on the next slide. But again, you can see sand waves, and I think Jamie's mentioned pre-sweeping in his very first presentation. So we would have to, if that was the final route, we would have to sort of flatten out some of those sand waves so that we could lay the cable safely. Again, published data, public data sets are not always the most up to date. They may be at maybe a very coarse resolution because they're covering a wide area. That maybe they're regional scale surveys. That corridor that you can see there is about 500 meters wide. Obviously, it's a very narrow strip through the North Sea, and you won't always get like the level of detail on the sand waves that you see there with a regional scale data set. And again, this is all building on, I guess, the base plate of your desktop study, where you sort of we think these are the key sensitivities. Then we go out and actually get the information. So this is just a list of the typical types of sediment data you can get. So sediment types will inform things like how the cable's installed. Do we need to use a cutting tool? Do we need to consider rock placement. It might be if we're doing pre-sweeping, that we have to consider sediment contamination. We don't have a cable landing in Newcastle, but Newcastle's been a port for a long time. There will no doubt be contaminants in the sediments around there. If we had to do some pre-sweeping, it could end up stirring up contaminants. Seabed imagery, we've got some nice pictures of some seabed mussels and some Sabellaria. Both of those are protected habitats under UK legislation. So if we found them, we would try and route around them, basically. So they would A, be difficult to route through, and B, right, they're nice. Why would we go through them? So we go around them, microsite around them. Fishing efforts, location, type will all play a part in how the route eventually is tweaked between the landing point and where it ends up. And if it's a heavy like potting area, it's slightly less risk than if there's people doing scallop trawling. So just the types of gear mean that, again, it will influence where the route goes. We've had one of our cables where the fishermen flagged a previously unknown drift netting area. So we've tried to route around that so that we have as low an impact as possible on them. Aggregates, Crown Estate licensed marine aggregate areas for extraction. Probably a very high no-no for putting a cable in. You don't want to put your cable in where there might be dredgers going up and down, sucking up the sand that's covering your cable. And then I think I touched on Rex, and somebody else I think mentioned the UXO. I think Nick's mentioned UXO surveys. So again, there's a lot of things that we do in the surveys. We'll collect data on potential UXO areas. Again, marine archaeology is an important part of what we do, so we don't want to route through historical features. So this is a hypothetical situation. We've got the new lightning bolt interconnector. It runs from Southend-on-Sea to the other side. I can't remember where I put it to. So this is, the engineers have come up and said, right, we want to build our power cable across here. It's nice and easy, it's a nice short distance, straight. But then this is just the publicly available layers of what is out there at the moment. So we have shipping lanes, we've got cables, we've got wind farms, we've got aggregate areas. We have, you'll notice it may just clip the French jurisdiction halfway across the North Sea. So the red sort of speckled areas, designated areas, either they are special areas of conservation or marine conservation zones or special protection areas. This particular one doesn't cross any highly protected marine areas, which are the latest or the most recent type of designation. So suddenly our nice straight line the engineers have given us is causing ruptions in the permitting department or the environmental department. So like, no, we can't do that. Can't do that anymore. So then your cable ends up shifting to try and cross it. So you'll see that it leaves Southend-on-Sea, tries to go straight out into the Thames estuary. It will then track up the outside of one protected area, so we don't go into it. Ducks down underneath the wind farm, although it does cross the export cable route. We try and cross cables at 90 degrees. Scoops around the brown aggregate site. This is hypothetical, by the way. This is not a real one or one under development. Then heads up what looks like a relatively free part of the sea between more aggregate sites, wind farms and shipping lanes. Then we dive across a shipping lane, seemingly crossing a cable in the middle of the shipping lane. Not the best route, but I'm not an official routing engineer, so I'll be forgiven that particular faux pas. And then we've moved it away from the French jurisdiction, because they might have different permitting regulations that we're not familiar with. They have slightly harsher, harsh is the wrong word, slightly more involved archaeological requirements in the French sector. So there's a decision taken that we don't want to go through. It might be shorter, but we'll lose time getting more surveys, more data, like processing it all in the French jurisdiction. And then we sort of cross over and drop down. Again, crossing cables at right angles as much as we can down to the final landfall And then the last protected area, we try and cross it at 90 degrees, shorter distance as possible. So this is the last one of the Viking link cable. So again, this was near the landfall. This was one on the Danish side. So again, high level summary, right? So you have a landfall and a connection point. You do the initial desk studies. You get your preliminary one, you sort of the straight line. Then you get more information, the route starts shifting around. You do your offshore surveys, it will continue shifting around and realigning itself. And then you'll end up doing more assessments. You'll end up talking to more people, more regulators, more nature bodies to understand what their concerns are. And then the route carries on evolving, basically until you get your final permissions. And that is me. Appreciate it's a very quick overview. If there's any questions, very happy to take them. Any questions about the sensitivities we crossed, or any questions about how to do it, very happy to answer them.
We do have a little bit of time, so if there is any quick questions you would like to ask, please do so. Question at the back.
Oh, yeah. Mm-hmm. Yeah.
Hold that thought. Can you ask again? I can't remember. Sorry, just for people online.
Hello. Yeah, we have an area of Subsea Reef at the moment. We've not got the full survey back at the moment, but consenting wise, it was. I think the wording used was to minimise impact, which was quite vague. So, sort of just interested on your experience of dealing with that particular feature. You know, did you have a strategy, or how did you overcome that?
So those pictures are from the cable route that's currently under development. So the way that we're looking at the data at the moment is that we have to work out if it is a reef. So there are published papers and guidance on the extent, the height, the elevation, how much of a reef, like what constitutes a reef. Is it then a low resemblance reef, medium, high resemblance reef? Our sort of base case is we just want to go around it. We don't want to go through it because we will face permitting challenges from the regulatory authorities about, well, if you can go around it, why wouldn't you go around it? And because the corridor is so narrow, you're not talking massive kilometre deviations with a power cable, which costs an insane amount of money per kilometre. So, you're talking about, instead of going straight ahead, you're going slightly left, slightly right. So our usual approach is to avoid it. We have, on the Viking Link cable, we have, I think it's biogenic reef or stony reef areas, and we have a condition to monitor them slightly more regularly than our normal O&M surveys. So we have to provide just basically pictures on how it's evolving after our cables. That one we couldn't avoid, so we had to go straight through it, but we just picked the narrowest point, because it went all the way across the survey corridor. We just picked the narrowest point, went straight across it. But because we did, we had to do extra monitoring. Yeah, go around it if you can.
Okay, time for one more. Yeah.
Bear with me with the analogy, but sorry,
Just for people online.
Chris Polly, MOD. With planning shoreside, so if I'm building an extension in my house, I submit the plans to the council, it gets approved, but then it gets inspected thereafter for compliance with what has been proposed.
Yep.
Is there a similar feedback loop for compliance with regulation post-lay, so particularly with marine sensitive sites?
Yes, so the main sort of permit is your marine license in UK waters. There are other permits in Dutch waters and German waters, Danish waters. If we just concentrate on the UK, you have your marine license. It will contain a number of, you have a license document and then an online system which contains something called returns, which basically say you have to provide evidence to show you've met certain conditions, and then that is reviewed and signed off by the NMO. Specific, but those will be general conditions from pre-installation to installation to decommissioning, so it covers the whole life cycle. it can contain very specific ones for environmental purposes. So the Viking Link one has a very specific one saying you have to do surveys or we've agreed a survey plan with the Natural England and the MMO that say in these particular areas we're going to survey in, I think it's post-installation, then years 1, 3 and 5. But then 5 is when our O&M surveys start. It's all publicly available information. It's on the MMO case system. So yes, and then we get audited usually once every 18 months, something like that. So I have to explain myself to a case officer at the MMO to say, have I met these conditions? Can I give them evidence that shows I've met them? So yeah.
Okay, thanks, Dave.
All right.
I'm Felgate from Meta. Thanks.
Hi, good morning, everyone. I'm delighted to be here to present on marine route surveys. But before I do, I'm afraid I'm going to have to bore you with a bit of a career story. I feel like I'm old enough now to be one of those people who can't give a presentation without, first of all, telling you a bit about their early stage career. So I'm going to do that. So back in the late 90s, I graduated from Bangor University in oceanography. Didn't really know what I wanted to do at that point, didn't really have a career plan, wasn't really quite ready for the real world. So I got a job as a sailing instructor, teaching sailing and windsurfing out in Menorca in the Mediterranean, and found it absolutely fantastic. That this is great to get being paid to do something I love doing. And it was fine for a couple of years, but then there was 2 problems. One was it only was a job from May to September, and the other problem was I only got paid £40 a week. So I thought, right, I'm going to have to fix this. So I came back to the UK and I got a job, and I absolutely hated it, couldn't stand it. It was one of those Monday to Friday jobs. And then I thought, right, I'm going to fix this. So I phoned a friend of mine who at the time worked for Nick Smith at ASN at the time in Greenwich, and I said, have you got any jobs? And he said, yes, we've got, it's the end of the .com bubble. So it was the late 90s, big build out of submarine systems around the world. She said, we've got corridors full of project files that all need to be put in cardboard boxes. So I said, great, I'll come and do it. So I went up to London and spent 6 weeks in basically an underground basement, filling all these project files into cardboard boxes, labeling them, archiving them. But I was so inspired by this. I looked at these folders, and there was these maps of cables across all parts of the ocean, and found it completely inspiring. So beyond that 6 weeks, I'd never looked back, haven't really felt like I've had a proper job ever since, back to where I wanted to be. This story does become somewhat relevant at the end of my presentation, so I'm going to start in earnest now. So marine route surveys, why do we do it? What's it used for? So first of all, we're looking for hazards, to identify hazards and avoid hazards in the marine environment. So as Peter explained at the outset, most of the cable faults around the world are caused by human activity, and the cable needs to be protected from those. We're looking for anywhere where the cable could be left exposed to both human threats, but also those geological threats as well. We'll come on to that in more detail. We're looking at the cable length and slack planning, so we need to know the exact distance it is from one landing to the other, not as the crow flies, but along our precise route, and also with the ups and downs that you've got to follow along the contours, along the ocean floor. Then we have to add in a bit more cable on top of that, which is called slack, that allows the cable to sit nicely on the seabed. So that all needs survey data as inputs. Next, planning the burial operation. So we need to bury the cable in shallow water, and we need survey data, particularly geophysical and geotechnical data, to allow us to effectively plan that operation, work out where the slopes are within tolerance, work out where the sediment conditions are conducive, and in some cases plan the type of tool that we'll need to use. Generally it's a burial plough, but if there's some particularly difficult patches, it might be done with a remotely operated vehicle. Determining the appropriate cable protection. So by cable protection we mean Are we burying the cable? How deep are we going to have to bury the cable? Are we going to armour the cable? In some cases, there's extra protection such as mattressing or rock placement over the cable, particularly at crossing points. So we're planning those transition locations between the different armour types, different cable types in deep water, where we might put a screen, like a plastic screened cable rather than just pure lightweight cable. Also looking at repeater positions. Repeaters are very expensive optical bodies that amplify the signal every 70 to 90 kilometres along the route. We need to make sure they land suitably benign locations, so we're looking for that. Also looking for cable and pipeline crossings. Often these are charted. In rare cases, they're not. Sometimes the charted positions don't match with reality, so we're looking for where those are. Benthic and habitat assessments are very important to, in some cases, report on this to the permitting authorities. They want to know what type of environment it is you're crossing. We had one recently where they were interested in a pink sea fan, and you have to map all these things out and present them. Seabed mobility analysis. Again, the previous presentation there was mention on sand waves. These are migratory features. Some cases we're interested in trying to work out if they're moving, how much they're moving. The route might be fine when we survey it, but when we come to install it, it's something that's going to move into the path of the cable. For the power cables in particular, they look at doing the dredging or pre-sweeping, how much of that is going to be required. And then maintenance operations. When we're planning a repair, see Rob at the back is going to do a presentation on this tomorrow, I believe. So when planning a repair, having that survey information is also vital. And then here's just a few pictures, illustrations of what we're trying to sort of prevent here. A good survey helps to make sure the cable's well protected and it's not going to be subject to damage from the fishing, the big anchors, abrasion on the rocks. In other cases where the cable's ended up in high tension or has abraded on something and been damaged. Okay, so various categories of survey. We have surveys in the inshore and the landfall area, on the continental shelf, and then in the deep water. So I've got 3 more slides, just one on each. Firstly, with inshore surveys, it is the most dangerous activity. And I want to stress this because we're looking at small boat operations, sometimes looking at diver operations. So it might be the most hazardous survey activity. So health and safety precautions there are vital. And we're looking to collect geophysical and geotechnical data, similar to what we do further offshore, but we're doing it at on a smaller grid. So as you can see on the previous slide, at the beginning here, when we're doing surveys, our coverage is a function of the water depth. We're insonifying a triangle in the water. So in very shallow water, that width that we're collecting of coverage is not very wide. So we have to do lots and lots of lines on the inshore part, as you can see on that bottom image. It's typically done so using a small launch. Here's a catamaran. And it will go out and it will try and get as close to the beach as possible and extend out to that 15-metre water depth contour where a full-size cable vessel can take over, collecting a corridor width of about 500 metres. And we try and overlap with the land survey, so that the guys will be on land doing topographic survey with land survey techniques. And they'll try and go down at low water, at low tide, right to the water's edge. And then, if the tidal conditions allow, at high water, you might be able to get the inshore vessel in to overlap, which is great, gives you complete coverage in the intertidal and surf zone, which is often a tricky place. Increased use of drone technology. So in some cases, we're seeing LiDAR surveys used now for mapping the topographic elements on land. LiDAR can also be used in some shallow water conditions where the water is very clear. we can actually measure depth with LiDAR. Some of these small autonomous surface vessels and underwater vehicles are being used to try and to replace that need to put divers in the water and have the divers swimming along doing seabed probing. So next, continental shelf surveys. Often we term these shallow water surveys. And again, this is critical because it's where most of the human activities are on the continental shelf that can result in cable damage. So we need the best data. And we're collecting, again, geophysical and the geotechnical. So that's the multi-beam echo sounder, side scan sonar, sub-bottom profiler, magnetometer on the geophysical side. And then on the geotechnical side, we're using cone penetrometers every few kilometers and gravity or vibro cores to both assess the seabed conditions for burial survey, but also to ground truth the geophysical sub-bottom profiler traces and provide ground truthing on that. So this extends from the inshore survey limit out to typically the end of burial or just beyond around 1,500 meters water depth. Corridor width of about 500 meters, and we do 3 to 5 lines to get that. Using a large survey vessel, here's the EGS Ventus pictured here, and they'll be working 24/7 to collect the data. And if they identify anything tricky, they'll extend that survey corridor to go around it. Next, deep ocean survey. So here's the simplest and fastest operation. Typically, it's just a single pass at about 6 knots. Single line with multi-beam echo sounder. So it's a single sensor operation. And as said on the last slide, additional lines are performed if required to route around canyons, seamounts, or other hazardous features. And it requires shipboard reps to be on board, constantly reviewing the data and assessing in real time, do we need to circle back, collect another line on the edge to map out this feature accurately enough to find a route around it. Typically in deep water, wanting slope angles of below about 20 degrees. Anything really rough like this in the image, there's a risk of the cable being laid in suspension, resulting in abrasion, and we're looking to avoid that at all costs. So performing extra survey data here is time well spent in the long run. Sound velocity changes, they need to be measured constantly so the data can be processed. Here at the Oceanography Centre, you probably know all about stratification in the water column, temperature differences, difference in salinity, it all affects the speed of sound in the water. And without having a vertical profile measurement of that at frequent intervals, it's impossible to properly process the data and give accurate depth sounding. So that's done as well. And then my segue back to where I started from in this conversation. So look at new greener technology, which is on the way. And here's something that I've been working on over the last summer, which is a multi-beam echo sounder. So it's simply the sensor that you have on any survey ship to collect data in deep water, but it's mounted into the keel of an unmanned sailing boat. The end. Right, there we go. So this is an example of how technology is changing. We did a survey across the Atlantic over the summer using this technology and acquired results that were good enough for, in my view, for planning a deep water cable route. This is just a preview. I'm going to present the full details on it at the Suboptic conference in Lisbon in June. But yeah, here I am 27 years later, still teaching sailing, but this time to a robot. Thanks very much. Any questions?
have time before coffee break if anyone has any questions for Andy. Question.
Sorry, me again. Just in your marine survey experience, in the heavily fished areas, and when you tow in survey equipment, do you have any experience in when you've maybe snagging equipment or ghost fishing gear that's caused problems? Because that sometimes causes issues. I don't know if you've got experience in that area.
Yeah, I do actually, quite painful experience. So we've had various projects in Southeast Asia which have been really heavily impacted by what are known as fish aggregating devices, which is static fishing gear moored to the seabed, where you have, it's basically like a raft, which is used to create a habitat beneath it with a bit of shade that brings in the small fish, that then brings in the big fish, that then brings in the tuna. And these fish aggregating devices have become really prolific around Southeast Asia and the Western Pacific in recent years. And some are drifting, they're just floating devices, others are moored to the seabed. And we found that they're now moored to the seabed in depths of up to 6,000 meters with polypropylene line. And you try and lay a cable in that, in a close proximity to one of these things, and the cable would just grate down the line on its way to the bottom, and it results in a chunk fault before you've even finished laying the thing. So that's one example. Other examples, you have lobster pots, you have a lot of other static fishing gear in shallow water that does all pose a threat at the survey stage. And you're right, the survey companies, the last thing they want to be doing is towing a side scan sonar fish, and it suddenly either gets entangled in one of these fad mooring lines or in the line from a lobster pot, or even worse, an actively trawled net or long line fishing gear. So it certainly is a problem for the survey companies. They try and mitigate it as best they can. Sometimes they'll have to do a scouting run first of all to try and assess what's in the way. When the cable ship is laying in these type of environments, they'll have what's called a long line cutter, which is a line with blades hanging off the bow, and that's designed to clear stuff before the cable might engage with it. And I think going forward for the survey industry, we don't typically use autonomous underwater vehicles. They're used more in oil and gas. But the advantage that they have is because they're free swimming, they're not tethered to the vessel. There's less chance for that becoming entangled. So I think we may see them becoming used more in those type of situations.
Anyone else? Okay, so we'll have a break now, and we're 10 minutes early, but if we can come back at 11 o'clock, please. And as I said earlier, we do encourage networking and just talk to people you don't know, and particularly the ones with the red lanyards. We'll see you back at 11. Thank you. Stop. Right. Stop working. I don't know why.
I'm forward in.
What's that? Hello. There you go.
So Peter Sparrow's online.
Yes.
And I'm just flicking his slides. That's
Yes,
right.
please. Yeah, just get the people to say slide. Right, this video is on now.
So,
Do you do it from there or on this?
I could do that.
Yeah. I was bringing Peter up there. Look. Oh, I've moved on. I think. There we go. You can ring the bells.
Okay, welcome back. The next, there's 6 presentations that are covered under permitting and consenting. And the first presentation is by Peter Sparrow from Marine Director in Scotland for an introduction on licensing bodies. Peter's online, so Peter, would you like to go ahead and I'll forward your slides as we go.
Yeah, this is the first test of technology. Can you hear me all right in the room?
Yep.
Great, thank you. And thank you for having me to speak today. It's a real pleasure. I'm coming to you from a very chilly Edinburgh. I wish I was in sunny Southampton with you, maybe next time, but I think our budget only extends to the border at the moment. So I'll try and cover in this presentation. I only had one slide. They're just a couple of very brief topics. They are who are Marine Directorate Licensing Operations Team, what do we do? A little about surveys and regulation, a general overview of the cable licensing process, the timescales and some of the common issues that arise during that. So I'm Peter Sparrow, I'm Marine Licensing Group Leader with the Scottish Government's Marine Directorate. We are the marine licensing regulator for Scottish waters. We issue licenses on behalf of Scottish ministers for licensable marine activity in the Scottish inshore region, 0 to 12 nautical miles under the Marine Scotland Act, and in offshore waters, 12 to 200 nautical miles under the Marine Coastal Access Act. The Marine Scotland Act is unique to Scotland, although very similar in structure and content to the other UK inshore marine licensing legislation. The Marine and Coastal Access Act covers the wider UK offshore area. Additionally, we have a compliance role in ensuring compliance with marine license conditions and taking action in respect of unlicensed activity. We typically determine between 300 and 400 marine licenses every year. This covers a range of things: marine construction works like ports and harbours, aquaculture, coastal protection, dredging, and of course things like cables. Typically, cables make up about 5 to 10% of our caseload, so a relatively small number of applications in total, but it probably makes up a lot more than 5 to 10% of the licensing effort, given the range of locations, the scale of cables works. In terms of surveys and the regulation around surveys, there's a significant amount of work, as we've already heard, that's required in advance of licensing a cable in order to define cable route. And this obviously comes with extensive survey requirements, which may also require licensing. And part of my team's remit is the issuing of licenses to disturb European protected species, typically cetaceans and basking sharks. And this can be disturbance by any mechanism, but in relation to cables, it tends to be auditory injury or disturbance by noise generating survey equipment during cable survey works. Typically, EPS licenses, European Protected Species License, and basking shark licenses are a shorter and simpler process than marine licenses, and they involve consultation with only the statutory nature conservation bodies. They normally require the submission of a European Protected Species or basking shark risk assessment, and conditions will likely be applied to the subsequent license to mandate adherence with that document, with any guidance required by the nature conservation bodies, and potentially with other wildlife codes. It usually takes us around 8 weeks to determine a European Protected Species or basking shark license, and it doesn't currently have an application fee associated with it, although I would like to change that, so please get them while they're free. We've had some absolutely fascinating output from cable corridor surveys. I know Savallaria was mentioned a couple of times previously. We've also recently had some significant discoveries of previously unidentified aggregations of northern feather star in the Wester Ross MPA, and it's been great to be able to link up the survey groups with researchers in Nature Scot. In terms of the cable licensing process, cables and any cable protection will require a marine license in the inshore region. Typically, only the cable protection works require a license, as cables are exempt in most cases from licensing in the offshore region. The licensing process involves the submission of an application and supporting documentation, which can include an assessment of the environmental effects, normally a pre-application consultation report, and the payment of an application fee, which varies depending on the cost of the project. Once it's accepted, applications require the publication of public notice, and then are then sent to statutory and non-statutory consultees for a 28-day period. That's not a statutory consultation period in Scotland. It can be compressed in exceptional circumstances where we need to get through some work very quickly, but normally a 28-day period. And then a determination can be made and a license issued, in all cases with conditions. It may be reassuring for you to know that it's extremely rare for us to completely refuse a license application. And the reason for that is that the marine licensing process is an iterative one. Any objections or clarifications that are required are returned to the applicant, and resolutions, compromises, or marine licensing conditions end up addressing most of the issues. Obviously, that leads to a bit of back and forth between the licensing body, us, the applicant, and some of the other consultees, and can take additional time to resolve those issues, but it does mean that ultimately licenses are positively determined. Statutory pre-application consultation is required for most cables, the threshold being for cables in excess of 1,853 meters, which is most cables. And the purpose of PAC, or pre-application consultation, is as an awareness raising process to notify anyone who may have an interest of significant proposals in an area. Cables in Scotland are typically not environmental impact assessment scale projects, unless, of course, they're connected to renewable energy generating infrastructure. When we're determining marine licenses, we, on behalf of Scottish ministers, must have regard to the need to protect the environment and human health, and to prevent interference with legitimate use of the sea or other sea users. And that's why we consult broadly the range of groups that we do. We also require to make authorisation decisions in accordance with Scotland's National Marine Plan, and to consider regional marine plans and any other relevant policies. On timescales, I'll really keep it brief and just say allow plenty of it. You'll know from experience that licence applications can run on. Our target determination times are 8 weeks for EPS and basking shark licences, and 14 weeks from the date of payment of the invoice for marine licence applications. And we managed to determine about 80% of applications in those timescales, but it's not unusual for complex applications to take much longer. In areas of high environmental sensitivity, other assessments can be required, which can also add time. Some of the common issues that arise during the marine licensing process with cables typically surround increasing use of the sea. We hear the term spatial squeeze a lot, and that is felt by a lot of stakeholders, particularly in the inshore region. In terms of other marine users, fishing groups in all areas feel impacted by a lot of licensable activities, but cables do seem to raise a substantial number of responses and objections among a whole range of inshore and offshore fisheries. And I'm aware that a lot of discussion can be required to resolve those conflicts, and that can take additional time. Restrictions on cable routes and temporal restrictions on works arise routinely because of environmental sensitivities. We obviously, across the whole of the UK, have a broad and growing network of protected sites, including the SPAs, SACs, NPAs, and priority marine features. And in Scotland, we're also aware of the forthcoming second iteration of the National Marine Plan, and I think we may see some increased protections for priority marine features in that, and that includes features like seagrass. Now in Scotland, under the National Marine Plan, we must not allow development which could have an impact on the national status of a PMF, and so I anticipate that this may become a more regular feature of licensing determinations. In summary, the key messages I'd like to take away from a regulatory perspective are to engage early, come to us early seeking advice on licensing requirements. We're very keen for that to happen. I'd say allow time, give yourself a lot more time for the licensing process than the statutory determination times. We anticipate that the process can run on, and we'd advise you to build in as much time as you can. And I'd also finally say, build stakeholder relationships. There is a lot of work you can do in advance of the statutory consultation process to wash out quite a lot of the issues that will arise. If you can build relationships over time with the statutory nature conservation bodies, some of the other consultees, some of the other stakeholder groups, you can give yourself a no surprises approach to the licensing process when we get to that point. That's everything I wanted to say. I'm happy to answer questions by follow-up email or now. Thank you.
Thank you, Peter. Yeah, if any questions can be asked via Slido, and we'll come back to you on that. But thanks for your time, Peter. Okay, next presentation under the same topic is from Alice Ramsey, who's presenting on behalf of the MMO.
Hi everyone. I'm not going to attempt to cover all of the detail about MMO and the organisation's role, but just to complement the presentation that Peter gave for Scotland, it was just to use this as an opportunity to highlight the jurisdiction for MMO. And also note that the marine licensing authorities in inshore territorial waters in Wales is NRW, and in inshore territorial waters in Northern Ireland is DERA. So just to give you that broader UK perspective, MMO have supported us in these workshops over the years, but unfortunately had a clash with another workshop today, so couldn't join us. But they were very happy for us to share these slides on their behalf. So just a map there to show the area of MMO jurisdiction, and then to follow on from that, there are some links here where you can find out some more information about the MMO's role, about marine licensing generally, how to make a marine license application, and marine licensing fees, marine license impact assessments, and so on. And we'll be able to share these links with you after the workshop. I would also note that there's the MMO desk note, which was published in 2021, which gives a really good overview of the cable sector and the relevant legislation and information about installation techniques and so on. It's really worth the read, so we include that as well. And then finally, some contact details at the end there. But that's it from me. So.
Okay. Thanks, Alice. Next presentation is a joint presentation from Maurice Bray of the Crown Estate and Mona Stewart from Crown Estate Scotland on the introduction to management of the seabed.
Thank you, Clive, and good morning, everyone. So I'm Maurice Bray from the Crown Estate. I'm the transmission portfolio manager in the Crown Estate team. So along with my team, we have responsibility for managing the seabed interests, the land seabed interests for the sort of power transmission sector. Rona Stewart from the Crown Estate Scotland has probably got similar restrictions to Peter in that she's in Edinburgh today, but she's going to be joining us online to do the second half of this presentation. We're going to try and give you a little bit of an insight into the difference between the Crown Estate and the consenting and regulatory authorities that you just heard about in terms of the Marine Scotland Directorate and the MMO, DERA and NRW. Try and tell you what we do for the power and telecom sectors and also what we don't do, just to provide that sort of clarity. Probably worth, as we were preparing for this, it became clear that both the Crown Estate and Crown Estate Scotland actually manage the telecoms and power sectors in not a dissimilar way. And we do have some sort of management oversight that makes sure that we look at both sectors, effectively all cabling sectors, in a good way. And I think another observation is that between the Crown Estate Scotland and the Crown Estate, we do actually work quite closely together as a result. Who are we? Between us, we're effectively landowners, land managers, but really long-term custodians and stewards of land, seabed around the UK. Although we do have onshore land interests, confining our discussion today to our marine responsibilities, subsea cables workshop. And what you can see from this slide is the distinction between our jurisdictions and our responsibilities. Crown Estate Scotland in the different shades of blue and the Crown Estate in the different shades of purple. Our roles really originate back to the 1760s, since the time of George III, and what's called the Settlement for Crown Lands, which effectively meant that since then every monarch has sort of surrendered or relinquished the revenues that they can get from their hereditary possessions of their land, effectively, and that has been transferred to government. And King Charles III would have done the same thing when he acceded to the throne. He would have surrendered his hereditary revenues effectively to the government. Now, the management of hereditary possessions, including land, has fallen to the Crown Estate organisation since and formalised in the Crown Estate Act of 1961. but subsequent to the devolved powers for the Crown Estate in Scotland, those functions of land in Scotland have been devolved to through the statutory transfer scheme of 2017 to Scottish ministers and then delegated to the Crown Estate Scotland. So we are slightly different in how we're constituted, but we have come from a long history of a relationship to the Crown. When I mention hereditary possessions, the territorial seabed, which you can see here is the sort of brightly highlighted area around the coastline, is a hereditary possession of the Crown. So as a result, that gives the Crown Estate and Crown Estate Scotland the responsibility to grant seabed or land access rights in that area. You can sort of see from the slide as well that some of our responsibilities and accountabilities are slightly different in terms of our interactions or relationships with government. Crown Estate, for example, is independent of government. Crown Estate Scotland reports into Scottish ministers, obviously. But collectively, I suppose one of our products is that our contribution, certainly from a commercial perspective, means that all of our net revenues go into government funds, which are for the benefit of the nation. So ultimately, the contribution that we make goes to a national benefit, whether in Scottish government or in UK governments. Our wider responsibilities outside of the territorial seabed are really shaped by what's quite a complex framework of legislation and conventions, primary and secondary as well. And not being a lawyer, I just want to highlight a bit of an overview of the context for that without getting into the detail. So these are some of the main building blocks of the legislation that are relevant and are important to sort of distinguish what we can and can't do as a Crown Estate, especially outside of the territorial seabed. This legislation sort of defines the continental shelf. It defines the exclusive economic zone, of what activities can be undertaken in there, and obviously the renewable energy zone, which is most relevant to power cables connecting wind. And this sort of suite of legislation helps define what the Crown Estate can or can't do, as I said. However, it's probably important to try and give a summary of how we interpret that legislation and what it means for power and telecoms cables. And I suppose what that means for our sectors is that within the territorial seabed, we can grant rights, and we do grant rights for any interest, basically. So any cable interest that comes through the territorial seabed will need to have appropriate land rights from either Crown Estate Scotland or the Crown Estate. However, outside of that, there is a mixture of how and when we can grant seabed access rights. Cable rights are really only provided in the renewable economic zone, where they are related to the production of offshore energy. And as a result, for power transmission cables that connect to wind farms, the Crown Estate or Crown Estate Scotland can do grant transmission rights for those. But if the infrastructure is not associated with the production of energy in the renewable energy zone, then we don't grant seabed rights. So that for the majority of telecommunications cables, electricity interconnectors that go between GB and other countries, or indeed some of the national reinforcements that are coming down the pipeline going around the coastline and that are outside 12 nautical miles, neither of our organisations can grant rights for those cables. So it does lead to a little bit of a potential for inconsistency, and a lot of most of our dealings are within the territorial seabed. But as I say, one of our abilities is to grant transmission seabed rights for power cables that connect offshore wind. It's probably just distinguishing from the previous presentations. So we don't grant marine licenses or other consents. So we're really, in fact, a lot of our land rights are subject to those consents that Peter and Alice have mentioned there. We don't have rights over and controls over some other sectors, so we don't have controls over navigation, civil shipping, environmental designations or military uses, and in particular fisheries. So all of the agreements that we give out in terms of land access are subject to things like public rights of navigation and rights of nation states under the UNCLOS Convention as well. Where we do grant the rights, I just think it's important just to be clear about what we do grant to sort of cables infrastructure. Typically, we provide a sort of a spatial designation for being able to sort of install, operate, maintain, repair, and even deinstall and decommission assets. Typically, as I say, that involves providing an option agreement to allow developers to narrow down their route. As we've heard from this morning about how routes are an evolving process, and we provide some flexibility in our land access rights to an option agreement or agreement fees. That's not the case for across the board, but that's something that we do provide to allow some of that narrowing. I think you heard today things like routes corridors being around about 500 metres when you're looking for when surveys are originally carried out. We want to provide that flexibility, but ultimately we'll be narrowing down to an area where the cables are actually going to be installed, and that's what we call a designated area in the seabed. And that's where ultimately the Crown Estate Scotland will be providing the rights to do the activities to install cables, allow them to be repaired, etc. It's just, these are not sort of property rights, so this is not a right to the land. So we normally provide, we don't provide exclusive possession, for example, to the seabed. We provide a lease of rights, and those rights allow you to install, operate, maintain the cables. On our websites, there are a number of sort of documents that support developers and stakeholders about how to come forward and identify cable routes and how to get into this process of engagement with us. We particularly have a cable route and identification and leasing guidelines particularly for transmission cabling for offshore wind. A lot of our interactions are with smaller works, with survey licenses, with seabed activity licenses, and from the Scottish perspective, small works licenses. So a lot of our activity and day-to-day and operational work is actually embedded within those sorts of activities, and some of you might be familiar with dealing with the Crown Estate or Crown Estate Scotland and those sort of survey needs. I'm going to pause there. I think what I want to do there was just give a flavour for the jurisdiction that the Crown Estate and the Crown Estate Scotland have, the rights that we can grant and the rights that we don't grant, where we do that. And I'm going to hand over, hopefully, to Rona to take us through a bit about the future. So, Rona, hopefully if you're there.
Thanks, Morris. Hopefully you can all hear me okay.
Yeah.
Great, thank you. So, Rona Stewart, I work for Crown Estate Scotland as a development manager of all things transmission relating to power and telecoms cables. And part of my role is basically I grant agreements for all development stage projects in Scotland for access to the seabed. So currently there's an unprecedented demand for seabed with the integration of renewables. Basically, this is driving more offshore transmission infrastructure to be built. That also means there's billions of investment needed and also highlights there will be areas of congestion for land and cables. So the map on the left, which was taken from the National Energy System Operator, highlights all the infrastructure, including offshore wind sites and subsea cables in the UK needed for the power sector. If you just click on the map again. So the next map basically shows you the telecoms cables, and it just gives you an indication of the amount of demand of subsea cables in UK waters. One of the approaches we are taking at Crown Estate Scotland is that we undertook recently an internal project looking at how we could manage and facilitate congested cable landing sites. And one of the outputs of this was to work with ESCA to put together a technical guidance document around specific issues around proximity, legal implications, environmental issues, and how we minimise the impacts of this. One of the areas of congestion we currently actually have in Scotland is around Peterhead, which is around the north of Scotland and is due to the many ScotWind offshore wind sites and cables that are due to connect into that area. To facilitate all the interaction, there will be a technical guidance document given to developers to help facilitate the issues and implications around the congestion and find solutions that work for all. There will no doubt be more and more scenarios of congestion offshore, approaching shore and at cable landing sites in the future and around the whole of the UK. We involve ESCA as their members have the knowledge and experience firsthand to be able to help put together the aspects of a document and utilise all their expertise to put together a document which can be publicised and used for future use. Both the Crown Estate and Crown Estate Scotland work with the industry and stakeholders and support engagement and facilitation and fund events just like this one. Next slide. So more broadly, and just wrapping up, we want to highlight the work that both TCE and Crown Estate Scotland are doing about the future management of the seabed in order to accommodate multiple sector interests, both in territorial waters and the exclusive economic zone. Both organisations are working together to build a picture of needs from a number of sectors, including the likes of offshore wind, CCS pipelines, gas storage, power and telecoms, tidal, aggregates and minerals. Developing what we like to call a whole of seabed approach evidence base in order to be able to provide route maps for different sectors out to 2050. Using this tool, we will be able to support engagement with the governments and ministries and also support the NESO's spatial energy planning responsibility, especially in relation to offshore renewables. And last slide. And that's all from us, just to say thanks, and there's contact details on the screen. However, if you want to contact us, feel free to do so or put any questions onto Slido. Thank you.
I think ESCA are going to put the contact details into the chat so that people can access that as well. Thank you, John.
Thanks, Maurice. Thanks, Rona. Okay, next presentation is on environmental impacts of subsea cabling from Lucy Cooks from the Marine Industry Senior Specialist team and Paula Daglish and Senior Marine Industries Advisor. So, who's first? You first?
First, yeah. Well, good morning, everyone. Thank you very much. So yeah, thank you for inviting us to come and speak today. So Paula works at the Joint Nature Conservation Committee, or JNCC, and I work at Natural England. So together we'll provide an overview of our roles as SNCBs, or statutory nature conservation bodies, in the context of subsea cables. So, oh, I didn't even do that, did I? Right, content. So what will we cover today? We will introduce JNCC and Natural England and describe our remit and what we do as part of our roles. So we'll provide an overview of our subsea cables best practice for those of you that haven't heard of it yet. And finally, we'll present our main concerns of subsea cable activities as SNCBs. So I'll start with providing some background on Natural England and our role. So as an SNCB, we're the government's advisor for the natural environment in England. So our remit is just within England. Our vision is thriving nature for people and planet, and our mission is building partnerships for nature recovery. So our purpose is to help conserve, enhance and manage the natural environment for the benefit of present and future generations, so thereby contributing to sustainable development. So in the marine environment, Natural England are a statutory consultee to the regulator out to 12 nautical miles, with the exception of renewable energy, which Paula will cover in a bit. So our priorities support our mission of building partnerships for nature recovery and also the ambitions of the government's 25-year environment plan. So in order to achieve our mission, we aim for a well-managed nature recovery network to create and protect resilient ecosystems. And we also hope for evidence and expertise to be used by a range of partnerships, organisations and committees with the aim to achieve nature recovery. So I'll hand over to Paula now. Hi, good morning. So So I'm from JNCC, and JNCC is a public body that advises on UK-wide nature conservation to the government and to devolved administrations. So JNCC's vision is up here. So it's thriving nature for sustainable future, and our mission is turning science into action for nature, people, and the planet. So we do this through our links with science research and through collaboration and through our advice. So I work with in the marine management team at JNCC, and our core function is to provide nature conservation advice for offshore industries. JNCC's Marine Directorate has 6 teams. So we've got my team, which is the Marine Management team, we've got the Marine Species team, the Marine Protected Area team, Marine Monitoring, Marine Ecosystems, and Marine Evidence team. So JNCC, with other SNCBs, work in partnership to provide consistent and common approaches, solutions, and best practice advice. So here's a map of the UK waters and showing geographical remits of all the SNCBs. So JNCC are represented by the yellow area here, so that's all that we cover. And then for other SNCBs, so we've got Natural England in the orange, we've got Nature Scotland blue, and Northern Ireland Environment Agency in the pink area, and then NRW in green. So we as SNCBs so we're not decision makers, just want to stress that. So for consenting, not for consenting, leasing, licensing. So we're statutory advisors to the regulators who make the decisions, such as the MMO and the Marine Directorate. So we provide evidence-based advice on nature for our representative areas. So NRW are slightly different in the fact that they've also got a regulatory role as well as advisory. So who are we? So Natural England and JNCC work together and separately, advising on a range of industries that include fishing, harbours, oil and gas, renewables. We also do monitoring and survey strategies, decommissioning programmes, and obviously cables. So we advise on a range of aspects from scoping, screening, all the way down to strategic plans and NESO engagement more recently. Beyond this, we're also involved with strategy and guidance, such as the Crown Estate leasing rounds and marine planning. We also give advice to developers, consultants, inshore fisheries, conservation agencies, and local authorities, Department of Energy, Net Zero, Energy Security and Net Zero, sorry, and the MMO, to make just a few. So most of our advice for offshore cable development centres around the protection of designated habitats and species within marine protected areas. And currently about 38% of UK waters are designated. That's across about 377 marine protected areas, and 3 of those are now highly protected marine protected areas. There are several types of MPAs in the UK which in combination are intended to form an ecologically coherent and well-managed network. So as mentioned earlier, Natural England and JNCC have different remits, and this is also applies to marine protected areas. So JNCC are responsible for offshore sites, and NE are responsible for the inshore areas in England, where an MPA crosses the 12 nautical mile limit. We have joint responsibility for that site. Therefore, both organisations have a wealth of information online available to support assessment of impacts to marine protected areas. And I think we've got links at the end of this presentation that you can have a look at, and they'll be in the slide pack. There we go. Okay, so some of you may have seen this document before, some of you may not, so I'll introduce it to some of you and ask for some feedback from the ones that have used it. So JNCC and Natural England developed this best practice document, guidance in association with ESCA. So we decided that with a fast pace of change with marine sustainable development, that we would make it a live document to allow for review and updates as new evidence becomes available. So we're currently in the review process at the moment, and we welcome all feedback, good, bad, the ugly, everything. We want to make it useful to everyone. And it's something which we want people to use, so it has to be the best it can be. So there will be a link provided at the end for those who've not yet accessed the document. So please have a read if you haven't seen it, and I'm very, very open to having any feedback from everybody. So what does the document include? So it's high-level advice provided in this document. So it includes information on electricity cables, telecommunication cables, and renewable export cables. So the aim of the document was to fill an evidence gap with subsea cable technical advice, but also to provide a focus on nature conservation considerations for industry. So it's also a positive example of partnership working between industry and SNCBs to achieve a positive environmental outcome. However, it's not designed to be a substitute for project-specific advice, and SNCBs always welcome and encourage early engagement with the projects, so we can highlight any key issues right at the start. So what's included in the best practice? So the document recognises there are different levels of impact depending on the type of cable which is installed. And the environmental advice links to an understanding of the potential pathways and environmental impacts over the cable lifetime. So this is from route preparation through to decommissioning. This is presented in a guidance with reference to the pressures that may be associated with cable activities. And the environmental impact will depend on the nature of the operations. This will include things as the number of cables, the size of cables, the receiver environment, the type of habitat the cable is going to be installed into, and also whether there's an interaction with marine protected areas. And we will always advise that the mitigation hierarchy is applied. Just to quickly note that NRW are currently working on some cable documents for terrestrial and for the marine environment, and they are due to be published in February, so that's something to look out for. Okay. So I just said the mitigation hierarchy, so this is avoid, reduce, mitigate. It was really encouraging to hear earlier that sub-area reefs are generally avoided, so that's good for us to hear that. But when planning a cable route, we always ask for this to be used to minimise the impact of the cable route. Marine protected areas are not no-go areas, though, just to note here, but they will require more rigorous consideration and assessments under legislation. However, this does not include the highly protected marine areas. They do need to be avoided. As previously mentioned, early engagement is encouraged to highlight key potential sensitivities and impacts. So impacts may differ depending on the receptor, so whether it's birds, marine mammals, or benthic habitats. So this diagram is provided within the best practice, and it's just a simplified form of a flow chart that you can easily work out what you need to do. So can the cable route avoid an MPA? If it's yes, it's great. But there are also sensitive features outside of MPA, such as Annex 1 habitats, like the Savile area. So also we do ask if that can be avoided as well. If that can be avoided, then that's great. If it can't, then there will be another step in order to get more detail. So further assessments and also mitigation measures may be required. But can the cable route, if it can't avoid an MPA, we then look if can the cable route avoid MPAs contain features sensitive to cable pressures. So as I said before, MPAs are not no-go areas, but MPAs with features that are sensitive to cable pressures, so generally benthic features, then it might be that you will need to have further assessments if you can't avoid these sensitive features, and mitigation measures may be required. And it may be necessary to have compensation measures under the HRA regulations, or in the instance of marine conservation zones, MEAD may be required, so measures equivalent environmental benefits. So main concerns. So what are our main concerns related to subsea cables? So as highlighted earlier, marine protected areas are a key concern. So we want to understand the activity that's been undertaken, the pressure of that activity, and which feature is going to be impacted. So this is paramount to understanding the magnitude of impact Key pressures include abrasion, habitat loss, and change in habitat type. Another key concern of ours is external cable protection. So the use of rock protection when target or sufficient burial depths have not been achieved, or when there's cable crossings. So the problem with external cable protection is it can result in a habitat change. So for example, if there's a sandy or muddy habitat and you install external cable protection, it will then change to a granite rubble. So this will reduce the extent of available habitat for the local biota. Unexploded ordnances, so UXOs, if these found, they need to be detonated and the disturbance to marine mammals need to be assessed. Sand wave clearance can result in changes to sediment transport, hydrology and topology. And some locations may require significant boulder clearance, which can cause long-lasting impacts. Another area going closer to land now is impacts in the intertidal environment and associated habitats. So these are of concern. There is horizontal directional drilling, or HDD, which can reduce the impacts, and it is a useful tool when applied in the right conditions and the location of exit pits avoid the sensitive habitats. And finally, decommissioning. I will hand back to Paula to discuss this. So decommissioning. So the graph on the left here is taken from the Offshore Energy UK's 2024 offshore decommissioning report, and it shows that there's expected to be a rise in decommissioning, particularly in 2030, that large spike there. So just for oil and gas alone, there are around 600 platforms and associated infrastructure in the UK that will come offline in the next 10 years and need decommissioning. So this graph doesn't include the decommissioning of offshore cables and renewable structures, which will also become an increasing requirement. All decommissioning activity may require some form of rock protection, as Lucy's just spoken about, to avoid snagging pressures. So you can see that with all this decommissioning activity alone, it's a potential concern for us. The image to the left, to the right here, shows the North Norfolk Sandbanks and Saturn Reef, which is a marine protected area. It's a SAC, or Special Area of Conservation. And I've included this just to demonstrate the amount of seabed infrastructure within this marine protected area. And the yellow line through that site is a cable, but there's also an export cable for a renewable offshore wind farm, I think, that goes through that site that's not mapped on there, which is unfortunate. So cable decommissioning involves, excuse me, involves a section of cable being cut and removed, while other sections can't be removed. They'll be left in situ, and sometimes the ends need to be secured so they'll have rock dump over the top of them. And to date, most cables seem to be left in situ, and there have been very few examples of power cable decommission removal so far. So we believe there are significant benefits to knowledge and data sharing. So intra-industry data sharing allows for more confident assessment of impacts and long-term recovery. So shared monitoring results of post-slave benthic recovery, as well as an open register of baric success in various substrates, would build confidence in application process. Another thing we're looking at, which would be very useful, is a hard substrate database. I'm aware that MMO have currently got a project which is building on Natural England's project to develop this database. So I'm really keen to see how this goes, because it would be very useful. So this will sort of use geospatial data on as-laid external cable protection. Also pre-sweeping data. I know pre-sweeping was discussed earlier this morning, and it'd be really good to understand the correlation between using that activity and what the success rate of the burial will be when it is used and when it's not used, and in different substrates. So that's another thing that we'd really be interested to find out. As well as impacts, it's really important to consider environmental opportunities, so net gain, restoration. Above all, it's imperative that our advice is evidence-based, and we use research and evidence project to underpin our advice. However, the project limitations often relate to data availability. So to us, the knowledge and data sharing is key. So, so as some previous speakers have alluded to, the environment is getting busier and increasing competition for space in the marine environment. So therefore, it would be great if we could all work together with the industry and regulators to try and reach the best outcomes that we can for which have least impact for the environment. And through using avoidance and mitigation, hierarchy, and early disclosure with cable developers, owners, and SCBs is essential. Lastly, I'd like to highlight the importance of sharing and learning from previous experiences to ensure continuous improvement and to try and develop on new technologies to help us minimise impacts to the environment. Thank you. So here's some useful information and some links that there will be in your slide pack at the end. Thank you.
Okay, next presentation is from Sandra Delaney from Aquacom. Same topic, but from an Irish perspective.
Okay, good morning. Obviously, this is a topic that would be a workshop on its own. So what I'm going to do is just a very high-level overview, touching briefly on the past of Ireland and its history with subsea cables, but more importantly, what some of the current issues that you may not be aware of from the regulatory perspective. Also, this is a view from the owner and operator of cables rather than from any other perspective. So first of all, just wanted to briefly look at Ireland and its huge historical significance of subsea cables. The first transatlantic cable landed in 1858 in Valentia, which is in the west of Ireland, and that was absolutely revolutionary, I think it's fair to say, in the history of this particular industry. It's a huge feat. It cost an awful lot of money, and it took 3 attempts to actually land the cable. And even with that particular cable didn't last very long. But it was the start of a number of other cables, and I suppose the industry as we now know it. The reason, obviously, Ireland was chosen was because it is the closest point to the US, so that made it hugely advantageous. But also it had the proximity to the UK, which if you look at politically where we were at that stage and the powers, between the UK and the US, that was important from a communications perspective at the time. So Ireland remained very much at the forefront of subsea cables up until about 1922, when obviously there was independence from the UK, and then again politically, because you're not going to have the UK government having its really important telecommunications landing in Ireland. Most of the cables then would have diverted and bypassed Ireland, and eventually the ones that were there were kind of wound up, etc. And from then, probably until about 2015, we had obviously, cables coming every number of years, but not a huge kind of development in that area. But I think you'll have heard from earlier this morning the Express cable and the focus on latency, etc. That was 2014. And that was kind of the start of the next level of subsea cables coming into Ireland. And obviously, very much when you look back at where we were from the extended use of the internet, etc., everything coming to mobile phones was really where I suppose the demand for subsea cables that we've seen right across the world was similarly seen. Ireland was still important at that stage. Even our first cable that would have went operational in 2016, AC1, latency was still important to a number of our customers, and having landing in Ireland and still gave good latency, even if ultimately your destination was in London. But it was about that time that I think the Irish government then realised that also not just subsea cables, but more importantly, the whole offshore planning for wind farms, etc., was beginning to come on board. And we were operating under a very old bit of legislation back in 1933, and it really wasn't fit for purpose. So there was huge delays at that time with regard, sorry, I should say subsequently to 2016, in getting licenses, not just for subsea cables, but also for offshore. And then the concept of judicial reviews, which is a very unique item that we have in Irish law, because our constitution does give you the right to challenge any decision of that the state would make, and obviously permitting would be one of those. So the Irish government focused very much kind of from 2016, 2017, and right up to when they published the Act in 2021 of overhauling the whole licensing and permitting perspective in Ireland, and the result was the Planning Act 2021, and in July 2023 the establishment of MARA. So this had obviously was to revolutionise the whole thing, put a key focus, a designated unit in place that would be responsible for all permitting of maritime area. So there's two provisions: maritime area consent and maritime usage license. Subsea cables generally come under maritime usage license, certainly all of the ones to date, because a marine area consent would be where you would need an environmental impact assessment. But you will be guided by MARA in relation to that. As I say, they were only established in 2023. So, I mean, the impact of MARA is still working through, but certainly it's put us in a much better position with regard to avoiding some of the key issues that we have been experiencing in relation to delays and then potential challenges. Because obviously from a planning point of view, certainty of license and when you're going to be able to lay your cable is huge for the industry. So I've just quickly put up here from the MARA website what the application process is. So it is a very, very detailed process. And this is for the marine usage license. The one thing that this is missing at the moment is a timeline to get through the process. Now, a timeline can only ever be indicative because could be depending on responses from applicants. But it's one of the things that I think over the next while, as MARA goes through a number of these applications, we will see actually indicative timelines. Unfortunately, seabed licenses are not priority one within MARA at the moment, unless it's a connection between Ireland and Europe, of which there's only one PISIS cable, which is an application at this stage. But the most important thing really here to notice is to engage early with MARA, because that's going to start the whole process. I have put this map up of where we are currently with Ireland and subsea cables, and what I really wanted to do here. But if you look, hey, down here, the mouse, here, down here, a lot of these cables aren't actually landing in Ireland, and up here they're not landing in Ireland. But it is important here, the new legislation. You actually need a license if you are actually transversing through the EEZ, not just landing in Ireland, which would be what you would normally expect and would have been the point under previous legislation. But if you're actually transversing through the EEZ, and if you see this, and then, sorry, back to where we previously were, there are a lot of cables already built in this area, and that potentially might be planning to come into this area. And I know certainly the To Africa cable, which would have been planned way before the legislation came in, ended up having to get an installation license because it was passing through the EEZ. So when we look at routing, and I know that had come up this morning, your chosen route, you may want to consider any potential additional regulations or regulators that you have to deal with and maybe bypass, or else plan to get there quickly, or engage with them early. The second thing, which is an issue under the new legislation, is also that you need to, if you want to repair a cable, you need a license. So in Ireland, you need a license if you want to survey, you need a license if you want to install, and now under the new legislation, you need a license if you want to repair. Both of these issues, both the transiting EEZ and needing a license to repair, is currently under review by the Irish government, because they obviously understand the importance of these subsea cables, and more importantly for a repair, which I know we've a session, I think it's tomorrow, and a deep dive into repairs, being able to get out there and repair very quickly is important. So hopefully we'll see some guidance coming through in the coming months But I think it's important to just remember, even if you're not landing in Ireland, you may end up having to consider EZ and your potential route. The timing of the application, as I said, is still an issue. You need a survey, you need an installation. It's very difficult to give a guidance, but roughly you're probably talking about a year for each. You should certainly allow for that. And as I said, hopefully that will come down and we'll get kind of an actually indicative timeline shortly. I've mentioned the judicial review. That is basically when you've got your license, there's still a period of 30 days in which somebody can take a challenge to that license, and that hearing could actually take quite a lot of time to hear. So you could be delayed for a very long time, which is why engaging early and building this into your project plan early is important. Other things that are happening on the Irish side is that the government are considering whether or not to put in place marine area corridors for cables. Again, demand of coastline, I think we've seen from the earlier presentation, is key. Offshore wind is key for the future of Ireland. But that's only in consideration at the moment. Obviously, some other jurisdictions have done that. I know Australia has done that very recently, but there are secure corridors, because I think obviously from a resilience point of view, the last thing we want is all the subsea cables coming in one spot and then being subject to potential issues. Other planning considerations are for your cable landing station. Again, there's planning required for that, and the same judicial review. So if you're dealing with Ireland or looking with Ireland, getting on top of these regulatory issues early is important. And then obviously, I know we've mentioned fishermen a couple of times before. The fishermen are very active in Ireland. They kind of know their rights, but they are very willing to engage with you. So engaging with them early is important. And then probably the other key area which makes Ireland slightly different is its position as an island at the most westerly part of Europe. But also Ireland is neutral from a military point of view. So we're not a member of NATO. We don't have a huge navy. We don't have a huge air force. So in this current very unclear area where we find ourselves politically, I think we've all seen an awful lot of discussions on this recently in the Baltics, etc. It has a potential of exposure, but again, something that the Irish government are working on very closely with its closest neighbours, of which obviously UK is one. So I suppose in short, MARA and the Marine Act has made hopefully a huge difference to the licensing and permitting process in Ireland. It's still has a bit of way to go, but it's relatively new in 2023 with a couple of things that we're hoping to see some guidance issued, very much the AEZ, and if you're just transversing the EZ, and then also the repairs, and a much more simplistic approach for both of those. And we expect an update in hopefully this year from the Irish government in relation to those issues. Thank you.
Thank you, Sandra.
Okay, yeah, thank you, Sandra. The next presentation is from Luciana Maglio from Subsea on the Italian policy and permitting.
So, hi everyone, I'm Luciano Manilio from Poliservizi, I'm the permitting manager of Poliservizi. And today, thanks to ESCA for having me. And I will bother you on the permitting side a little bit more on the Italian side. So basically, the Italian submarine network is growing. Year by year, we find new projects. Luckily, we are being involved in new projects. So in the last 5 years, we saw the landings of 10 more systems, fiber optic and power cables. Italy, let me say, it's for its position in the Mediterranean, it's a center part of the Mediterranean, and it's very close to the main roads from west to the east side of the Mediterranean. Also, it's very close to the major city in the Central Europe, so it's the perfect landing spot for submarine cables. In the last few years, we had an increasement of the landing in Genoa, for sure, which is the new candidate to be the new hub after Marseille in the Mediterranean to bring the fiber directly to the central part of the Europe. And by now, in the last few years, we have deeper. The profundity of our sea is very high. So during the last few years, we saw a lot of projects coming through Italy, especially in the sea, but not only, also in the territorial water of floating wind farms and renewables from a floating point of view. Oh, just push. Okay, no, just push the wrong button. So the perception of the Italian permitting process, we are not a very right to the point country, so could be this one. But from our side, it's more a straight line. But as you know, the truth is always in the middle. So the reality is something like this. You have to inform our authorities. Our authorities are not, they don't know very well our world. So we have to do a lot of meetings with them. We have to inform them. And especially for fiber optic cable, as we can see later on, the authorities are more local, so they are not directly connected. They are not part of the central government. So we deal with local authorities, and many of them are at the first time experience of this kind of projects. The type of permitting that we have in Italy is mainly we have operational permits. They don't grant you any rights with the seabed. They are only needed for survey and installation process. So they are more focused on the safety at the sea. So are mainly composed by notice to the mariners. But and the third frame to obtain them is from 4 to 5 weeks, depending on the flag of the ship during this period of war. And the first and secondary permits, or as many of you know, is the permitting principle process. So this one gives you the rights on the seabed, basically the space to lay your cable, and gives you the environmental and archaeological authorization also. The difference is that in this kind of process, we will expect 12 months long process. So it's quite bit different, but it's made by a lot of meetings, but it's not a fixed time frame, because at the moment the law in Italy doesn't put a limit to the extension of this process. So it's up to us to reduce it, to explain, to do more meetings, to inform our coordinators and whatever, to help them to reduce the time frame of the process. So talking about a little bit the differentiation through the various jurisdictions, what we have is that permitting principle mainly applies only for the territorial sea. But starting from like the last 3-4 years, we have been involved for the archaeological point of view also in the contiguous zone. So the Italian government claims the contiguous zone as part of the heritage controlled area. So you need an application also for the archaeological archaeological permit on the contiguous zone. Talking about operational permits, they are mainly issued by the Navy and the Harbour Master in the territorial sea, while in the outside of the territorial sea, what we see is that the Harbour Master has no jurisdiction, so it's everything up to the Navy. But as I told you later before, these are only for notice to the mariners, so a safety at the sea problems or whatever. For the permitting principle, there are two main differences between power and fiber optic cables. The power cables are mainly controlled by the central government through the ministry and through the harbor master for licensing and easement, concession, or whatever. Even the environmental permit is issued directly by the ministry, while for fiber optic cable, we are talking more locally authorities like municipality, region, or port authority. So imagine a cable that crosses the Adriatic Sea, all the jurisdiction encountered by the cable. You need basically an authorization from each one authority. What we would expect in the next few years is for sure a simplification of the permitting procedure. The government in Italy is, let me say, it's opening the doors to talking with the industry, starting to know very well the process for licensing this kind of process or projects, but mainly we hope in a simplification of the procedure for fiber optic cable. It's, let me say, at the moment you can acquire an easement even for 800 meters, 70 kilometers away from the coastline in Tuscany. So it's a strange situation, difficult to explain to the project owners, but at the moment we are pushing basically on the government to have some changement in the laws. What we expecting is a more involvement of the government also, because they created in the last 2 years the Department of the Underwater Dimension. Basically, it's concerned about the safety of the projects because of the war between Russia and Ukraine and Israel with Palestine. So they are basically, they know that the fiber optic cable and the power cable are big assets at the moment. So it's a geopolitical team, and we saw the born of the National Underwater Superintendency. Mainly the cables were regulated by the local one, the territorial one, but in this case, we will have this new department of the superintendency, so they will grant an archaeological permit even in the easy or better in the contiguous stone. What is pushing me on this topic is that fact that the National Underwater Superintendency wants to be involved also in the operational permitting. So they need to be involved during the survey procedure, because they can prescribe an archaeologist on board or whatever. And this simplifies a lot the process during the PIP, the process of the PIP. So because it's without the archaeological permit, you cannot lay your cable. It's one of the most important permits in Italy. They have the power to stop everyone when they want, basically. So in the next month, we will see the issuance of the new regulation from Hydrographic Institute. In this case, they will be more strictly on the survey requisites and certification works for the public administration for sure, but even our work will be affected because the Hydrographic Institute is part of the operational permit. They double check the charts, the survey equipment, and if they see something that it's not aligned with the requirements, so they can stop the permit process. And also, we hope to see a little more definition of the permitting process with the other seabed users, like the fishermen. At the moment, they are not very well involved in the permitting procedure. But also, as mentioned before, in Italy, we will have a lot of floating wind farms coming in the next few years. So it will be nice to have a round table with all the seabed users in the next years, in which we will discuss with possible interaction and find the right solution to evaluate the idea of one. So thank you. It was pretty quick, I suppose. Great. Thank you very much. So,
No, thank you. Again, again, questions on the slide. If you have it. Okay. Next presentation is from Mike Clare, in his role as the Marine Scientific Advisor to International Cable Protection Committee, ICPC. So thank you, Mike.
Thanks very much, Clive. Well, thanks for the previous speakers. I think it's really useful to have some local and national context, but also reassuring to see kind of a repeated message about the need for science, for evidence, for engagement with researchers, with industry and policymakers. So I guess that's the point I'm finishing up on. So I don't think I'm necessarily showing anything specific here, but I'll maybe take a bit of a step back from just kind of jurisdictional waters and also think about considerations in areas beyond national jurisdiction, and talk about really kind of how important data is, good quality data, so it can form the evidence base that we need collectively for planning and licensing. So I think it's been said in a few talks already, we are aware, it's particularly at the National Oceanography Centre that we're particularly aware of, and that's the ocean is under increasing stress from a whole range of different drivers, and whether that is human-driven climate change, whether it's increasing fishing and human uses of the ocean, and other sorts of impacts. And so for these reasons, because these compound impacts, increasingly, collectively, we all need to have a greater understanding of what those impacts are and what we can do to minimise the impacts. And even if the impacts of an industry or an individual structure is relatively small, collectively we have that kind of duty to look after the ocean that underpins so many of the key services we rely on in our day-to-day lives. And whilst the oxygen provides a significant amount of oxygen that we breathe, and it takes up a lot of the heat from global warming, the ocean also, it hosts one of the most important networks on our planet. It hosts this network of at least more than 400 submarine cable systems, almost 2 million kilometres of telecommunications cables. So they have a global spread. They play a really important role, as many presentations have talked. But actually, when we think about them, they have a very small physical footprint. You can see examples of cables out in the foyer here. Others can see examples on the screen. And as Peter had said, the typical diameter of a deep sea cable is similar to a garden hose pipe, between about 17 and 21 millimetres in diameter. So a very long, a very big network, but with a very small physical footprint. So therefore, actually a relatively small area. And whilst there can be impacts on the sea floor and the marine environments from the installation of cables, both telecoms and power, in the deep sea, cables are typically surface laid, particularly in water depths of more than about 1,000, 1,500 metres water depth. And so they're laid on the seafloor as these relatively small objects with minimal disturbance of the seafloor in those areas. And studies have shown, I think there'll be more presentations tomorrow, talk about the recovery of cables. But after many decades having laid on the seafloor, there are examples that are floating around here in the room. We can see that when cables are recovered after many decades, here's an example of a cable recovered from the Pacific Ocean after almost 45 years on the seafloor. The cable looks like it's just been laid, it's in pristine condition, and so the deep sea in many places is an ideal place to preserve cables, so limited or no degradation of these cables, and that leads on to discussions around the value of potentially recovering and recycling systems. You said cables require burial in some places, and several of the presentations have talked about intense seabed use by multiple different sectors. So clearly a need to bury cables in some places in shallow water where there's intensive anchoring and fishing activities. But in the deep sea where cables have been laid, peer-reviewed studies have dominantly shown there's no statistically significant difference between faunal abundance close to the cable and further away. But in this presentation, I just really want to emphasize the need to not just make an observation and take a photo, but to gather data that can be used in a meaningful way, that can feed into peer-reviewed publications, that can then form the basis of evidence and decision-making, and through organisations like the OSPAR. We'll come back to that. Andy's presentation and a couple of others this morning have talked about the need to route cables in a careful way. And one of the things that you route cables around is natural hazards. So typically cables are intentionally routed away from seamounts and underwater volcanoes, hydrothermal vents, and submarine canyons. And these locations are also often areas of high biodiversity. So this means, for the most part, cables are intentionally being routed away from hazards and also areas of high biodiversity. And so most of the total length of telecoms cables in the global ocean are routed across pretty flat and benign areas of seafloor through abyssal plains and low-lying hills that tend to have quite low benthic abundance and biodiversity. There are places where it will be necessary to cross because of various different routing constraints. And so clearly consideration needs to be placed there. And so examples such as these, the top right image from MBAR is from offshore California, where there's been significant efforts placed in repeat environmental surveys to try and document what the impacts are and what the rate of recovery is. And here we see actually the rate of recovery is extremely quick, and there's no, in most places, no significant difference between the fauna close to the cable and further away. And typically disturbances relate to the installation of the cable. Then after that, nothing happens unless a cable is recovered. With the exceptions being where maybe the seabed is disturbed by events like submarine landslides or strong currents. That's where repair may be needed. But these are typically kind of one-off short-term operations. Cables may need physical protection. This will be very localized. I think other people will be talking about that. But studies have shown that even where cables do need to be buried on the continental shelf and the upper parts of the continental slope, that the recovery of the seafloor and the recovery of the benthos that lives there can happen very, very quickly. In many cases, this happens over weeks to months. In other cases, it's years. And so there's a real important need to understand the environmental context. The higher the energy, the hydrodynamic energy of the environment, the availability of sediment, the quicker that seafloor will start to recover. So the previous presentations that have talked about a need for desktop studies, surveys, these will be dictated by local environmental conditions. But regardless of this, I think the subsea cable industry, from my experience of working with them over a number of years, is there is a recognition also that there are opportunities to minimize environmental impact. So examples that Andy talked about, greener uses of survey equipment, for example. There are many opportunities out there, but the approaches that you take, and whether this is around areas like net marine gain, for example, are going to be contextually dependent. They're going to depend on the local environment. So a need to understand that environment. And underpinning all of that is a need for a peer-reviewed evidence base. And this is where organisations like the Crown Estate are really important, because they contribute funding, also to match funding from organisations like the Natural Environment Research Council, which underpin larger programmes which allow scientists to gather data, but that can be pointed in a direction that is going to meaningfully help influence policy. This also requires data sharing. So the industry, the subsea cable industry, providing access to survey data, environmental data, is also really, really important. I should stress I've focused most on the impacts of telecommunications cables. These will differ in some cases from power cables. For example, power cables can emit relatively low-level electromagnetic fields, whereas for most telecoms cables, this isn't an issue. And so understanding those differences, whether it's water depth related, whether it's environmental context related, whether it's type of cable or installation methods, is really, really important. And there are lots of resources which set the scene, provide a lot more detail than I can give in this presentation. So I think John is going to provide in the chat links to the UNEP WCMC report published in 2009, which provides a really nice background for environmental considerations for telecoms cables. If you want to look at the differences between impacts of telecoms and power cables, a good document to go to is the background document published last year by OSPAR that ESCA and others have contributed to. And this provides a nice breakdown of the different sorts of phases involved in cable installation, maintenance, recovery, and decommissioning, the different activities that were involved, the durations of those activities, and the sorts of potential pressures environmentally that may be involved, and mitigation measures that could be placed, what you could do in different circumstances to minimize those impacts. And so I think it's increasingly important that we understand the impacts, even if they are relatively small, in light of initiatives like marine net gain, so we can not only work out how to minimize the impact, but to leave the environment in a better condition than which it's found. So there are some of the links. I think John is busy typing in the links as we go. There are a host of other resources out there. So some of those reports, particularly the OSPAR document, provides links to lots of peer-reviewed studies, which over the past 10 years have included field-based studies, not just laboratory or theoretical approaches. So I think this need to share data, to collaborate between industry, academia, policymaking, and regulatory organisations is really critical. Something that's happened. It's something that we should keep doing. Some of the other resources available through the International Cable Protection Committee include a 6-monthly thematic focus on different areas, so cables and how they could be used to monitor ocean conditions, impacts of climate change on subsea cables, and the indirect impacts of human activities in the deep sea, to name a few. I think that is me, and I'm conscious I'm ahead of lunchtime, so we've got 5 minutes. Thank you very much, and just a reminder, I guess collaboration is really key, and it's one of the reasons why we're so pleased to be hosting this meeting and having so many stakeholders and people from across industry and different sectors. We're excited, and we're here to chat for the next couple of days as well. Thank you.
Thank you, Mike. Okay, lunch is at 12:30, so we're 5 minutes early. But if we can come back at 1:30, that'd be great. Thank
We need to go on one. There we go. Yeah.
1:30.
And we'll then try to, so we'll just say to people like,
Let me ask. Is there any way that the volume could have turned up? Guy was saying he couldn't hear that. So what you we're just trying.
Should be. Let me just say it's. It seems like I'm only hearing this. Try that. Does that work?
We're just like, oh, Doyle, oh, yeah. How you doing?
I haven't seen you for quite some time.
No,
it's good to see you.
And you're doing well. I love it. Yeah, good. Yes. So you've got 15 minutes, is that enough?
Yeah, I'm running back until about 18.
Oh, that'd be fine. No, I'm not going to ring the bell. We'll go straight into the group exercise after.
Yeah,
John's Okay, welcome back. Hope you enjoyed your lunch. So next presentation, presentation from Alistair Hall, BT on route engineering, and then we go straight into the route planning exercise that'll be managed by John. So over to you, Alistair.
Thank you, Clive. Good afternoon, everybody. My name's Alistair Hall. I am a marine route engineering specialist on BT. Prior to my time at BT, I worked as a route engineer at ASN for 4 years. And in fact, prior to that, I was a student in this very building. So great to be back on this side of the podium. I'm going to do a quick run through of route engineering considerations, so things you take into account when planning an initial cable route. And hopefully it's going to give you some food for thought for the route planning exercise we've got coming up in the next stage. There will be a bit of repetition from what we covered in this morning's session, but hopefully there will be a few items that you will learn about in addition. And also I'm going to take a bit more of a global view. We focus mainly on European in this morning's session, but on my background, ASM, I'm more used to working on international, intercontinental projects. So you can see here I've broken up the cable route design process into 3 distinct stages. So we'll start with a desktop study. This is predominantly the focus of my presentation, so I won't spend too much time now talking about that. But as we heard this morning, that's a comprehensive study of all risks and hazards to a submarine cable. The final output of that study is the marine routes survey. So as Andy spoke about this morning, the routes get passed on to the marine survey contractor, who will then conduct a detailed survey of the DTS route, which he provided as the output from the desktop study. This will map out any potential obstructions to the route, it will identify any obstructions to the route that we may not have known about during the design phase. And then we move on to the final route design. So as route engineers, we'll receive the survey data from the survey contractor, and we'll do the final route engineering within the survey corridor. So that is just minor, small adjustments to the routes. If you've spotted, for example, an obstacle or a hazard or a slope within the survey data, you make some minor adjustments. But also part of the final route design, we do a burial assessment. Now, this is very important. You'll hear a lot about this over the next 2 days, but burial is the #1 way to protect the cable. It gives you a physical separation between the cable itself and any form of external threat or aggression. So you may notice in your survey data that you've got sediment favourable for burial, which is fantastic, and you can have a well-protected cable. On the other hand, it may be that you have outcropping rock, subcropping rock, things like that, where the cable may be a bit more exposed. So in that situation, you'll look at using a stronger cable type to compensate for that loss of protection you get from lack of burial. And once that has all been signed off, once your final route has all been signed off, the cable can then be sent for manufacture and installation. So as I said, I was going to focus mainly on the desktop study. So why is this important? A comprehensive study is essential for finding the optimal cable route. So just like everything, the more planning, the more resources, the more time you spend at the beginning of a project, the more likely it is to be a successful project. So we cover a lot of factors in this desktop study. So potential hazards along the proposed route, natural conditions, human factors, and other seabed users, and then geopolitical and environmental considerations, which I'll cover in the next slides. But also as part of the desktop, the initial study is site visits. So looking around the room, I can see a lot of green badges today, so you may be early career starters. And for me, we work in the best industry in the world for travel opportunities. So site visits are the chance where you get to go to site and do an assessment of the landing point. As Nick mentioned earlier, you can do an assessment. Is this a suitable place to land a cable for 25 years? So I was very lucky. I got to travel to South Africa, Ecuador, Madeira, Seychelles, all in 4 years of a route engineer. So it's a fantastic industry if those are looking to travel in their future career. As I said, we're going to now focus on the contents of the desktop study. So, natural conditions, so local geology, seabed composition. So I mentioned earlier the importance of burial for a cable, because that gives it the best protection. So what we try and do in the initial route design phase is identify areas where we will get softer sediment. So the image there in the top left is off of the west coast of Portugal, in Lisbon. This was a project that landed about 3 years ago. We did a study, we didn't do this study, but this was from background BTS research, looking for areas of favourable sediment which would lead to a better buried cable once the installation phase came around. So that's something we take into account. We also take into account the seabed slope symmetry. So it's favourable, as Andy mentioned earlier, to bury or to install a cable in areas of shallow slopes, because if it's too steep, it's impossible to bury with a burial tool. Also, if it's too steep in the deep water, you may get risk of suspensions and future cable damage. So we look for areas prior to performing the survey. We look to plan our initial route in areas of shallower slopes. Oceanographic conditions, so predominantly seabed currents. If you have an exposed part of cable laying on an outcropping rock or something, if you're in an area of strong seabed currents, then it's going to sort of rub on the seabed, and that abrasion is eventually going to wear and tear. You're going to cut through your cable, you're going to have a full cable break. There was recently an incident in Gibraltar, off the west coast of Gibraltar, the cable being exposed to 3 knots of current, and that caused the cable break and a full cable failure. So in the desktop study, we look for areas of minimal seabed currents. Meteorological conditions, so winds and storm events. It's nice for us to have an understanding of the impact a strong climatic event could have on your landing point. So, how exposed is it? Is a strong wind going to wash away the entire beach, and you're going to have exposed infrastructure? So it's important to understand how the climatic events can impact your landing point. That's also useful for planning of the installation. You want to make sure you have your vessels in the area where you get the minimal risk of weather downtime. So you don't really want to be installing a cable, for example, in the North Sea in the middle of January, because you're going to have much more higher risk of high wave conditions, and you're going to have a lot of downtime in installation. And the last 2 examples are quite pertinent because they relate to incidents that have occurred in the last 5 years. So start off with incidents that have occurred in the last 5 years and have caused significant cable damage. So we'll start with mass movement events in the Congo Canyon. Now, I don't profess to be an expert in this topic at all, but we do have Dr. Mike Clare in the room, who's written many papers on this. We have the Congo Canyon. But essentially, feel free to jump in if I'm wrong. And Isabel, sorry. Feel free to jump in, either too, if I'm wrong here. But as I understand that the Congo Canyon is a submarine channel canyon emanating from the mouth of the Congo River in West Africa. Now, conditions of, high precipitation unseasonably high rainfall has caused increased sediment movement, which has caused slumping within the Congo Canyon, which is known as a turbidity current. And this is a mass movement of sediment that moves at astonishing speeds, up to 7 meters a second. and I believe extends west by up to 1,000 kilometres. So that image in the bottom left, all those red lines are, you can just about make out the canyon, and all those red lines are fibre optic cables, submarine fibre optic telephone cables that have been severed recently, I think in 2 events in the last 5 years from mass movement events. So lessons learned, if we're ever to route a cable through this area again, we want to make sure that we have enough separation from the canyon or other areas in the world where similar conditions exist. And then plate tectonics. So tectonic events such as earthquakes and volcanoes, they are rare, but when they do occur, the impact can be catastrophic. So I point you to the 2022 Tongan eruption. Some of you may remember it on the news. I believe it was the strongest or the second strongest volcanic eruption ever recorded. Caused a tsunami which absolutely devastated the island of Tonga. Very sadly, many people lost their lives and hundreds of more people were displaced. But a side effect of the tsunami was the one and only submarine cable that services or connects Tonga to the rest of the world was completely cut off. Not only that, you can see from the image in the top right, the ash cloud emitting from the volcanic eruption disrupted satellite communications. So essentially, the island of Tonga was completely cut off from the world at a time when it required humanitarian aid most. So I think that's a very good example of how vital cables are to the world, and also how important it is that we keep our systems resilient and design them so they're less likely to fail in events such as this. So now we're going to move on to human factors. So this was covered a lot earlier, but we'll go over it again. Fishing is the #1 cause of cable faults worldwide, as we heard in the quiz earlier. And when we say fishing, we mean particular trawling activity. So if any of you aren't aware of what trawling is, it's essentially in the top left image, the fishing vessel is dragging along 2 mobile pieces of equipment on a seabed called otterboards, and suspended between those otterboards is a big fishing net, and it's essentially scooping up everything in its path. Now, these otterboards are in contact with the seabed, so if they run over a submarine cable that happens to be exposed and not buried, then you're going to have a fault. So as route engineers, we try our very hardest to route away from intensely fished areas, because you're only asking for trouble if you're going to route through an area where you're very likely to get fishing damage. Existing and future seabed infrastructure. So the bottom left image is of the North Sea, and that is blue lines you can see on there are fibre optic cables, and the black lines are oil and gas pipelines. Now, I realised from this morning I probably should have plotted the wind farm and power cables on this one as well, but it's a good example of how congested, you can see how congested the seabed is getting. In this case, the world over, there's telecom cables all over the world, there's infrastructure, seabed infrastructure all over the world. And we need to have an understanding of where that is when we plan our cable. Of course, you can cross other assets, other infrastructure, but you have to make sure that you don't hinder any maintenance opportunities for the asset that you're crossing. And there are guidelines published by SPC and ESCA about crossing angles, etc. So all these things have to be taken into account. Landing point infrastructure. Yes. So that comes back to the site visits, as I mentioned earlier. Is it a new landing? Is it an existing landing? If it's new, is it secure? Is it exposed? These are all the things you assess during the site visits or the cable route study. If it's an existing landing, do we have enough spare ducts that connects to the land route? How can you connect to, well, more for a new landing really, how can you connect to the terrestrial network? All things like this get taken into account during the desktop study phase. Port and harbour areas. So these are areas which they experience quite intense vessel shipping activity quite often. To maintain safety of navigation of these ships through the port areas, they will be routinely dredged. So for obvious reasons, you don't want to be routing a cable through an area that's commonly dredged, just asking for trouble. And the same thing, anchorages as well. Anchorages are generally charted, and we try and avoid them. Once again, quite clear why. 50-ton anchor is going to make pretty light work, be a little cable. So anchorages and avoiding them is quite important. It's another consideration to take into account when planning the route. Unexploded ordnance. So for those of you who aren't aware of what that is, it's unexploded bombs and munitions, very common in the North Sea. from remnants from the Second World War. And there's also munitions dumping grounds all over the world. Once again, goes without saying, we don't really want to be using installation equipment or repair equipment near to potential explosives, things that could detonate with contact from a burial plough or a repair grapple or something. So, you know, worst case, you could be looking at loss of life there for people working on the vessels. So it's exceptionally important that we understand where all the UXO is, and we do a study to make sure that the route we're taking is of minimal risk to the environment and also to the people working on the installation. Archaeological considerations as well. So this is maybe not, well, it's still quite important. We have a lot of shipwrecks around the UK, and some of them are maybe national heritage sites. It's important. You may have a permitting regulation or something, and maybe no installation work can occur within 50 or 100 metres of this wreck. So it's important that we understand things like that, shipwrecks and heritage sites that exist near to the landing points. And finally, piracy risk. So this is less of a risk in the UK, obviously, but it's still a genuine real threat in the world. Obviously, most famously in East Africa, Somalia, made famous by Tom Hanks and then St. Captain Phillips. And also it exists in the west coast of Africa as well, and well, all over the world, Straits of Malacca, Indonesia as well. Doesn't really impact the cable routing, I must say, because if you have to route through these areas, then you have essentially no choice. You have to route through these areas, but having an understanding of the risk involved for when the survey vessels are there and when the installation vessels are there can help the project managers, ship captains, etc., plan security and response, and plan and just to minimise the risk from piracy. So these are all the factors you take into account during a DTS that are human or man-made, if you like. Now we're going to talk about environmental considerations. So this was covered in quite a lot of detail earlier in the JNCC presentation. So the ocean is mankind's most important resource, but currently only 8.3% of the ocean is classed as a marine protected area. I think we heard earlier it was 38% of the UK. A submarine cable can be routed through an MPA, although it's often a complicated process with environmental permits, for legislation you may need to adhere to, things like that. What I learned this morning, that should probably be rephrased. So submarine cable can be routed through an MPA unless it's an HPMA, which we learned this morning. No human influence of anthropogenic activity can occur within an HPMA. So as cable yes. Yeah, sorry, that's been reworded. So, yeah, if possible, these areas should be avoided. If not possible to avoid, then early identification of the restrictions imposed is crucial for the success of the project. So you can see in the bottom right there, that's the UK. It's almost impossible to land a cable in the UK without going through an MPA. So in that case, you may look to limit the environmental damage you have in MPA. For example, you may have proposed burial as a way of limiting the damage. You can propose surface lay, which is much less environmentally damaging. Yeah, basically having a good understanding of the restrictions imposed by marine protected areas at the earliest stage, so we can plan and there's no permitting delays. And then the final slide is about geopolitics. So once again, we covered quite a lot of this morning in the Crown Estate presentation, but talking from a global perspective now, every nation state, or at least every marine nation state, is encouraged to subscribe to the United Nations Convention for the Sea, or UNCLOS. This is a legal framework establishing rules governing all nation states' use of the oceans and their resources. And as part of that, it dictates areas of the seabed that can be claimed by these nations, or it can be claimed as part of nations' jurisdiction. So we heard that earlier. If you look at the image on the bottom left, everything from the coastline to 12 nautical miles is known as the territorial sea, or the territorial waters, and that expands to 200 nautical miles for the exclusive economic zone. So when you've planned your cable route, you need to have an understanding of which EEZs you're passing through, because you may have legislation to adhere to, you may have environmental regulations to follow, there may be licensing fees, etc. to pay. And every country is different. So we heard earlier about Ireland. Now Ireland would charge a license, or you have to apply for an installation license, even if you're not landing a cable in Ireland. So every country has different laws, every country has different regulations, and it's good to understand those as early as possible. And then finally, on a related note, there are certain areas of the world which are disputed. So even UNCLOS can't fully define the extent of every nation's EEZ. So just off the top of my head, regions, Congo, Democratic Republic of Congo and Angola, they're all arguing over one patch of seabed. There's a small part of seabed between Spain and Portugal, which is in dispute. But perhaps the most famous example in the world is the South China Sea. There's large parts of the seabed in the South China Sea, which is disputed between China, Vietnam, Indonesia, Malaysia, and I believe the Philippines as well. So you can just imagine what sort of headache this is going to be if you're trying to install a cable in this area. You don't know which nation you should be speaking to. You don't know which permits you should be applying to it for. So really identifying the exclusive economic zones and the potential areas of conflict, dispute at an early stage is essential for the success of the project. It avoids any sort of permitting delays. And that's it. That's pretty much all I had to say. It's a massive topic, and it's one that I can't really do justice within 15 minutes. So I'm here all of today and tomorrow. So if anyone does have any questions, feel free to sound me out. But yeah, thank you everybody, and I'm going to pass back to John.
Yeah, thank you. Okay, now we have a bit of fun. John's going to introduce the route planning exercise. So I'll pass over to John to go through it as to what's going to happen.
Great. So for those who pulled this microphone on, for those who don't know me, I'm John Wrottesley and I'm liaison officer for ESCA, and we're going to talk through the route planning exercise. So hopefully everyone was listening to Alistair's presentation, just because now we're going to do some practice. So we're going to plan a cable route. It's going to be an open discussion split into groups, and everyone will have to consider the various constraints and different factors that go into planning the cable route. So the objective is to move from start to finish. This will make sense when I show the next slide, which is a grid matrix of the exercise itself. And everybody just has an open discussion to consider the different features along the cable route that might impact. It could be a power cable, it could be a telecoms cable. It's up to you. It's for the groups to decide. I say there's no wrong answers. That used to be the case. There is a wrong answer in this slide, so you'll have to spot which one that is if you were listening carefully to what Alistair and Lucy and Paula were saying earlier. The purpose is to just use the information that you've learned during the workshop this morning, and then any questions can be raised either on Slido or in the panel discussion at the end of the session today. So here's the matrix. The purpose is to move from each column. We'll have some speakers, or the speakers have all volunteered to be part of groups, so they'll be there to guide discussion. They might answer your questions, but they're not there to answer questions. It's for everyone to engage, think about it, talk about it, and see what you think as a group. I won't explain each column in a lot of detail. I mean, we've talked about all of these constraints today, and hopefully you'll be able to find some good options there. The interesting point to note is that the MPAs within or marine protected areas within each column have specific designations which might influence your decision as to whether you prefer potentially crossing an MPA with the appropriate measures in place, or whether you prefer looking at a different constraint that might be in the way. So to split into groups, we don't have numbers and we haven't got set groups, so it's going to be a little bit of a case of everyone working out together how best to split. I think if we look at each 2 rows moving backwards, we should end up with groups of around 10, which is roughly the idea. If speakers and those with red tags on notice there's too many with red tags in a group, please move to another group where there are people with fewer red tags or more green tags.
So I think if we can, hopefully, because it's all of us working together, we can all be responsible for a chair. If we turn chairs around, please put us back afterwards. And we've got about 45 minutes for the exercise. And if it makes sense, feel free to go and use the corridor area as well if it's too crowded here. So we'll break into groups. Oh, and sorry, for those participating online, unfortunately we couldn't split into groups because there were too many numbers. So Alistair will be guiding the group online through his thoughts as to how he would conduct the exercise. So enjoy.
I don't understand. We don't understand it. What's marine traffic management? Marine traffic management, that's when you've got like separation, sports, like in the channel. Channel, you've got like channel, everybody going. That's what it means. I just find it.
Okay, so for those who are online, hopefully you can hear me. I think I'm coming through the room as well.
That's going to be a problem.
It's much easier. We can make you quiet, John.
Okay, hopefully everyone online can hear me and hopefully no one in the room can hear me this time. We've taken the exercise outside. So I will hand over to Alistair, who will guide you through what he thinks of the routing exercise and the considerations that he would make. Alistair.
Thank you, John. And hello, everybody. Yeah, it's coming through. I'm good here. Yeah, it's all going to work. And I'm not coming through in there, am I? No. Fantastic. All right, I'll just take this away. Sure. All right. Sorry about that disruption. Yeah. Hi everybody. My name's Alistair. Well, you were just seeing I did the presentation on cable route engineering. So unfortunately, you guys who joined online, there's too many of you. We're not going to be able to break out into breakout groups. So what we're going to do is for this route planning exercise, I'm going to take you through from the start to the finish, and I'm going to talk about each one of these options and give you my thoughts on them. And I think if you do have any questions, you'll be able to submit them either on the chat or to the possibly using the Slido, but I can ask John that later. I'm not entirely sure if that's if you can submit questions to the Slido. But so as John explained earlier, the purpose of this route planning exercise is there's 6 columns here, and you have to choose one option from each column. So each of these options has pros and cons, positives and negatives, and you have to jump between each square to make your final cable route. So, but because you guys can't have a discussion online, so I'm going to talk you through each option and say the positives and the negatives, and I'm going to give you my opinion on what I think I would do. So we'll start off with the first 2 columns. They're quite simple, quite straightforward. So this is choosing of the landing point. So are we going to use an existing landing? Are we going to use a new landing? Or are we going to use a national infrastructure location? So if you don't know what a national infrastructure location is, that is, it's part of the, it's for power cables. So the government or the regulatory bodies dictate where power cables can come to shore, and they're known as national infrastructure locations. So when you're bringing a power cable into the UK, you don't have as much flexibility or choice about where you can land it. But my background is in telecoms, so I've never had to deal with the national infrastructure location. So I deal with existing landings or with new landings. So just because it's a bit more interesting, I think we're going to choose, for this one, we're going to choose a new landing. Just for background information, an existing landing, quite often it could be an old cable that's been taken out, but the ducts remain, the infrastructure remains, or quite often when the BMH, the beach manhole, and the backhaul route was constructed in the first place, there was enough space to land a second cable in there. So that's quite often when you use an existing landing point. But because it's a bit more interesting, we're going to go with a new landing. So column 2 pretty much describes itself or explains itself. We have existing. If it's an existing landing, it's likely to be an existing front haul because the infrastructure is already there. If it's a new landing, it's likely to be a brand new front haul. You wouldn't have a front haul without a landing point. And if it's a national infrastructure location, then you'd have a grid connection. So because we've chosen a new landing, we are going to choose a new front haul as well. So we have a new landing and we have a new front haul, which is connecting the BMH back to the CLS, the cable landing station, and then onto the terrestrial network. Now we have 3 options here. We have, do we route through an MPA, an anchorage, fishing, which is long line and potting, fishing, which is bottom trawling, or a marine traffic management zone. So I'll quickly take you through what all these mean. If you just bear with me, I have a definition sheet for the different types of MPA. If you remember in my previous session, I mentioned there are different types of MPA, which we'll go into a bit more detail here. So just bear with me, I'm going to load up the definition sheet. Right, okay, so MPA1 is an MCZ, a marine conservation zone. And in this situation, it's designated as an MPA or an MCZ because of a geogenic reef. This is a feature that cannot morphologically recover or regenerate from direct impacts. Communities are sensitive because increase in suspended sediment and smothering, because of an increase in suspended sediment and smothering. Sorry, communities are also sensitive to increases in suspended sediment and smothering. So if you do an installation, you're going to upset a lot of the sediment on the seabed, and you may possibly cover this geogenic reef and cause significant damage, irreparable damage to it. And the feature is currently in favourable conditions with maintained conservation objectives. So what we don't want to do, is disturb it in any way. So now we talk about the anchorage. As I mentioned earlier, ships' anchorages pose a threat to a cable and may risk damaging it. So if you drop an anchor on your cable, very likely it's going to be damaged. Fishing, long line and potting. So this is a different type of fishing to trawling, which is what I mentioned earlier. And in my opinion, is nowhere near as damaging or potentially damaging to a cable. So I'm already leaning towards choosing the fishing, long line and potting. Fishing, bottom trawling, well, this is an absolute no-go area, I would say. We avoid that at all costs. As I mentioned earlier, trawling disrupts the seabed, and the more trawling, the more likely your cable is to be hit and damaged. And marine traffic management. So marine traffic management means there's an inshore shipping route with a draft restriction, which means you may have heavy vessels transiting through the area, which means a risk of anchor damage. And there's also potential for the area to be dredged. Because it's a shipping route, we want to make sure that vessels with large draft can Sorry, there's just a few messages coming on screen. If anybody can't hear me, or sorry, if anyone can hear me, can you just write a message in the chat? Because I'm not sure you can hear me right now, but I'm going to carry on. Carry on regardless. Fantastic. Thank you, everybody. I just had some messages crop up on my screen saying that the microphone's changed. Yes, it's a better day. Fantastic. Okay, right. So let's go through the pros and cons of all of these options again. So the MPA, as we said, it's a reef that cannot morphologically recover if it's hit by a direct impact, which it may well be during cable installation. In my opinion, you would avoid going through this region for the risk of damage, because it's been designated as an MCZ where the objective is to maintain the conservation. So you want to maintain the reef in the condition it's found at the moment, and you don't want to damage it. Now, if on a marine survey that you saw that you could actually route around this reef, then possibly you could pass it without actually directly impacting it. So that's a possibility. Anchorages, absolutely. For me, no way. So we're going to cross out anchorages. As I mentioned earlier, we're going to cross out fishing, bottom trawling, and we're going to cross out marine traffic management. So between the two options, because of the risk of damaging the reef, I think we're going to go for fishing, long line and potting. So long line and potting fishing pose less risk to the cable once it's been installed, but it can cause disruption to the fishermen's activities during the installation phase. So it may need a bit of engagement with the fishermen. They may need to clear their long lines. They may need to clear their pots for the installation. But once the cable's gone in, you should be pretty safe. So for that reason, we're going to choose the middle option, which is fishing, long line and potting. Feel free, by the way, to ask questions. I have got my eye on the chat, but for the guy, Rui, who asked how much time expected to finish, I think maybe 20 minutes or so. I'm just going to carry on working through these until we get to the end. But if you do have any questions, feel free to ask, and I will answer them. So we chose fishing, long line and potting. So the next option is oil and gas seabed infrastructure, a pipeline, an MPA, which is an SAC, a boulder field, or a fish spawning ground. Now, I'll give you a few more details on this. So the seabed infrastructure, this includes oil platform foundations and capped wellheads. Pipeline, So if it's a pipeline, we may need a pipeline crossing, and potentially additional construction, because as I mentioned in my presentation earlier, you can cross the pipeline, but the risk of the cable laying on top of a pipeline may cause damage to the pipeline in the long term. So we may need to add in a few more additional mitigation measures. So one such thing is known as Euroduct. It's basically a rubber tube which you can wrap around the cable, and you can lay that on top of the pipeline. You will also need to get a crossing agreement in place with the pipeline owner. So the crossing agreement takes into account not only technical and procedural things, but also legal as well. So it can be quite a drawn out, complicated process. The MPA, which is an SAC, that's a there's a special area of conservation. And this is a special area of conservation designated for subtidal sandbanks. So these features are sensitive to habitat loss, but if it's disrupted, it is likely to recover from short-term impacts. Communities are largely tolerant to suspended sediment and light smothering. The feature is in unfavorable conditions and will restore conservation objectives. So it's in our whoever designated this as an MPA has decided that we need to try and restore this subtidal sandbank region to its natural condition. So in my opinion, it is possible to route through this MPA. It will recover from short-term impacts, and it is tolerant to suspended sediment that may occur from the burial. But it may be that it's a little bit of extra work on our part to restore. Once we've installed the cable, it's a little bit of extra work on our part to restore that region to its natural habitat. Boulder field. So this is, well, the clue's in the name really. It's an area of the seabed which has a lot of rocks or boulders, which can cause an obstruction to the cable. It can also cause a cable suspension if you accidentally lay your cable on top of the boulder field. Now you can mitigate. You will see these boulder fields in the survey data, but you can mitigate for this risk if you can actually move the boulders. So we can identify areas of heavy boulder intensity, and if it looks like a favorable place to bury the cable, we can actually perform a boulder clearance operation. So that's definitely an option for me, the boulder fields. And the final one is a fish spawning ground. Now, fish spawning ground is a very broad term and would require an environmental impact assessment. So it's quite a lot of extra permitting work that needs to be done. We need to know, is it a sensitive site? Is there any specific seasons when we can't install the cable, or is there any specific seasons where there may be higher or lower impact to this fish spawning ground? So once again, quite possible to route through the fish spawning ground, but you will need an EIA in place. So looking at these 5 options, in my opinion, and I would like to stress here, there's no wrong answer. One route engineer may choose oil and gas seabed infrastructure. Another route engineer may choose the boulder field because we can move the boulders out of the way. And if I'm honest with you, I'm torn between the two myself. I would rule out the MPA. I would rule out the pipeline because of the difficulties with the pipeline crossing. And I'd rule out the fish spawning ground. I would probably opt for the oil and gas seabed infrastructure because they're easy to spot and survey. They should also be charted. So usually wellheads and things like that are contained within nautical charts. And so it should be possible to route around those. But like I said, there's no wrong answer. You may think it's a better option to take on the boulder field, but make sure that you move the boulders out of the way, or even find a route around them. You know, if they're spaced enough that you can route around them, then that's great. So now we're on to column 5. You've got high seabed currents. Now, as I mentioned in the presentation earlier, these can cause a lot of damage to the cable. The current can cause the cable to, you see my hand, sort of rub against the seabed. And eventually that abrasion and that wear and tear will cut straight through the cable and you'll have a cable break, a fibre break. Area of known hard seabed. Oh, sorry, one more point on the seabed currents is if the cable is surface laid. Well, no, not even if it's surface laid. If it's just during installation, it can pose difficulty if you're running perpendicular with the current. So you're going in, so you're heading this direction and the current's coming across the cable, then the position you lay the cable may be quite far off the position you actually initially intended to lay the cable, because because of the current forcing it either left or right, or port and starboard, as we say. Known hard seabed. So this is, for me, a big no-no. It may be impossible to bury the cable, which in the future will leave it more vulnerable to damage. And there's not really much you can do about hard seabed. You know, a lot of these constraints are you can mitigate against them. But known hard seabed, it is what it is. It is hard seabed, and you can't really change that. So if there's no option at all, you can use a stronger cable type, but you definitely won't be able to bury. So for me, I would rule that one out. Paul Sutton has asked the question, how should costs be brought into any evaluation of routing? Presumably believe there are difference in cost with a boulder field, for example, and another. How can this be estimated in advance?
I'll see you at
it's a good question. Cost is obviously one of the defining factors for systems. Presumably there are differences in cost with the boulder field. So yeah, so you would budget for mitigation strategies. So your survey could show that you are going to a boulder field and you have no option because there's boulders scattered all over your survey corridor. You would then have to perform an additional operation to remove those boulders, and that would be budgeted in as a sort of contingency cost. But it's a very good question, in fact, because a lot of these options do come with differing, they're not only physical and geographical impacts, but they are cost impacts. So, and you've got to also think of the cost in the future, the cost of a repair, which is why yes, Claire, I can. Column two. Do you mean column 3? Because the column 2 is the existing front haul, new front haul, and grid connection. So the reason I did skip over column 2 quite quickly was because if we chose an existing landing, then we're likely to be using an existing front haul as existing infrastructure. Okay. So the front haul is the route back from the beach manhole where the cable lands back to the CLS and beyond into the terrestrial network. So it's likely if in step 1 we chose an existing landing, then we would be using an existing front haul. It's likely if we were choosing a new landing, it would be a new front haul. So every from the beach manhole back to the terrestrial network would be brand new infrastructure. A national infrastructure location, you would have a designated grid connection by the appropriate authority. We have another question. Could we classify outcropping as hard seabed? Yes, so I'm not entirely sure I understand the question, but if I understand correctly, the survey data you get provided back would be rock, an outcropping rock would be a specific classification. So your survey team or your survey contractor would perform a survey and they would break the survey corridor up into different coloured sections, and each section would be classified. So it could be soft sediment, it could be soft clay, it could be dense sands, it could be soft silt. And these are classifications. So they're specific set areas. And for rocks, outcropping rock, then rock is just one classification. So it does differ slightly. Hard seabed is different. Hard seabed could be something like cemented sand, which is, it's not rock, but it's as solid as rock. And even with a 30-ton plow, you're only going to get like a couple of centimeters burial, maybe sometimes. It's essentially as tough as rock, but it's not actually rock. It's like cemented sand. So Your survey contractor will give you these classifications as part of the survey deliverable report. And just jumping back to Paul's question, sorry, I'm a bit all over the place here, but jumping back to Paul's question about the cost, you have to weigh into the equation the cost of a repair. So this is why for column 5, I would specifically avoid the area of known hard seabed, because you're not going to get burial there, and therefore you're far more likely to have a cable fault, and the cost of a repair can be in the millions. So you're thinking about cost, long-term cost as well. When you make these decisions. Spoil ground. So just jumping back to column 5. So we've covered high seabed currents. We've covered known hard seabed. Spoil grounds is a thank you, Paul. Spoil ground is a dumping ground of area of disposed waste or dredged materials. So it's essentially anthropogenic waste that gets dumped on the seabed. Could risk containing disturbed contaminated sediments. So I can't think of an example off the top of my head. Possibly, I think off the west coast of the UK, there's there are radioactive waste dumps globally, I believe. Oh, and chemical weapons. I mentioned earlier in my presentation, there's munitions dumps. You do get chemical weapons dumps as well. And there are some dumped off the west coast of the UK. So disturbing that could have a significant environmental impact. So that's probably best avoided in the desktop study stage if you realise there's a risk of, releasing these contaminants. There's a known radioactive plume at Donrier in the north of Scotland. Thank you. I did not know that. I've never done work in the north of Scotland. But there you go. So you don't really want to be installing a cable or using heavy burial equipment near to these radioactive plumes, because, well, obvious reasons really. You don't want to disturb the ocean or poison the ocean or poison the fish. So for spoil grounds, if you've done enough research during the desktop study phase, you should be able to identify where they exist and route around them. But there may be questionable things that come up in the survey which may require further specialist evaluation. So steep slopes, these are bad for installation. Mohammed, how could we define the required cable protection along the cable route? Good question. Generally, it's specified as a depth of burial. So when I worked for Alcatel, we would have clients and they would say, we want 2-meter burial across the whole route. And that would be the level of protection. And if I'm honest with you, there's no real science behind that. It used to be 1.5 and now it's become 2. I just think people seem to think deeper is better, but it's a bit, in my opinion, it's a bit more complicated than that. I would say 0.5 meter of very dense sediment, like dense sands, is going to offer just as much protection as 2 meters of soft clay, for example, because an anchor, for example, or something like that is going to penetrate far deeper than, or in soft clay than it is in like dense cemented sands and stuff. So it should be the burial depth consideration should, in my opinion, be a bit more technical and fluid. You shouldn't just say 2 meters everywhere. It should be, 1 meter here or 1.5 meters here or something. But for the question, required cable protection along the cable route, as a route engineer, you would make an assessment of how deep you think you would bury, based on the survey data that you have. And if you don't think that that level of burial is going to give you the protection that you want or your client wants, it's at that point you consider up-armoring the cable. So in my presentation earlier, I used the example of a surface lay because it was simple to understand. If a cable is completely exposed on the seabed, then you may want to, well, it makes sense to use the strongest cable type possible, but it goes, sometimes if the cable is only buried by 10 or 20 centimeters, you'd still be looking at using a stronger cable type there. But it's all an assessment really of the risk. If we're talking about we're talking about equipment penetrating the seabed, so anchors and trawling. But if you don't think it's possible based on the strength of the sediment for those equipment to reach your cable, then possibly a lower level of protection is acceptable, because obviously greater protection comes at a greater cost. Depth of burial specifications need to consider how difficult recovery. Absolutely. Very good point as well. In a very good point, Walter. Sometimes, well, burying the cable, we use a big 30-ton plow, which has a lot of strength, a lot of force to bury the cable into seabed sediments. But when we recover the cable, we use a much lighter piece of equipment known as a grapnel, or we can use a detrenching grapnel, which is slightly stronger, but it does not have the same force of a plow. So if you bury your cable to 1 meter and it has a failure, then you're going to really struggle to pick that cable up again using traditional burial techniques, traditional recovery techniques such as grapnels. So sorry, yeah, I didn't realize that. Okay, so I thought you could all see the comments. So Walter has asked that has not really a question, but he's stated that depth of burial specifications need to consider how difficult recovering the cable will be in case of damage or repair. So it's a great point. You don't want to bury it too deep because it might not be possible to recover again. Mohammed asked about how could we define the required cable protection along the cable route. So that was what I said about depth of burial depth of burial examples. Claire pointed out there's a known radioactive plume in the north of Scotland, so that relates back to the spoil grounds. And Mohammed also asked about classification of hard seabed compared against rock. So I hope, Anne, that has kind of made a bit more sense. What I'm just seem to be going off in all sorts of different directions. It's because I'm answering the questions. So Jacques Hartman, how likely is an anchor to break a cable? I've heard stories suggesting that it's very difficult to break a cable with an anchor. Well, once again, it comes down to the level of cable protection, but I would not say it's very difficult. Anchor breaks are common. The recent story in the news in the Baltic Sea was caused by an anchor dragging. So the cables that got severed between, was it Finland and Lithuania? In the Baltic, I think it was between Finland and Lithuania. They were severed by an anchor being dragged along the seabed. Quite recently, well, about a year ago, a vessel in the Red Sea was sunk by Houthi rebels, and it had its anchor deployed. And as it sank, it dragged its anchor across the seabed, and it cut 3 fiber optic cables in the Red Sea. So it's definitely possible for an anchor to damage a cable. But also it does depend on the size of the anchor. If it's a small pleasure yacht, then probably not. But if it's a big 50-ton anchor of like a cargo ship, then yes, definitely possible. Yep, thank you, Walter. So Walter's pointed out perhaps also defining what steep slopes over 5 degrees means in this context. So for me, anything steeper than 12 degrees would class as steep. That's for burial. Your burial tool won't work as effectively. Well, in fact, it won't work at all. It's too steep to bury. It's just too dangerous to try and bury in slopes of over 12 degrees because you could run a risk of the plow just running away with itself under its own weight. So when we look at cable burial, we don't bury if the slope is greater than 12 degrees going down and actually 14 degrees going up slope. And then for the deep water, where we don't bury the cable anyway, and it's just surface laid, we consider anything above 20 degrees to be steep. Lateral slopes, thank you, Walter. So lateral slopes, we mean them as side slopes. So that's if you are burying parallel with the contours. So if you're running parallel to the coastline or with the contours, you can't tolerate, the burial equipment can't tolerate a side slope of over 6 degrees. So it's actually a very small amount. If it gets a side slope of over 6 degrees, it's a very good chance it's going to topple over and you're going to have a damaged cable. What's the max slope which is considered moderate risk to lay the cable? That's from Claire. Claire, are you talking about burial here or surface lay? Because for burial, then I said 12 degrees. That's an absolute maximum. If it starts to get to about 10 degrees, you start worrying about it because you can't 100% rely on your survey data. You know, if it's 10, it could be 11, and all of a sudden, if it's soft sediment as well, there's much more of a risk that the plow is going to run away in soft sediment than hard sediment. So it does take into account a lot of different variables. Yeah, and just in the surface lay areas, the steeper the slope is, steeper the slope. Pretty good, pretty good. I'm on column 5.
We're moving to coffee at some point. So.
Okay. Okay, I'll wrap up quite quickly.
Carry on.
Okay, sure. Oh, have a great time, yeah. Yeah, and in the surface lay areas, the steeper the slope, the greater the risk of suspensions, as Andy's presentation said earlier. So at the landfall section, I'm hoping you mean the shallow water, because that kind of answers itself with the burial. Basically anything approaching, I'd say 10 degrees and above, if you're looking at burying the cable, you start worrying. Let's just jump back now quickly to column 5 because I may need to hurry up on this session. So steep slopes, and then the final one, HPMA. This is, as we mentioned earlier, an HPMA is an absolute no-go zone. So this is a highly protected marine area. No anthropogenic, no human activities at all can be performed within this area. So we can instantly cross off HPMA. There's no way we'd be allowed to route our cable through an HPMA. So we have to make a decision on column 5. And in my opinion, I wouldn't do known hard seabed because you'd have exposed cable. I wouldn't do high seabed currents because you're asking for trouble if you don't get. Oh, we've gone to a break. I'm just going to get John to put the presentation back on the screen, so bear with me. Yeah, I'm going to ask him to jump back so we have the screen again. Bear with me. Sorry, looking for trouble. Oh, thanks. Hello, everybody. I am back. We have the screen back up now. So yeah, as I was saying, I would avoid high seabed currents. I would avoid known hard seabed, and I'd avoid HPMA. I would probably go for the spoil grounds here because if you do thorough research in the desktop study phase, you should have enough information to know how damaging and risky that those spoil grounds may be. And also in the survey data, you may identify them and be able to route around them. So I'm on column 6. I'm just about to finish. Do you need your laptop back? Yeah. Who's using your laptop? Yeah. Yeah. Sorry, everyone. I'm just on column 6 now. We are just going to finish off with column 6. So we have in-service cable, out-of-service cable, traffic separation scheme, MPA, which is an MCZ, or UXO. So in-service cable is an in-service telecom crossing. This is generally a lot more straightforward than a crossing of a power cable or an interconnector. A telecom to telecom cable is normally just a simple notification saying we're crossing you at this point, at this angle, at this water depth, and this is our cable type. It's a lot more simple, straightforward process. Sometimes people push back. Sometimes people say, can you move the cable? Can you change the angle? But generally, they're accepted. So in-service cables generally aren't a problem. Out-of-service cable crossings, these aren't a problem either, but you do have to identify the cable owner and just let them know that you'll be installing over the top of their out-of-service cable, and let them know that you're going to cut it and clear it out of the way for the installation. Both those two options are very simple, and as route engineers, you do them all the time. Traffic separation scheme, generally you're probably going to have, this is a high density traffic separation scheme, and it's going to be a major shipping route, which is going to mean slow moving installation vessels in the navigation lane and possible anchor damage. So I would rule that one out. MPA, which is an MCZ, which is a marine conservation zone, I think. This has been designated for multiple broad scale habitats, including coarse sediments, sands and muds. Includes specialist habitats and species, communities moderately sensitive to disturbance. So really, we don't want to be disturbing natural communities. Habitat change, a more significant issue, which is potentially what we will be doing with the burial tool. And then conservation objectives are to maintain the area as it is. So I would avoid the MPA. I don't like the sound of sensitive communities, and I don't like the sound of maintaining habitat change to a minimum. And UXO, finally, is the one that I spoke about earlier, unexploded ordnance. If you've done a thorough enough study, it's okay to route near to these, but you need to be absolutely sure that what you're doing is correct. Because if you accidentally detonate a munitions, a dump munition, or a bomb, then you're in a whole lot of trouble. So there's a lot of research out there on UXO, so it is possible to identify which are the more threatening and dangerous ones. But still, it's still a risk. So for column 6, I would choose either in-service or out-of-service cable. It really doesn't matter. In-service is maybe slightly more of a problem because the cable owner could push back on you. But out of service, it's just a simple notification, and then you cut and clear. And that basically means you cut the cable and you clear it from your route. So, and you weight it off so it's not going to get disturbed or move anywhere else. And and then you just install through the gap that you've cut. And there are guidelines provided by ICPC for cut and clear, now how it's done properly. But yeah, so for column 6, I would choose in-service or out-of-service cable as my final decision. I think that is everything, and all the questions have been answered. Zohaib has asked, sorry, excuse my pronunciation if I've got that wrong. Can we have a chart with descriptions and definitions and abbreviations? We can provide that, but just for this exercise, I'll run through them quickly. MPA is Marine Protected Area. MCZ, Marine Conservation Zone. I think I may need to Google that one. MPA SAC, so that's a Special Area of Conservation. And HPMA is a highly protected marine area. And UXO is unexploded ordnance. But I think that is all we have time for in this session. So thank you all for joining online. Everyone else here is having a coffee break. So you guys who have joined online, thank you for being patient with me. And I hope that was a useful session. And yeah, go grab yourselves a coffee, and we are going to rejoin the rest of the session at 3 o'clock. So yeah, thank you everybody. And I hope you found it useful.
Depends what you call it. Okay.
Finished. You're still online, by the way. Are we muted? No, I don't know how to mute.
Okay. Right. Asking a question before your presentation. Do you have a question? Do you have a question?
I'm all good. So I'm going to try and sort of follow on from our routing workshop and talk a bit about the cable ships, equipment and engineering that goes into actually installing a cable. The aim of all the following equipment is to create a resilient, reliable cable system at a low cost with minimal impact on the environment. Sort of try and bear that in mind as we go through what will be a lot of photos. So we've got our initial route, got our routing desktop study. We now need to start looking at it in a bit more detail, planning to get the cable system in. Well, if it was 1855, we've got our initial route, we're done. Straight out there, across the ocean in a wooden ship and lay the cable behind us, hope for the best. And that's one of the reasons they didn't last very long. So these days, we try and do a bit more investigation. As a background, I'm sure some of the ladies and gentlemen will not be able to give you more information on this, but sadly, the sea is quite unknown. There's still a lot to be discovered. So you're entering an unknown environment, which is one of the reasons you do a marine survey, as was discussed earlier by some of the other presenters, using vessels like this. They vary in size, shape, form, function across a wide variety, all the way from vessels like the Strill Explorer, which can deploy very large, heavy geotech equipment, down to small unmanned vessels that might fit in a suitcase, and all the way in between. The first kind of survey we do is probably a geophysical survey, which is using sound in the ocean. Light doesn't penetrate very well, to examine what's there. The two classic techniques, there are more, are multi-beam, seen in the nice multicolored image with the ship taking a swathe, similar to the previous presenter, and side scan, where you've got a towed vehicle, typically, but there are other methodologies, towed behind the ship, looking at the sediments that you see beneath on the seabed. You can see in the bottom part underneath the side scan a little example of a diagram of how it comes out. You see reflections in different intensities from different substrates. We can give you some information on geology and obstructions in the seabed. We also do geotechnical investigations, which is looking at the seabed itself, taking samples of the seabed and examining them. You can see a vibrocore being deployed on the left-hand side and a variety of grabs on the right. These are impactful surveys, i.e. they have an impact. You need a license from the Crown Estate and others, or wherever you else might be in the world, often to do this kind of survey. Whereas geophysical, the impact is more just sound, and the licenses tend to be a bit lighter. We're doing these surveys to examine the seabed and to examine and think about how the external threats might play out through the cable. If we're going to bury it to protect it, what threats are we burying against? Got an anchor, a volcano, and some fishing. Some you can protect against, some you can't. If you lay over a volcano, that's a routing mistake. And what we're trying to avoid is cable damage. Cable damage is very expensive. Telecoms cable might cost you $1 million to repair. Power cable might cost you $100 million to repair. It is a very expensive mistake to get them broken. You're trying to avoid it. In order to avoid it, we do things and we study the risk and threats and the seabed we're burying in things like cable burial assessment, risk assessments, and burial assessment studies. There's some really good guidance from the Carbon Trust on on this if you're interested for future reading, or find me sometime to have a discussion about it. So we've got a route, we roughly know what the risks are. We need to prepare the route. We can't just go out and lay. There'll be problems in the way. We discussed boulder fields briefly in that routing exercise. These can be cleared sometimes by things like the grab you see on the side. We talked about out service cables and fishing gear. They can be cleared by PLGR or pre-laid grapnel runs. You can see a pre-laid grapnel equipment on being hoisted into the air. Apologies, the background doesn't make the best photo, but hey. So we've done a route, we've done a survey, we have a rough idea of what's there. We've assessed the threats. We've made a realistic appreciation of those threats and the risks they pose to our cable. So we've planned a burial around that. We're not going to bury everything to 2 meters deep just because we can. It's really expensive. Looked at the risk to the cable in that area. We've decided how we're going to bury in that area, depending on the geology and the risks there. We've cleared the route. We've got a route ready. So now we need some cable to lay in it. So there are different types of cable. There are a few outside I saw on a table somewhere. I know there's a few other bits lying around in the room. We can see the 4 different types of cable that are perhaps most commonly laid. Although 3 of them are current, and 1 is a little bit more historical. You've got a HVDC power cable, cutaway in the top left, a fiber optic cable on the right, an HVAC cable on the bottom right, and a very old telegraph cable on the bottom left, which is, there are still telegraph cables in service or in the sea, so though they are definitely somewhat obsolete. These are not to scale. Fiber cables can be very small, HVAC cables are very big, and HVDCs are somewhere in between. We now need a ship to lay that cable in the sea. We don't use divers or anything else. These cables weigh a lot, and you can't sort of carry them over your shoulder, so we need a ship to lay them. These are examples of telecom ships. I'd like you to just have a look at the shape of those ships and think about what they're designed for. We talked about telecom systems going transatlantic, going around the world. Those ships are ocean-going ships, mostly designed for laying across oceans. By comparison, power cables historically were laid off barges, very suitable for shallow water, short lengths. Power cables are very heavy, you need to lift a lot of weight, and they're very difficult to join together, so you want to have as fewer joints as possible. So you want a shallow draft ship that can lift a lot of weight and lay for a relatively long time without joints, but is not really worrying so much about the weather. As power cables have got longer, barges got slightly more seaworthy and turned into what we might describe as more oil and gas style flat back ships that can operate in areas like the North Sea. And they develop and develop as time goes on, getting closer and closer to this telecom ship as the power cables get longer and longer and go into harsher and harsher weather. And perhaps in the future you'll have ships like this, which are a similar ship shape to those telecom ships we saw on slide 1, designed for laying power cables potentially as far as fiber optic cables. This is a really useful photo of a power cable ship called the NKT Victoria. The reason I really like it is the direct top-down view. It shows you how the ship is split up into different bits. At the front, you have a helipad, which hides underneath it all the accommodation, and underneath that's cable storage for the ship. So all the people are living, and most of them are actually working in that front part of the ship. So that's where your bridges controlling the ship, or your offices and living accommodation. In the middle, you have cable storage. You can see a large carousel with cranes over the top. In the middle, which is where all your cable is stored. I hope online you can follow this with the mouse as well. And at the rear, you have your cable working deck. This is where your cable is deployed, jointed, and handled before it goes in the sea. You can see some examples of the equipment we use to handle cables. This is from a telecom ship. On a power cable ship, they'd be a bit bigger. On the left, you have a drum, which you would wind cable around. It would use engine, drive it to haul the cable and control it. And on the right, you have a cable engine, what's called a linear cable engine, to do a similar thing in a linear motion. Sometimes we can get away with quite small machines to move our cable around. In the foreground of this photo, of the back deck of a ship, you can see a little wheel. There's actually another one slightly hidden underneath the 2 bollards in front of it. That's a wheel pair, just 2 tires powered to move, in this case, telecoms cable around the ship at relatively low tensions and relatively low weights. You can see the back deck of a ship can be very busy. There's lots of equipment and containers obstructing it, but if you take all that off, it is in essence a flat area for working. Cables don't just come in one long length. We lay all of it at the same time. Well, not very often. So we have to joint it together. So you can see on the left a cutaway of halfway through a power cable joint. You're unlikely ever to see this in your career. The manufacturers are pretty secretive about how they do this, but it's a very important process in the installation process. It takes a very long time on power cables, even some time on telecoms cables, but it's a very technically precise process that needs to work perfectly. And in the case of power cables, it will take a week to do. So your ship is sitting there for a week doing this joint between two parts of the cable. On the right-hand side, we have a similar sort of thing in telecoms. In this case, it's a repeater. Telecoms cables don't need to have equipment beneath the sea to help boost the signal. Please ask someone else how it works. To make sure that the signal reaches the far end across the thousands of kilometers they operate. So you can see a repeater being deployed. And the ships and equipment have to be able to handle not just cable itself, but also these joints and repeaters, which can add width to the cable and a lot of weight to make it more difficult to handle, and your ships and operations have to be designed around that. These also form some of the weak points in our cable systems. This is where failures are more likely to happen because you have either a joint or a repeater, which is a point of failure in your system. So we finally got our cable down. It's on the surface. We've done it as a lay. Well, I've borrowed a beach photo because it's quite hard to take good photos underwater, but you can see how the cable is sitting on the surface. But if we leave it like that, this might happen. And you get a nice anchor come along and take your cable with it. So fortunately, the person dropped their anchor this time. It didn't damage the cable too badly. But you can see the anchor in the slightly murky waters next to that, which is something we don't want to have. So we've got to bury it. In telecoms and today, somewhat in power cables, the cheapest and most efficient way to do that is probably with ploughing, which is sounds a bit agricultural, but is forcing the cable beneath the surface. The ploughs, in this photo being deployed, doesn't look that big, but they're actually quite large bits of kit. Hopefully you can see the people scale. And if you had a power cable plough, these telecoms, they would be 2 or 3 times bigger again. So they're very large bits of kit using weight and being towed behind ships to bury the cable beneath up to 2-3 meters beneath the surface. Alternatively, slightly more expensive, but again, very common. You have jetting. This uses high pressure water jets. The photo on the bottom right, you can see the jets being tested, so you can see the jets of water being fired out. That's why I borrowed that photo. But the other, you can see roughly that kind of tool, which is high pressure water to fluidize the seabed and drop the heavy cables into the trench. If you're in harder seabed, and typically these are reserved power cables because it's a very expensive technique, you can use a cable trencher. This uses a mechanical cutter. See a nice example of on the top right to cut a trench. The advantage of this is the trench tends to be very narrow, which means it's very hard for other things to fall in it. With a plough or a jet, you want to cover with sediment above your cable. With a cable trencher, cut trench, you might not. You might assume the cable is well protected, even though, as you can see here, it's got no cover, the cable just sits on the trench. That is because the trench is so narrow. That trench is probably only 50 centimeters wide, which means that anything coming across to catch your cable, like an anchor or fishing gear, is likely to go across the top of the trench. Whereas a jetting trench or a plough trench might be more V-shaped, wider, and allow gear to go down one side and up the other, which is why when we're burying with ploughs or jetting, as in previous 2 examples, we want to see some cover with sediment above our cables if at all possible. If none of those techniques work, the more expensive way of protecting it is with hard external protection, such as rock placement. As an example of a rock placement vessel, you can see the large tanks of rock effectively behind the bridge. It's loaded from a quarry somewhere like Norway, typically, and then it's laid on the seabed and gets colonized afterwards. It's not historically that could be quite a crude operation. I've seen pictures of people using bulldozers to basically bulldoze rock off barges straight into the sea, but today it tends to be a very highly controlled and precise operation. You can see the control station for a rock placement vessel. The guy's got more screens than he knows what to do with, and it is done incredibly precisely. They can direct the rock right underneath the cable in suspension, for example, and it's done very carefully. We can also use things called mattresses, which are concrete blocks tied together. In different scenarios, rock placement can be more or less effective than a mattress, and particularly at crossings, these are a very common tool to provide separation between different assets to avoid abrasion. Once we've laid it, we want to check it's all done properly. So we use some as-built survey equipment, such as this. This is an ROV, work-class ROV, and on the front of it, that black frame is what's called the TSS frame. Please, there isn't an acronym for it. It's one of those weird ones. But it's basically used as an electrical signal to detect the cable and determine how far down it's been buried. Sometimes the permitting authorities have conditions on your installation that tell you how far and how deep you have to bury a cable, and you need to check that's been achieved by your contractor with a tool like this. It's also useful for finding faults, similar tool, and for examining how well protected your cable is. We need ships and operations to maintain our cables. Now, we've got 2 ships here doing a power cable repair right next to each other, quite a complicated operation, and with simultaneous operation between 2 large vessels in very close proximity, as you can see. But if you zoomed in far enough, forgive the guys at the back, maybe some of the guys at the front can see, the ship at the front is the NKT Victoria, the same top-down installation ship I showed you earlier. In power cables, we almost always use similar ships to what we use for installation for maintenance, at least currently. Whereas in telecoms, they have ships more dedicated to repair and maintenance. As I think Peter said earlier, there are a lot of repairs in telecoms. I'm not the right person. There's about 100 a year, and therefore it makes sense to have dedicated vessels doing that. You can see several examples. Some of these vessels are purpose-built, and some of them will be converted from other vessels, such as ferries, or at least in one case, tank transport. To do that repair, we have to get the cable off the bottom of the sea using things like in the telecoms industry, commonly grapnels. In the power industry, it's more commonly using ROVs. We bring them back on board the ship. See the cable being brought up here from with a grapnel chain. It's actually Rennie and Gifford's off the grapnel run, and brought back on the ship, cut, damaged section taken out, a new working section of spare put in place, and then it's laid back on the seabed. And when you lay it back down, because you end up with an extra loop of cable that looks something like this on the seabed, and you can see the Omega pipe being deployed in the quadrant on the right. This is quite a tricky operation. You need a big crane and careful control of tensions to lay that down safely. Finally, your cables are eventually going to get to the end of their life, and we do decommission. Particularly telecoms cables, where there are more of them, and more of them have got to the end of their life. It is it's commonplace nowadays for cables to be decommissioned or recovered for their scrap value and recycled. Particularly old telegraph cables have a lot of copper in them, and power cables certainly in the future will, that are economically viable to go out, recover, and recycle for their raw material value, scrap value. That was quite a run through at speed. I do apologise. That is the whole life cycle of a cable as fast as I could do it, covering as many bits of equipment I could. You could spend hours on each section of that. I hope it was helpful. If you have any questions, please do find me at some point. Thank you very much. Also, if you're online and you want to send a question to Slido, please do. Alternatively, you can email me. Emails there. Thank you. Okay. Oh, I've been even quicker than planned. Yeah, that's good.
Okay, any questions for Matt? Oh.
Nailed it then.
There you go.
Obviously. Thank you.
Okay. Hopefully you enjoy your tea towels when you get home. It's just the Gisolka map that we've printed onto tea towels, and obviously there's the Gisolka website that you can go on to find out more information about Gisolka, but the links are on the website, our website as well. So, okay, over to Richard Hill with a presentation on subsea cable landings and the differences between power and telecoms. So over to you, Richard.
Thank you, Clive, and thank you, Matt. Really informative. So my name is Richard. I'm a mechanical engineer, which is a bit of a strange beast in this area, but hopefully Matt's presentation starts to show you some of the range of equipment that's involved. So I'm going to do a little bit about cable landings and the differences between telecoms and power. But for me, I've been fortunate. My career is 30 plus years. I think I'm about 2027 with BT, and then probably 6 or 7 with Guernsey Electricity, and now more recently with Waves Group, where we sit as a marine warranty surveyor, which is trying to stop things go wrong before the operation starts. And then we get involved in what we call casualty, or casualty response, which in the shipping term is when ships go aground and into salvage. But in a cables world, and especially a power cables world, it's when the power cable goes wrong. We've heard big numbers being banded around, like 10 million or 100 million for repair. At the end, someone needs to pay for that. So we'll get involved in the sorting out of who pays what towards those repairs. And we also do a little bit of consultancy, which just tries to tie up the loose ends and feed the lessons we've learned back into the front end. So I thought I'd start with a safety moment. A photo courtesy of BT. It's a classic shore end photo. It's a nice, flat, calm day. There's no swell. The landing's about to go ahead. That's Sovereign out in the distance, and there's a digger in the foreground. And that's to remind me to tell you about when things go wrong. So at the start of the day, I got that on my WhatsApp, and I thought everything's going to be fine. What can go wrong? I carried on with my day. About 4 o'clock, I got a call from the contractor. Yeah, Richard, we've got a problem. The digger's broken down and it's a bit wet. Okay, what does that mean? Well, we're not quite sure yet. It's early days. And about half an hour later, I got a call from their beach master, who I've known for years. He phoned me up. Yeah, Richard, the digger's learning to swim. Okay, tell me more. We're not quite sure, but we think it's broken down. Okay. And then about half an hour after that, I got a call from our rep, and he said, yeah, the digger's underwater. Okay, what happened? Don't really know. One guy says he was the wrong side of a rock bank and couldn't get back. Another guy says the digger wouldn't start, but I think they ran out of fuel. And the point to all of this is, if things can go wrong, they will. And on a landing job, there's lots to go wrong because you're working in the intertidal zone. So it's complicated. So just take your time. So setting the scene. My favourite stop the job moment goes back to a shore end in Africa, where I had to write on an email to my boss, dear Keith, full stop, zebras on manhole. Try again tomorrow. That was it. And as a number of people have alluded to, we are all so fortunate to be working in this fabulous industry. What could be better than being flown around the world to exotic locations to land a cable and play on the beach with diggers? On that particular zebra job, I arrived to coincide with the ship. The ship broke down in Cape Town, so I had a week in Durban to amuse myself, courtesy of the business. What else could you possibly want for a job? It's brilliant. And the disclaimer that goes with this really is a high-level introduction. There are many tools, there are many techniques, many methods that have or will be used. Probably it's been done before, and I'm just trying to give a little bit of an overview, a little bit like Matt, about the equipment from a mechanical engineer's perspective, because it really is a multidisciplinary activity. You'll find electrical, optical, transmission, mechanical, mariners, and they're all part of the team that goes to make this great business work. So 2025, I did an internet search. John gave me the title. I went to ChatGPT, other search engines are available, just to find out what it thought. And at a high level, telecoms is data transfer, power is electricity transmission. What's difficult about that? They're pretty similar, just different scales. And the infrastructure, we've talked a little bit about cable landing stations from a telecoms perspective. That can be as low key as just a manhole, or maybe a green cabinet you see at the side of the road, up to a full international cable landing station, which is a big building. Once you get into the power world, everything ramps up. The scale increases, you might need a substation, or if it's a big HVDC, international interconnector, you'll need a big converter station. So it's about size. Telecom, quite compact, smaller facilities. Power, we're moving on up in the scale. So there's been a lot of talk today about environmental impact, and telecoms, ChatGPT, minimal. Power, higher due to size, burial requirements, heat and EMFs. So I put the asterisks there. This is just my opinion. I think, yes, these are legitimate impacts, but they are relative and proportionate. And it really depends on the cable that you're looking at, how much power is being transmitted, and a whole range of other factors. So don't get put off by those words. So you've seen a few 101s. I'm going to do cable landings 101. The landing covers a section of cable between the manhole on land and the offshore installation, which Matt talked about. And I've mentioned the intertidal zone. If you look at the diagram on the box to the right, you can break that down further into the spray vert zone or a splash zone, a high tide zone, middle tide zone, a low tide zone. And the key here is the sun shines, so you get light. So you've got a lot of environmental things going on. You get a lot of growth. So some of the BT guys are here that used to hear me talk a lot about dry, damp and wet. That's the terrestrial side, the intertidal and the offshore. And the landings covers that intertidal bit where the tide goes in and out, and it's really difficult to work because 1 minute it's dry and the next minute it's not, as we saw earlier with the digger that went for a swim. And it's often the highest risk section. So it's shallow water, it's close to land, there's a high risk of human interaction, and there's a whole high energy ecosystem going on. So a lot of potential for wave action, high current regimes. It's often a harsh terrain. And as a few people have mentioned today, sediments can be mobile. So some of you in the room may recognize this. This is Sennen Cove in Cornwall. Classic transatlantic landing, lovely sandy beach. It faces the Atlantic, so it's got a direct route to the States. There's a bit of surf running, but not too much. Nice and rural, fairly safe. What could be wrong with that? And they're lovely jobs. But that was summer. And this is winter, same beach. Looking the other way. If you look along the foreshore, there's no sand. All the sand's been washed out during a storm. And the image of the waves just shows you the power of the sea. So if you take one message away from today for me, it's nature always wins. You've got to find a way to work with nature rather than try and beat it. So cable landings 101, a typical landing. This is a photo of a telecoms cable going to the Isle of Wight. Can't get more local than that. It's Isle of Wight 3. And this one photo shows you the basic typical landing technique that applies across telecom and power, although the scale is different. You have a vessel or a barge standing off the beach. You'll have a small boat that lands a messenger rope to the shore. And that'll either go onto a winch or around a quadrant. And then the cable will be slowly pulled ashore on floats. And the excavator, you can see, that will hopefully bury the cable in a trench. And then the cable end is pulled through a duct and terminated in a manhole on land. And that's about it. Except every beach is different and every cable is different. So those basic principles run through, but it can be complicated. So I'm going to focus on the equipment and the scale of the equipment a bit. And we've talked about permits and regulatory. So the picture on the right is a typical telecoms landing. They wanted 2 meter burial. We decided as a client we wanted 2 meter burial. It's quite easy to get to with a digger and not too much of a job. On the left, this is a power cable landing in Holland, and the regulator decreed a burial depth for them, and they started at 9 meters at the head of the beach, and they went down to 5 meters across the beach, grading up to 3 meters into the wet zone. So suddenly the scale of the activity goes up. You're into multiple diggers, you're into shuttering, you're into sterilising large areas of the beach during weeks. So they will push you to when you can or cannot install. So the whole scale of the operation changes by a simple increase in burial depth. And that's called open cut trenching, which is sort of the basic, cheapest starting method. The alternative to that, and a number of people have mentioned today HDD, which stands for horizontal directional drilling, and it's a low environment impact method of installing cables. Effectively, from land, a drill and a drill pipe is used to bore a hole out to a predefined punch-out location offshore, and they can do that really accurately, to within about a metre or so accuracy. And then usually a duct is pulled back through that hole as the drill is withdrawn, and that'll have a messenger rope inside it. Sometimes that drill pipe might be left, and I know some telecoms companies will use the drill pipe as the bore. And then the cable is pulled back through the duct using the messenger rope from the vessel offshore back towards land. Same again, the cable is jointed to a land cable in a jointing bay. The offshore end of the duct is sealed and buried. So if you've got a really sensitive environmental area, it's a great way of getting past it, but it's expensive, and suddenly budget comes into play. So whilst it might be ideal from an environmental perspective, it might not be ideal from a business perspective. There's been a lot of talk of burial, and there's always a preference for burial. And in some places, there's a requirement to bury from your regulator, but sometimes that's not always possible. This is a recent shore end, and in a particular part of the country, this was in Scotland, and the particular islands this was between, there just wasn't any sediment. So sometimes you have to surface lay cable, and that's okay if you know about it. Rock armour cables exist for laying over rock, and on this particular picture you can see there's got these cast iron shells across it. They're a remedial protection, and they provide extra stability as well as extra mechanical protection for the cable. So I'm going to stress it really is not preferred, but I felt I couldn't talk about shore ends without saying sometimes it is the only option. So you just have to be aware of that. There isn't the perfect solution for everything. Now I'm going to go through the equipment, and it can be as simple as something like this. This is a diver-operated airlift, and literally you pump air up from the bottom, and as it travels up the tube, it pulls up water and sediment, and you can trench with that. And on the right is a diver-operated jetting sled, about the size of a small car, a mini, not very heavy, not very powerful. But the point through all of these next slides, it's about selecting the right tool based on the ground conditions. And the ground conditions means the type of seabed you're in. It might be sandy, it might be gravelly, it might be rocky, it might be chalky. So you have to be aware of that and aligning that tool with your burial and permitting requirements in the safest and most efficient way you can to meet whatever your project objectives are. As we move up a scale a little bit, these are typical telecoms machines designed for about 2 metre burial. On the left is a pretty standard jetting sled. This is a positive cable placement machine. So what that means is the stinger, once the jets are running, rotates downwards into the ground and it positively places the cable into the trench. So you've got a really good idea of where it is. And the machine on the right is the starting of what I'm going to call modular track machines. This is a small, lightweight machine. I think it was about 100 horsepower, not very powerful, but it was capable of having a jetting tool or a chain excavator or even a small rock wheel on it. So you can cope with a variety of seabeds. As we start moving up, we get into ploughs and heavier track machines. Cable plough is the typical telecoms tool of choice. And I particularly like this photo because we talked about the intertidal zone, and I think most people think about the beaches they know from holidays, and the beach might be 100 or a couple of 100 meters long, but sometimes that intertidal zone can be 3, 4, or 5 kilometers long. So suddenly you start to have to think about how you're going to manage your operation over days or even weeks to be able to make progress. And the photo on the right, that's a rock wheel cutter. So again, that's a telecoms machine, but you can see machines are getting bigger and more powerful, heavier, and more complicated. Moving on from there, we're now getting into the heavier power cable machines. At the time it was built, the T3200, that means 3,200 horsepower. So we're getting into big 50-ton machines. They're really powerful. And this is capable of 2 or 3 meters burial, depending on the seabed type. It'll come with a jetting option, a chain excavating option, or a rock cutting option. And there's pictures of people on them. So you can start to get a feel for the scale of the tools that are required to get power cables buried. But that's not the end of it. They get bigger still. And the picture on the left is a big track jetting machine. This is a 5-meter tool, and that's the sort of size of machine you need to cope with the power to achieve burial in the depths that are being prescribed. So as a mechanical engineer, it's great. I love these sorts of equipment. They're fabulous. I'm almost going a full circle, because when I started, I was fascinated by a job out in Asia where they were burying cables to 10 meters. They were using a vertical injector. I'm now involved with some wind farm projects where they're doing exactly the same. They're doing deep burial with a VI, but these are doing, they need about 20 to 30,000 horsepower of jetting power. So you're putting a huge amount of energy into the seabed to get the cable to the depth that you need. And we're here for cables, so I thought I would give you a little bit of a relativity diagram. This is typical telecoms cable. That's a lightweight 17 mil area, and that's what's sitting at the bottom of the Atlantic on the abyssal plains. Doesn't need anything else particularly. And that's the dot in the bottom right. As you go up, you get into a double armoured telecoms cable, and there's an example there on the table, and that will be left out on the table. I'd like you all to pick that up and feel how heavy it is. That's less than 10 kilos a metre. So it's quite a heavy product, but when you compare it to the power cables that are going in, it really is quite small. So telecoms, you're looking at 10 to 50 mil, size of my finger to a couple of inches. 1 to 6 kilograms is quite standard. Once you're getting into power cables, where they're from 100 to 300 mil, especially the HVAC cables, these cables can be over 100 kilos a metre. And I weigh 85, so if you think of that compressed into 1 metre, it's a big, heavy product. And the knot that's there on the table is to remind me to tell you that cables are complicated. Whatever cable it is, torsion is a real issue. It's very easy to say, lay a cable flat and level on the seabed, but it's a really hard thing to actually achieve. So even with a lightweight cable in deep water, it's difficult because the cable has a memory and it causes faults if you get it wrong. And then moving on up into HVDC bundled things, you're now starting to try to bury 4 cables in a single trench. And all these cables have got to be able to move relative to each other. One can become over tension. You've got huge amounts of power transmitting through them. They're really large, they're really heavy, they're really stiff. MBR stands for minimum bend radius. They need really big kit to be able to handle. And both the HVAC and DC, they're not as robust as a telecoms cable. So in telecoms, you've got the fibre package in the middle, surrounded by some wires, and that makes it a really strong mechanical product. the HVAC, you've got 3 cores that are coiled together. So you've almost got 3 springs. And once you start putting tension on them, they need to be able to move relative to each other. We start to break 1 or 2 of the cores. So just wanted to start to think about the mechanical aspects of the cable itself. So, how am I doing on time? In summary, for me, always work safely. And I'm going to say for 2 things. 1 for people and 2 for product. If it can go wrong, it probably will. And on a landing especially, where you're working with an intertidal zone, the water coming in and out, it's really prone to it. But the other message I wanted to get across is there's lots of similarities between telecoms and power cable landings. Basic requirements, the techniques and the equipment and vessels, they follow really similar principles. So if you're starting out in one sector, my message would be, don't be afraid of moving. There's lots of opportunities in both, and the world needs both telecoms and power. I was fortunate enough to be involved at the start of the digital age and building of the internet, but I think that's now just really starting to come of age with AI, and submarine cables are key to that. So it's really exciting in the telecom sector, but it's also really exciting in power. We all know global warming exists, environmental concerns are real, and power cables are part of that solution. So please, if you want to take a second message, it's a really multidisciplinary team, and moving around to give you the breadth is a really important thing. But once you've got past that, there are also differences. The scale, the size, the weight and the stiffness, it makes the product different, and how the cable handles different. And there are some environmental issues that come up as the power capacity of the cable increases. So, rightly so, there are regulatory or permitting issues to work with in the power sector. And complexity goes up between telecom and power. If I was to be honest, I think both sectors are complex, but power is supersized. So the key lessons for me is safety first to people and product. Look after your cable and it will look after you. That's the message that was given to me when I started in power. And it's only as I've gone on through the years, I've realised how important looking after your cable through the lay and through life is. In terms of landings, always do the engineering and base that on worst case conditions. You may plan to go in on a neap tide on a sunny day, but there might be an issue and you might end up doing the landing on a spring tide on a rainy, windy day. So always do the maths that goes along with it. And as I said at the start, nature always wins. So try and work with the natural forces where you can, not against them. And thank you very much.
Thank you, Richard. Got time for a question or 2, maybe? Anyone got a question for Richard?
Oh, we've got a question. And Dave put his hand up.
Dave, you want to go first?
I'll take the microphone.
Yeah, thank you. It was just a question. You showed a picture of the cable lay on the rocky shoreline, encased in the metal, like half shells. Would you have? What was the argument of doing that versus cutting it into the rock?
So, key difference between telecoms and power is budget, and that particular job was R100, which was funded by the Scottish government. And so we were guided by them, by their budget. And there was a requirement to get communications to the particular island it was going to, and there just wasn't any sediment. So we looked and we tried, and it was hard rock as well. It was granite. So I think it's worth talking about rock types a little bit. You've seen chain excavators and rock wheel cutters. The reality is it's really hard to cut through granite. A rock wheel is really designed for soft rocks like chalk or mudstone or sandstone. It's not designed for granite. So our end customer didn't have the appetite or budget to start spending those sorts of sums of money, and their time schedule was such that they wanted connectivity in a really short time frame. So yeah, if budget was available, we would have had a go, but the reality of it was budget wasn't available and it would have been really difficult.
Okay, one more question. I think the battery's run out on that, John. Yeah. Circular battery as well. We have another one. Another question.
Yeah, a question online. So I might steal the mic for a second.
Can you go,
Sorry. So we had a question online asking about in the event of a storm affecting the intertidal area and leaving cables exposed, would they be reburied?
Oh, that's a good question. I'm going to give you two answers. The first one is, and this is one of the hats I wore at BT, was overseeing that. We take things like that, or the industry takes cable exposures very seriously. I think telecoms and power will have slightly different perspectives on it. But from a telecoms perspective, if sediment existed, we would have a go at reburying it. But with one eye on our history of the landing. So we've got a team in Cornwall that goes out and does regular beach visits. And the call is generally the cable was buried, storms come in and wash the beach of sand. But if we wait a couple of weeks, the storm passes, the pressure changes and the sand washes back. So we'll probably try and work with nature and let it naturally restore. But we will put signs up on the beach to mark it as a trip hazard, etc. Power might think a bit differently. They've probably got more budget and there's more at stake in terms of security and risk to people on the beach. So they may want to spend more money and act a little quicker. But also, if they're confident of recovery of the sediments, they will probably wait too.
Okay. Thanks, Richard.
Thank you very much.
Next presentation is from Ben Limmer from Google, working with others, table crossings and interacting with third parties in the sea.
Cool. So this has been referenced a few times, I think, and it came up in the cable routing discussion. So hopefully there's a bit more context and fills in a piece of the puzzle, adding to what's already been discussed. So there's lots of different uses of the seabed, as we've covered. So a lot of those there are just sort of things that we come up against, and also that are key factors when planning a project. And also understanding in that desktop study phase, especially what we are sort of dealing with, what's on our route, what's on our, what we're going to come across as we go through a project. And a lot of these things are not avoidable. You're normally choosing between different issues as you go through a project. So as you discussed earlier, it's a least worst option rather than a perfect option transatlantic as those original cables did. So it's becoming more and more busy. These things need to be factored in, but also we're choosing our risks, or we're assessing risks as we go. So there's wider marine development and the spatial challenges, that's the routing decision, and then therefore these interactions are inevitable. We can't just avoid everyone. We have to work together to make sure that we're approaching these risks in a collaborative way, rather than sort of damaging other people's undersea assets. So before installation, this is a key phase of getting things underway as soon as possible, as has been referenced by the government authorities. Sort of the earlier you do these things, the more time that the process sort of has to come to a conclusion. And it's engaging with those stakeholders, working with each other to come to a joint solution that means that everyone's undersea assets can be used and monetized and aren't affected negatively by us laying, in most cases here, new infrastructure and conducting operations. So, yeah. So we have sort of laws and understood sort of conditions of how we go about this. So we're looking at sort of, yeah, how do we cross different assets, and then what are the industry standards? And this is where ICPC, ESCO, and other organisations start to govern and start to inform what we do. So here at the top, the crossing notification. So this is something that the telecommunications industry has sort of agreed jointly. I think there's sometimes it wavers from this, but this is the standard. This is the expected approach. So for crossing notifications, there's an informal agreement, typical, and it's a notification, sort of a joint understanding of this is how we're going to manage this problem, especially in more congested areas. And where we are then crossing other assets, we don't have this sort of broad industry standard. So this is a more bespoke crossing agreement that may well have a method of procedure agreed and understood, liabilities understood within that agreement, and then signed and agreed. This is probably a greater risk in terms of delay of a project than necessarily a no-go at all. These things can take a while to sort of reach joint understanding on. So it's not only a risk in terms of, say, someone saying, no, I don't want you to do that. It's more to do with conditions, cost, delays. A lot of the sort of understanding phase of, people giving very high demands, or say a pipeline owner says, I don't want you to do that. I want lots of mattressing. I want all the different methods that are used to sort of protect my asset. It's again coming to joint understanding. So there's risk in a few aspects of the project there. And then the final point, so proximity agreement, this could be at a wind farm or something along those lines, just understanding that we're close, and these are the conditions we're going to implement as we go through to manage any interaction. And so a wind farm owner doesn't go, why is this ship right next to my wind farm, for example? So it's sort of proactive engagement and working together to make sure that everyone's assets are protected on the seabed. So as I sort of referenced on the last slide, this is being kind of managed in the industry, working together in the forums, ESCA, ICPC, especially here. So the recommendations are good practice, and most people will follow these, and that joint understanding, that industry collaboration. So then you have the guideline 6, if you want to continue researching in your own time, that sort of outlines the collaboration between the cable industry, the offshore renewables, regulators, government. And again, it's an understanding thing. So a lot of discussions with permitting agents, or they'll think that the telecommunications cable is this huge thing when it's this smaller thing. So therefore, the sort of building the understanding, putting that in place, and making sure that we can work together, sort of understanding what we're actually dealing with, not these hypotheticals that may be sort of preconceptions in different people's minds. So yeah, that final one. So industry practices globally. So trying to have that whole industry view, and then sort of driving that work with other industries as well. Again, more sort of documentation, helping us have reference points for this. So again, ESCA publishing guidelines, NFFO, SFF. So again, good practices, recommendations, things that can be referenced in these discussions as different asset owners are trying to manage the protection of their own asset, and whether it be fishing as well, as an example. So fishing there, fishing liaison important. And again, this is something to manage proactively as sort of asset owners, to make sure we're not offending, causing issues, therefore setting projects back in terms of timeline and feasibility. So just to conclude, so the key bit is working together, being proactive, being upfront, and making sure that the discussion that we're having is the discussion as to what we're doing sort of practically within a certain space, and managing that seabed use collaboratively, not just within telecoms, but within telecoms and the other industries. Power cables, I'm sure, is very, very similar. So they're using the guidelines, industry practices worked on by the cable industry, and these governing bodies, collaborative industry bodies, and then for the other activities there as well. And it's important, sort of reiterating that top point. So everyone, collaborative use, shared use, events like this where information can be disseminated, understood, and then sort of moving forward together as we manage and use a more and more congested seabed. I think that's everything from me. Thanks, Ben.
Could you speak up a bit, because we're lacking a microphone.
Yeah, that's fine.
Yes, it's just in relation to engagement with asset owners on crossings. If we are getting low engagement from an asset owner and it's getting quite close to construction period, have you got any mitigation methods or that you suggest that can get those agreements in place, basically?
Just the question was, what happens if there's low engagement from the asset owners? I think this is an issue. That was sort of what I was trying to reference in terms of it's a timeline risk, not just a sort of feasibility cost risk. I think your legal team might be the one people to reference in that. So I think it's a risk-based sort of approach, understanding maybe why they're not engaging. I think from I've generally worked for like purchasers so it'd then be a case of sort of encouraging the supplier to up that engagement and look at new ways of sort of creative ways of getting in contact. I think your business will decide and what it wants to do in that situation. I don't think there is a sort of standard approach unless it's not covered under any of the guidelines. So John's shaking his head.
Okay, thanks, Ben. Okay, last presentation of the day, last but not least, of course, prior to the Q&A session, we'll have thank you target of Vodafone in terms of timing in subsea cable projects and understanding its role in project success. Over to you.
Thank you. Hopefully you'll be able to hear me. It's a bit closer to the mic down here. But so I am Frankie. I work for Vodafone. I'm a submarine cable engineer, and my role is in operations and maintenance. So I look after our subsea network and make sure it stays running and fix it when it breaks. And I'm talking a little bit today about timing in subsea cable projects, its importance, sort of the main factors that can impact before and after install, talking through how to mitigate those things, how it influences other stages of a project, and also increasing the operational efficiency through doing that, and sort of the butterfly effect of scheduling within subsea projects. So we'll start with one of the biggest ones, which is permits. So it's one of the biggest influences within scheduling within a project. So permit timelines can vary geographically. So it depends on the regulatory body that you are applying through. They give you a typical statutory timeline when you submit your permit for the period that it's going to be approved. However, these timelines can vary, and that is not really indicative of the process. So what normally happens is that you get feedback that something needs to change. You might need to go do additional survey or submit further information, which halts your timeline. So therefore, your initial 20 days ends up being 2 months because you've had to go back and do further work, which then influences the rest of your project. So regulatory bodies can also implement changes between permit approval and installation, and this was touched on earlier by Aquacoms and in the Irish EZ. So we had a situation on the To Africa project where during install of To Africa, the Irish authorities changed the regulation on the EZ where we were routing through, and that meant that we had to sort of reverse and change our install process to allow time for us to fix that situation, shall we say, and then come back and install at a further date, which obviously then influences the rest of your install plan. Permitting can also be dictated by sensitive restrictions, often driven by fishing, wildlife and tourism. So your permits can only be valid at times where certain species aren't present or outside tourist seasons, which often means having to stand on a cold British beach rather than standing on a nice warm British beach. So that all influences when you can install and your project planning. So these restrictions and delays can cause project postponement, which then influences other factors that we will go into. So a good way to mitigate things like this is consultation, which echoing everything that's been said today. The best way to avoid unplanned changes is always early communication. And again, touching on what Ben's just been speaking about, communication with other seabed users. So often scheduling of crossing agreements and proximity agreements are essential for avoiding conflict with other seabed users. Communication with other users can influence your project planning, your route and your seabed preparations for final install. Some permits, so I know in the Mediterranean we are doing some proximity agreements where the person who's liaising with us, their proximity agreement dictates them getting a permit or not. So some permits can rely on agreements already being in place before you can even install. So having those timelines put in place ahead of install is really important. And not only is this important for the ease and ability to install, but it's crucial to establish communication with other seabed users for the life of the system. And this is something that affects me being in operations and maintenance. So avoiding conflicts on future repairs or future projects as well, ensuring that those lines of communication are already established. One of the main and probably the biggest thing within scheduling a project is vessel availability and weather. So this can be driven by multiple things: manufacturing of your own system and others, timeline of future projects, using a vessel that has a dual purpose. So if you're using a vessel that may be primarily used for, say, the telecoms industry for repair, it can have an off-hire season. So if you're using a vessel that is in its off-hire season, that might be a limited time. So if things change, your project plans change, that can be influenced with your scheduling. And then vessel requirements, some vessels require dry dock seasons, what you'll do, but if that is something that's in that year for that vessel, then you'll have to make sure that you are working your project around that, as well as the big one is weather. So delays caused by any factor that I've just mentioned have an influence on vessel availability, and pushing install to a further date due to permitting agreements can cause delays in vessel availability. It also can push the vessel use into a less optimal weather period. So as mentioned, we try and install our cable for the best case scenario, so for the best weather window that we can. But if something like your permitting holds that up and pushes you into a poorer weather window, then perfect planning, weather can be unpredictable. You never know what's going to happen. So that can influence your scheduling. I know for us that recently we've had to put a repair on hold for 8 months due to waiting for a correct weather window. So it really can influence things. So if you move one thing in your permitting and then pushes your vessel into poor weather, it can really affect the scheduling of the whole project. So management of subcontractors. So everything that I've already mentioned involve the management of subcontractors. Each delay has a knock-on effect to each individual subcontractor that you're involved. So projects can involve several subcontractors, so vessel owners, cable manufacturers, support vessels, project and permit managers, cable station engineers, specialists, all the ones I've listed up there, and many more. So here, a picture on the screen, this was the To Africa landing that was viewed in Cornwall this year. So at the shore end, we had to navigate most of the people mentioned in there, and we were delayed one day. We were still on the beach, ready to go, because the support vessel wasn't available. So we then had to delay by one day, which was manageable by one day, but we had all of those people. So the staff here, the people using the diggers, us on the beach, we had ESCA, we had all our marketing people ready to go, and at about 8 o'clock in the morning, and one vessel not being able to make it meant that we were delayed. And the knock-on effect of that can mean that your project timelines can be completely disrupted. If it wasn't one day, it could have been a few months, and everyone was there and ready to go. But there is a big snowball effect that can happen due to any sort of delay that can cause this to run a bit further than mentioned. And the reason why delays are really inconvenient is mainly because of financial implications. So delays in project execution can incur substantial costs, and these can vary from storing manufactured items. So if you're having to delay installing your cable and it's left in a depot or a storage facility for longer than required, you're going to be paying extra days for storage. If you have to, for example, you haven't got your permit in time and you're in the middle of install, you have to cut the cable, move away and come back. You're introducing a joint into the system. You're introducing more vessel time, and all of that means money. In the telecoms industry, if we delay the project delivery significantly and we've got customers waiting to use the system, we then have to issue service credit. We would then have to issue service credits to our customers, and then this is that's thrown me off. Sorry, that's all right. We issue service credits to our customers, again, leading to more financial consequences. So project timing can not only impact your end user, but also completely impacts the financials and the budget of a project. And effective scheduling can mitigate that and reduce delays and the associated costs, in fact, enhancing project efficiency and also customer satisfaction, which is a big thing for us in telecoms, and I imagine so in power as well. And so my message is to remember the 6 Ps. Proper prior planning prevents poor performance. But so I would recommend, as we've been echoing throughout today, the early communication, constant communication is always vital in this environment, but always be ready for the curveball that this industry is going to throw you. That is my message.
Thank you, Frankie.
I think it's got a point.
Any questions? Before we go into the Q&A section.
Perfect. Thank you.
You'll get some chairs out front. Clive, we'll do 15 minutes and then come back to the Q&A so we can sort out mics for that.
So we'll just have 15 minutes and we'll come back at 4:30 just so everyone can refresh, and we'll sort out microphones, which you might have heard us testing in the room during Frankie's presentation. So if you can be back by 4:30, there's no coffee or anything, but everyone can just have a quick leg stretch. This might only make
Nottingham gutted that you not try that. Right, is that working? So do you hear me through your thing? Yeah, is that loud and clear? Yeah, okay. So I think what we'll need is people to be loud in their answers.
Yeah. You're going to put that in the middle. Are we going to have, oh, you've got a row of chairs.
I wonder also,
I'm on the table, put that on the table.
that this is on red. No, yellow and green. Yeah, we do. Does that come through very echoey?
Yeah. If it's coming through both that and that, it'll be handy.
Yeah.
You want me to get one of those tables?
Yeah.
Table then behind it.
Yeah, should we do that? And then we'll try and do it through here. Who's on the panel?
Alice Ramsey.
Testing. Testing. Testing there.
Yeah. Should be nice. Yes.
So food is a six. Yeah, it'll be drinks at five. Food at six. That'll be water at six.
Okay. So we're now into the Q&A session well, we've got till 5:30, but see how many questions we get, because we do have a lot of questions on Slido that we could ask. But before we do anything else, can I invite four people up onto the panel? Hopefully they know they're coming. If not, you are. Pete, Lucy, Richard, and one more, wasn't there? Alice, wasn't it? Alice. Oh, Morris. Sorry, Morris. Did you know Morris? Okay. Okay, we've got a roving mic until it runs out of juice. And then if it does run out of juice during the Q&A, which it might well do, if you've got a question, you can come up to the podium and ask the question. And if we run out of questions in here, we'll go to Slido and try and answer some of the Slido questions. And for those people, particularly online, just to let you know, with the questions that have been compiled on Slido, we will be taking them back, grouping them together. Some may have to go to different people. Some may be very similar, but we would hope to send the answers to those questions out very soon after this event. So we do our best. So I'm not sure how many we've got at the moment, but we'll do that after today and compile them. Okay, so for the panel, has anyone got any questions for the panel? Any question you like just to ask the panel?
Well, I ain't got many steps in today. I want to walk around a bit. Me too. Back corner.
Right, you don't have to move far there.
Go on, just to get it started. How does Mara's imposition of permits in EEZ fit with UNCLOS's treaties around freedom of navigation and laying submarine cables? Anyone want to have a go?
Is that a question for Sandra rather than? Yeah. Sandra's still here?
I am here, but I'm not sure I can answer that from, because that's a much more political question. But I mean, certainly Mara and Mara are the implementator of the legislation, if that makes sense. They didn't set the legislation, that was the Irish government. We've had a number of discussions, and I know ESCA have been very heavily involved in this with the government, and I think they believe this is what they're permitted to do under UNCLOS. However, they are reviewing it at the moment because obviously from an industry, from a political point of view, and from a lot of other reasons, this is not what you would normally expect to see. But they certainly, when they looked at it, when they reviewed it, when they were initially challenged on it, they certainly felt that they were very much in line with what their obligations were under UNCLOS to actually, safe passage. And if they wanted to license in that regard, well, that was at their prerogative to ensure that. So it's a difficult one because, that is what their obligation is, and how they implement that is a state issue. But they are reviewing it at the moment to try and make it, well, maybe not getting removed totally, but a much more easier process if you're just transiting, and maybe more information gathering process. But as I said, we're hoping to see something on that very soon because it does have an impact on the industry.
Okay, thanks, Sandra. I think we've got another question.
Something to add here? Yeah.
Oh, yeah. Okay, sorry.
I'll just add that Mara and the act that they're working under is pretty new, and it's new for the Republic of Ireland. And we had a similar situation in the UK with the Marine and Coastal Access Act, and the MMO tried to implement a similar thing in regards to repairs. They requested that we had to ask for permission to repair a cable. But after we pointed out to them that that was not in the spirit of UNCLOS, they rescinded and said, okay, you can just notify us then, please. So hopefully that'll go the same way tomorrow.
It's a good point from the UK's perspective as well, in terms of continuing to review legislation or review the intention of legislation, as there have been these layers of frameworks that we went through this morning, ensuring they're still fit for purpose for now and for the future, especially when it comes to spatial congestion, not only in our sectors but also more widely. So it's something that we in Crown State continue to have to think about, is whether or not legislative frameworks are currently being implemented properly with respect to convention, or if there is other options for the future. So we're continuing to keep that under review.
Okay, thank you. I think there was another question in the corner.
This one mainly for Richard. Is there anything you recommend in the, I suppose, the pre-planning stage to mitigate against some of those risks when you do come to that critical cable pull-in arena? Is there anything you would suggest that can be done, perhaps years in advance, months in advance, that you would recommend that can mitigate against those sorts of risks?
So what risks are you particularly concerned with? That's environmental perspective or from the engineering?
Anything to help it go well and and run smoothly.
So a word I use a lot. So start early, and the word I use is optioneering. I did have a slide on it that I was thinking of putting in. There's always options and ways round lots of things. And if you start from an almost blank piece of paper perspective about what landing you should be choosing, there are generally options. And it's just a case of working out what those options are and assessing the relative risks. And a spreadsheet is a really great tool if you take a simplistic view to list your options down one side and then your factors along, and just start colouring boxes in, whether they're green, amber, red, or using numbers to grade them. Very quickly, you see what is a definite no-go and what's easier to work through. For me, the message that came out of the exercise we did is that there just isn't a perfect, easy route. You're going to have to compromise somewhere along the way. So it's choosing the easiest, least risk, most cost-effective route that you can, and then use the engineering to make the most of that. Anybody else?
Thanks, Richard. Anyone else?
Questions in the room?
Okay, cool.
Hi. So we talked about the environmental impact of the actual physical cables. Has there been any kind of thought about the whole industry? So the cable ships, like manufacturing, how that affects the environment, how that's mitigated or thought about?
Hello, thank you for the question. In terms of SNCBs, we look at the whole operation and the whole installation. So that will include looking at vessel movement, vessel transiting to and from ports, and whether there's any disturbance to a particular species. Red-throated diver is a particular one that we're concerned about. In terms of the manufacturing of the cable, that's not something which we would look at. But I guess there's probably other targets within government, carbon neutral, that may put that into, I don't know if someone else would know more about that.
I can say a bit from the Curtin Estates perspective in trying to bring more sustainability factors into our leasing to drive certainly things like Scope 3 emissions, where we can use our seabed leases to try and extract that information in terms of cable manufacturing and source of origin, etc. So increasingly, these are things that we're trying to introduce into our forward thinking for seabed leasing.
I mentioned whether it's proportionate to the activity, and I think that's a key thing. I think most of the people in this room are understanders of global warming and wanting to change things and electrify the nation, which I think is a really good mission to be on. But the hard reality of the engineering around it needs to be taken into account too. You need a lot of energy to smelt steel. You need a lot of energy to drive ships and hold position. So I think it's going to take time. And I think it's right that we are developing and pushing change. But it's going to take time to do that so that it's cost effective and industry can keep up.
Yeah, I think it's just a massive question. You have to look at every single aspect of the sector. You know, the manufacture of the cable, the installation, the operation, the maintenance. But then you also have to factor in all the things that's taken out of the system, or the flights that haven't been taken because people don't need to fly because they can use the internet, or the other journeys that have been taken out. So it's a wide-ranging question, and I think you could probably do a doctorate on it if you wanted to. But I think it's too big a question. Yeah, I do know it. Certainly on the shipping side of things, I know the newer ships are certainly a lot more fuel efficient, using greener energy, greener fuels. But yeah, there's a lot of things to consider in that question.
Okay, we've got quite a few questions on Slido, so John's just going to ask one or two.
Yeah, so we've got a huge number of questions on Slido, ranging from environmental, technical, security related, all sorts. So I'll pick a few, but I apologise to those online and who've asked questions in the room. We won't get to them all, but we will answer them after the event. So just picking from a selection here. So we've had a good question. Is there, and this might be to Richard and maybe Peter first, is there an opportunity to share repair vessels between telecoms and electricity cables, or would it require too many modifications to make that viable?
That has already been done. So I know Orsted was a member of ACMA for a period, and they were using Sovereign. So she was modified to power cable repairs from astern and telecom cable repairs from the bow. But I think it's getting an understanding of the product, and that they have different requirements and different requirements of the ship, and they operate on different models. So at the moment, I think someone mentioned today that a typical telecoms repair is about £1 million, and a typical power cable repair is about £10 million. So organisations cover that risk in different ways, and generally the power cable sector will use insurers to help them cover that risk because it's a much bigger number. And so that kind of drives the whole model. And if you try and get those assets on standby, they're really expensive, and you need the kilometrage in the agreement to make the agreement like the ACMA, which the telecom sector uses, pay. So there's a big difference spreading the cost of a ship over 100 systems at 3,000 kilometres than maybe 3 export cables at 100 kilometres. So the economics has to drive it, and ultimately industry is business, and the numbers will drive those decisions and the frequency of those repairs. So I think they are coming closer together. They have worked together, and in time, I'm sure the power cable sector will have the kilometrage to make it cost effective enough to pay for ships on standby. And there are agreements existing. I think there's one in the Dutch sector with a Dutch contractor on standby for the Dutch TSO Tenet. So those things are developing, but the telecom sector's been managing a high volume of repairs for a long time. The power cable sector is catching up, and they really got going with offshore wind around 2005, 2010. So there's a lot of catch up to be done.
Super. No, I've got some more to go. So I'll do a couple more technical, then I'll come to environmental. So these might be quick fire questions, and again, actually might come to you, Richard, or maybe to somebody else in the room because they're on cable engineering. There's one which is just what's meant by slack planning, and when crossing cables, why do we cross at 90 degrees? So those two grouped together might be two reasonably straightforward.
Okay. I'll do crossing first. That every sector has a different perspective. Telecom sector, I think the 90 degrees originally came from distance to repeaters, so that you're maximizing the distance to repeaters, and the repairs were easily possible. When you get into power cables and telecoms cables, at 90 degrees you don't get induced voltage effects, but as the angle goes down, you start to get an induced voltage effect. And when I was in a previous role with BT, we did some studies, and once you get down to the very acute angles, maybe 30 degrees, those voltages can become significant. So from a telecom to power perspective, it keeps those impacts at a minimum. And then from the cable slack, I don't know if Alistair wants to mention or answer that one. Where is he? He's still here. Do you want to talk about slack?
The question was just straightforward. What is meant by slack planning? So just to explain.
Thank you, Richard. So slack planning would be if you plan your initial cable route, you do a survey of the route, which, as we spoke about, identifies sort of gullies and depressions and dips within the seabed. But within those depressions and stuff, you may need to install a little bit of additional cable just to make sure that you minimise the risk of suspensions. So usually in the deep water, usually in the deep water, we do about 3% slack. So if we have 1,000 kilometres worth of cable, so say, I mean, that's a reasonable distance when you're talking about an intercontinental system. You'd have 1,030 metres of cable. And that's just to make sure the cable lies down neatly on the seabed and nestles within the depressions and the gullies noticed on the survey data. And also you don't want, if you get a suspension, you're much more likely to have a cable fault or a failure. So I think that should answer the question.
Yeah, thanks. And maybe keeping the mic in that part of the room, the next question is actually going back to our survey presentation. If Andy, if you don't mind taking a question, it says regarding utilisation of smaller unmanned survey vessels, what's the working parameters or working limits for the vessel offshore, and is there any difference in data quality in data acquisition?
Yeah, I think for the ones that are being used for the inshore surveys, that they are more susceptible to bad weather conditions. So probably looking at about sea state 3 to 4 being the upper limit. So that's more restrictive. For the deep sea ones, again, possibly reduced a bit. I'll share some more details on that at some optic, hopefully.
John, can I just carry on from Alistair a little bit? So when I was learning about slack, the analogy I was given was called the bathtub analogy. If you can imagine you're laying a cable from the UK to America and your ship steams along the surface, the seabed goes down and along and up at the other side, and you could, at a very coarse level, imagine that you need slack of the cable to fill the depression along the bottom and up. But like all of this, we're scratching the surface. There's lots of different types of slack. So there's fibre slack within the package. The cores may be tight or slack within the power cable package, but most people refer to slack to make sure that the cable is laid so it's flat and level on the seabed, following the profile, and the residual tension that's left in the cable is appropriate for that product, whatever that might be.
Super, thanks. And I'll come, so if anyone else has a question in the room, please put your hand up. not, I'll come back to slide. I'll carry on. Oh, do we have a mic?
Right, thank you. There's a question about cooperation and noting that the UK is saying about spatially squeezed and the barriers of MPAs and other sort of protected zones around the coast. Has there ever been put forward a more sort of coordinated effort to perhaps have hubs at a distance from the shore? Because it feels like everyone's trying to build bridges across the same river, and you're ending up with a lot of the same problems being addressed. When actually, if there was sort of national infrastructure, noting that would there'll be issues with commonality and potential vulnerability in that. But having national infrastructure that got you through that initial couple of miles into these popular landing spots, and then a hub that people could then sort of plug into out at sea, and address this costly and complicated process of everyone attempting a shore landing. I was just wondering if that was, I mean, clearly it's okay.
Thank you. No, that's a really good point, and I think there has been some efforts with coordination. I think it's in Peterhead up in Scotland. I think you talked earlier, and it's something which I think would be definitely worthwhile looking into. I think in terms of the hubs, are you sort of referring to these energy islands? That I think there's one proposed in Belgium at the moment. I don't understand the technical side of it, but in terms of the cables, it's having the technology within the cable to transmit enough energy in order to reduce the cables that would then go to landfall, if that makes sense. So if you can have a mega cable that would be one cable coming in, that would be amazing, but I don't think the technology would be there.
Common ducts that were routes that meant that like the fishermen, for instance, there would only be one problem to deal with, noting that we're already, the horse is already bolted essentially, but for future planning.
Well, we do, in terms of SNCB advice, we do always ask that if there is a project that's landfall at a site, that if they can include ducts within that proposal, so then any future cables can then enter the landfall, without causing as much disruption. And that's something which does happen at the moment, but it's just on a smaller scale, I guess.
And if I may, in terms of bringing assets closer together, there's some differences, sectoral differences as well there. One of the principles of the industry is having geographic diversity. So making sure that you have literal physical separation between assets. So if anchors are dragged or fishing vessels are, there's intense fishing in an area, you don't lose multiple assets at the same time. So it provides some resilience in the system.
I was just going to say what John just said to you.
Sorry.
Well, it's the same argument that people make with cable corridors. Why we all go into different places? Why can't we just have corridors like that in Australia? In Australia, it's a very different case because their corridors quite wide, but they're also very heavily policed. And whereas we've been laying cables around the UK for since the 1850s, and we've got lots of different landings all over. So I prefer to have a corridor across every individual cable that was fished over rather than put us all into one.
Yeah, I mean, my angle was, I guess, predictably about security, and it's easier to not only would it be cheaper, but easier to defend. And safety in numbers, that you've got a landing spot that at least that you can upgun that than having multiple small ones.
Yeah, I mean it's a subject that comes up all the time, but it's also, say it's easier to defend, it's also easy to hit. And if you've got a government that's not willing to tell fishermen that they can't fish over cables, because they're not. Governments aren't willing to do that. So how are they going to protect the cables? That's the issue.
Security is obviously a really key thing. It's in the press at the moment, and we've we've talked a lot about machines and equipment. But for me, and I think maybe Peter or someone else said, the key is burial. The deeper you bury, the more secure it is, out of sight, out of mind, and hard to get to. And we are now having to use machines that are really quite substantial to get to the depths that we're sometimes regulated to get them to. So you can imagine it gets a lot more difficult to reach. But that comes at a cost, unfortunately. So, you know, real world comes in, and who wants to pay for it?
I was just going to add a bit about system planning generally, I think, and there are different organisations and roles and responsibilities between the power and telecom sector. Obviously, increasingly within the electricity industry, we are moving and have moved towards a more centrally planned system. You could hopefully see from the diagram that Rona spoke to earlier about what the National Energy System Operator is planning. A lot more offshore power transmission than there was 10 years ago, 5 years ago even, being planned. But it's being planned, or it's being envisaged and delivered in a coordinated way, potentially. And I don't know what the parallel is with the telecoms and data sector in terms of that central planning and organisation need. I think both sectors have evolved from being quite market-led, developer-led, customer-led. We're like that as an organisation, trying to support individual customers and sectors' needs. That's got to a point where it's really problematic to do on a coordinated basis without taking a big step back and looking at the seabed, certainly from a more strategic perspective. And that's what we're starting to do with the Crown Estate Scotland teams, to look at the UK more holistically in terms of where there could be solutions such as safeguarded areas, for example. That may not be the outcome, but at least we need to start thinking about how lots of different sectors can exist together in the same space, looking out to 2050 and beyond. I think one of the challenges is that we've got a central planning organisation, or a system planner basically within the electricity system, not to the same extent in the telecom system, and that's one of the challenges that we face, I think, certainly with our teams, and Alice leading with telecoms portfolio for the Crown Estate. That's one of the challenges that we have, is where does that central planning role come from to give that forecast of where that future demand is going to come and go to, in order that we can make cases to government that there should be sea space and seabed allocated for cables. That helps.
Okay, we'll come back maybe to a couple of explanatory questions. I'll come to Lucy first, if I may. So there's two which I'll group together. So what is a priority marine feature? What does that mean in the context of protection versus protecting MPAs? And maybe it's better to talk about protection that happens outside of MPAs as well. And another relatively explanatory one, what is sub area and why is it protected?
Okay, so a protected marine feature would, outside of an MPA, would be something like an Annex 1 habitat, which would include biogenic reef, which then goes on to suballaria. So suballaria is a Ross worm. It's a ephemeral species, so it is very likely to move, which is the problem with it. So you can survey for it, and there's also potential for suballaria as well when you do a survey. So not just looking at actual suballaria reef, you're actually looking at potential for suballaria to recover within a certain area as well.
Super. So if we come back, maybe this is one for Peter to take next. Is there a particular strategy in the cable industry for working with and engaging with the fishing industry?
Yeah, yes, there is. Yeah, I mean, as been said earlier today, the key with the fishing industry is early engagement. I mean, speak to them. Might not always be very welcome, but speak to them, garner information off them, plan your system as best you can to avoid their fishing grounds. But we also use things like the KISORG program, which I'll talk about tomorrow, which we got there and we give them the position of the cables, we even install it onto the plotter systems, and I think I'm right in thinking that the amount of fish-related instances around the UK has reduced over recent years. I think that's due to better installation of new systems, older systems being taken out of action, and also there's been a big increase in use of AIS monitoring now. So we monitor the fishing vessels if they've got it turned on around the cables, and ask them not to fish over it. And yeah, I mean, but I think the the biggest problem is it's not illegal to fish over a cable, and the government have sort of left it to the cable industry and the fishing industry to sort out between ourselves. And so there's a lot of engagement. There's the flow program that was on before, where we sit down and we've put together guidelines. ESCA, we've done our own guidelines in regards to fishing over cables and how close they can get. So yeah, there's a lot of engagement, and I think that the best way is to talk to fishermen. I think for a long time it's been very adversarial, and I think that is changing now. I think the fishing sector has realised that they're getting squeezed by the cable sector and all the other marine activities, and got to find a way to work with us, and we've got to find a way to work with them. So, yeah.
And while we're on the topic of sectors working together, maybe a question for Morris. There's quite a specific question about during leasing rounds, how does the Crown Estate manage any potential conflicts with the leasing activities of the North Sea Transition Authority? But maybe it would be easier for the audience to talk about how Crown Estate generally looks at conflicts and managing proximity and interactions between different sectors on the seabed.
Yeah, that goes to the heart of a lot of our activities, really, because we do. I think we have certainly well into the 20s number of separate sectors that we try to provide for in terms of access to seabed, whether it's aggregates and minerals, mineral extraction, whether it's a cables-based sector, whether it's wind, whether it's tidal, whatever. There are a number of sectors we try to provide for, and our sort of spatial planning capability has increased over the years, and that's understanding that in a GIS type based format to try and understand where there could be conflicts from the sectoral needs, but also from the seabed space and environmental needs. So our approach to leasing rounds, where we've got structured leasing, is to use our spatial planning tools to identify appropriate areas, what we call potential areas of opportunity for each sector. Let's take wind, for example, and gradually narrow down through both tools but also stakeholder engagement to try and understand the appropriateness of space that we want to propose. So it's a highly collaborative, a highly stakeholder-oriented process. It takes quite a long time, but we have got a team in our marine business. We've got Oscar here, for example, one of our marine spatial planning managers, who sort of take those processes forward and make sure that stakeholder input, many of whom are here today, can be taken into account, so that we know that seabed space can be appropriate not only for stakeholders but also for the investors and developers that we want to attract.
Thanks. So I'll look around the room for any more hands, and can we pass a mic?
Thank you. It's more of a follow-up to the question of dealing with fishermen and subsea cables infrastructure. As was mentioned, obviously there can be some altercations between industry and fishermen. HM Coast Guard of our functions as VCM. We are contacted by industry, BT Telecoms, when we have fishing vessels operating over their cables. If we're contacted and informed about it, we will warn off fishermen they can't move within 0.25 cables of subsea infrastructure. Basically, contact the VHF to move on, and 9 times out of 10 they will. Not all members of the industry do so, so we're trying to put that word out. If you contact us and let us know, we do VTM anyway. So if you contact us in our ops room, we will make that warning on your behalf, and if they do refuse, it can be logged and taken further. Thank you.
Any more for any more? Or I'll maybe do one or two more from Slido and then we'll call it to a close. Yeah. I can't see any hands, so if anyone shoots their hand up after the next question, then I'll take that. So this one maybe it's directed towards JNCC, but it might be one more appropriate for Lucy. So I'll let you decide who wants to answer it. So in regards to future environmental opportunities and in future environmental policy, specifically talking about intertidal marine net gain, what are the timescales for? It might be better to characterise this as what is net gain first, as a starter, and then what does it look like in terms of marine net gain for power and telecoms cables, and how can the sectors prepare? But I think it's quite a complex topic, so maybe start with what it is.
It's a big question, because we have biodiversity net gain, which comes out to mean low water, so that will impact the intertidal, which is currently in place at the moment.
And just to go back a step, what is biodiversity net gain?
Biodiversity. It's, well, I describe it as the cherry on the top. So it's outside of the mitigation hierarchy. So you go through the avoid, reduce, mitigate, and then compensate. So net gain would be on top of compensation. So it has to be considered outside of the normal process of mitigation hierarchy. So it's just making the most of opportunities. So like inshore, it would be things like, it's really difficult because it's very, there's a lot of questions that have been going around today about external rock protection and whether that is net gain, and potentially outside of the MPAs and not on sensitive features, that could be considered as net gain. But if rock protection was put down and then there was colonisation on that rock protection, but we wouldn't call that net gain within an MPA at the moment, because it would be seen that it was a different substrate to what the MPA was originally designated for. So quite often it would be on a sandy, subtidal sand. If you put rock protection on there, it's going to change the whole feature, and then it's classed as habitat loss or a loss of extent of that feature. So I don't know if I've made any sense there at all.
No,
It's getting to the end of the day and it was an early start. So I think it's really.
Are there any examples of net gain, just to sort of explain to people what that concept is of leaving the environment in a better condition after the project?
Well, it is, you want to leave the environment in a better place than it is for the future generations. I mean, that's really what we're trying to aim to achieve. And I think, it's difficult because a lot of emerging policies coming from DEFRA at the moment, and one of them is marine net gain. And I think, I'm not sure what that is going to look like at the moment. That's not something that I'm involved with in my work. It's just, I think for me, it's more sort of recovery. So if you can recover a habitat that has been degraded for some reason, that restoration, you're improving the overall net gain for a particular species or habitat. I don't know if Paula's got anything to add from a JNCC perspective. Okay, thank you. But yeah, it's a big topic at the moment.
An early policy. Yeah. Okay, so I'll look around the room for any hands. Oh, on there, run a mic over.
My question's actually for Paula. So I noticed that one of the products from the JNCC was regarding marine noise. And my question relates to how that's monitored and in which kind of context, whether that's just simply for like seismic operations, piling operations, or geophysical surveys, or whether we're also monitoring vessel noise and how we're dealing with that in the cable industry specifically. I wasn't sure you were. Thank you.
Thanks for that question. I think the Marine Noise Registry is, I think it's voluntary. Well, we request for any noisy activity. So I think it's low frequency activity. I can't remember what the threshold for that is now. There's below a certain frequency, then that is potentially damaging, particularly from mammals. So we have a concern about that. So we gather information on that kind of information. What's the rest of your question?
So of course, the seismic and piling operations, of course, we have the JSC guidelines in place to make sure that marine mammals are protected. However, my question relates more to shipping noise and whether we're also monitoring that.
Yeah.
Are there any plans in place to implement guidelines for vessels and how we reduce it?
Okay, thank you. So shipping noise is sort of chronic noise, isn't it? And background noise. I think there were some new guidelines issued last week in collaboration with DEFRA for UXO and for underwater noise generally. I don't know, I haven't read those guidelines yet, so I'm not sure if they cover continuous noise. But yeah, I think it's definitely something people are aware of. So. Thank you.
And while we've got the mic over the side of the room, this might be a question for Matt Trull. So how long is a typical cable section before a joint is introduced? Maybe some sectoral considerations too.
It depends on whether it's power or telecoms cable and the capacities of the ships laying them and the size of the cables. In an HVDC power cable, around about 100 kilometers can be considered normal. In an HVAC cable, it's typically a bit shorter because the cables are much larger and therefore use up more space and more weight on the ship. So maybe 40 or 50 kilometers, so it's very different between different HVAC cables. And they tend to be a lot shorter as well, so joints are relatively unusual. And in telecoms, it's normally how far is a repeater apart, which might be, again, 100 kilometers might be a rough guess, but I'll defer to the much more knowledgeable telecoms people from.
Yeah, I think you got it right. It's usually in repeater spacing. All right. Yeah.
From our perspective, I guess it's down to the different suppliers and their manufacturing capabilities. There's a number of people from Alcatel here. The telecom sector, they will make their cables in sections and then joint them. And then there will be a repeater on a long haul system. I don't know what the current spacing is, maybe 70, 80 kilometers or so. But the power cable sector really doesn't like joints. They're prone to failure. So they want to try and maximize the lengths as much as they can, but they are physically constrained by how long the factory can make the lengths in and the size of the vessels being used for the install.
Okay, I'll look around the room for any more hands. Frankie. We have Richard, Mike. Do you want to come?
We've got a lot of early career professionals here today, so I kind of want to ask a bit more of a fun question. So what is the most surprising or unexpected thing that you've encountered during your time on a subsea project in your relevant sector?
That's easy for me. The people. I've met so many amazing people over 30 plus years, and every day I go to work, I learn something new. So that's, for me, an easy one.
I suppose the most surprising one was several years ago when I was sat at my desk at work and the phone went, and I opened up the phone. He goes, "Hello, my name's Commander," whatever his name was. We've just been doing a routine sweep of the area and found there was a mine next to your cable, so we're gonna detonate it. And and just thought we'd let you know. I said, "Oh, okay." I said, so I had to tell the knock. Said, "Well, they're going to blow up this mine. What's going to happen?" He goes, "Well, sorry, it blows mainly outwards, so your cable's quite a few meters away, so it shouldn't really be a problem." So okay, so I told everybody at work, and left it for a day or so. But nothing happened, so I contacted the Navy again. I said, "Have you detonated this mine?" And he goes, "Oh no, we sent the ROV down, but it broke down, and so we just left it. We haven't got enough time on one to go back into it, so it's probably still there."
It's a hard one to follow. I think for me, it's just because I know I'm guilty of it, kind of work in silos, so I'm very much always have my environmental hat on. I always think it's really refreshing actually to get lots of people with different experiences, with different remits in a room and have those discussions. And I think they're really worthwhile because quite often you find you're all kind of going for the same result, but just in a different way. And I think it's a really good learning curve actually to have these kind of events. So that's my say to that.
Mine's quite similar. Some of my career has been involved in interconnector development, and I think the extent of collaboration between countries, multi-jurisdictional collaboration has been fantastic. That gives you exposure to, especially in Northwest Europe, and trying to break down barriers. It's got harder since 2016 in reality, but that's been one of my highlights, is how we can develop these quite complex cross-border projects and working with people, to your point, to make these sort of complex projects happen is fantastic.
Super. Thank you all. I think that's quite a nice note to wrap up, unless anyone else has anything else. And if not, join me in a round of applause for our panelists, and thank you very much.
Okay, as John said, that's for today. We have the Q&A. As I said earlier, the other questions online will be answered in due course once we've had time to have a look and group them into similar questions and send out to the relevant people, or just answer it ourselves. So yeah, it's the end of day one. Hope you've enjoyed the presentations and discussions. For those that are attending the awards evening tonight, it starts around about 6, maybe just before. Yeah, so we'll have drinks at 5:30ish, something to eat down there, and the awards start around 6:15. And probably end between 7:30 and 8 for the evening. So yeah, so for those not staying, have a good night, and see you tomorrow morning. Thank you.
So for those of you that haven't been here before, for the award, signs for it, but a few of us will be dotted around to help you get there. Otherwise, this building's a bit like Pac-Man, and you'll be chasing people around. So hopefully we get 80% of you there. That'd be good. Thanks.